Dear students, so now we are going to start the next topic of simple harmonic motion. So, before trying to understand what is meant by SHM, simple harmonic motion, so first let us try to understand what are the different types of motions which are present. Then we will come to understand what is the speciality of this simple harmonic motion. Clear? So, if I study about types of motions, then generally we know the different types of motions. First one is translatory motion. Clear? So body moving such that finally displacement of the body is a straight line. So such type of motion we call it as translatory motion. And second type of motion we know circular motion. If you take a stone, tie it with a thread, move it in a circular path, then it can be called as a circular motion. Rotational motion. So a rigid body moving around an axis, this we can call it as rotational motion. And one more type of motion is oscillatory motion. And if the amplitude of oscillation is very, very small, same oscillatory motion we can call it as vibratory motion. And it can also be called as harmonic motion also. Clear? So these are the different types of motions which we know. So what is meant by oscillatory motion? Moving to and fro. To and fro motion we can call it as oscillatory motion, vibratory motion, or harmonic motion also. So I start from here, there, move up to here. So I am moving in the same path to and fro. This is called an oscillatory motion. Clear? Next, all these motions, they may be periodic, they may not be periodic also. Clear? Now the question is, what is meant by periodic motion? So periodic motion means if a motion is being repeated after regular intervals of time, then such motion we can call it as periodic motion. For example, what is the meaning of this one? For example, if I take a person who is traveling in a circular path. So he started from point A, he traveled throughout this circle and reached the same point in a time of 10 seconds. Then I observe that after every 10 seconds he is able to complete one motion. Then it means that a motion is being repeated from the same point after regular intervals of time. So such type of motion we can call it as periodic motion. Clear? Now, for example, if I take a function f of t is equals to sine omega t, where omega is called angular frequency, clear, which is also can be written as, so sine 2 pi by capital T into t. I can write like this also. Clear? So f of t is equals to sine omega t. So if I should draw a graph of the amplitude of this or the magnitude of this function with respect to time, then how can I draw? We know sin theta values, how they change. So sin 0 is 0 and sin 90 is 1. Clear? So minimum value is 0, maximum value in positive direction is plus 1. Then again from 90 to 180 value reduces. Then 180 to 270, again it further reduces. So this is how sine value changes. Clear? So therefore, if I draw a function of this sine function with respect to time, then how can I draw? Then I can draw a graph like this. So this is how the value of the function continuously it changes. Clear? So this is a time of 0. Then this will be after a time of t by 4. This will be after a time of t by 2. This will be after a time of 3t by 4. And this will be after a time of t. So this is how it completes one cycle after a time period of t. Clear? So now the question is it a periodic function or not? Definitely it is a periodic function, because after a time of t, body has again started movement from the same phase and from the same position also. Clear? So this type of motion also we can call it as periodic motion. Motion should repeat itself after regular intervals of time. So after a time of t, it is again repeating its motion. Similarly, if I take one more function, for example, if I take f of t is equals to cos omega t. Now is it a periodic function or not? Definitely it is a periodic function, because again the values of cos theta, they change from 0 to 1. Clear? 0 to plus 1 to 0, and again 0 to minus 1 to 0, and again 0 to plus 1. Clear? So these values, the change between plus 1 to minus 1. So cos 0 is how much? Cos 0 is maximum, plus 1. Clear? And cos 90 is how much? Cos 90 value is 0. So therefore, if I draw again the change of displacement of the particle which is following according to this function, then I can draw the graph like this. Clear? So this is what happens. So at a time t is equal to 0, so this is the time. So at t is equal to 0, where is t is equals to 0? This point. Then its value is maximum. Cos value is maximum. Now the question is it a periodic function or not? Definitely it is a periodic function, because again after a time of t, again it will repeat its motion. So here what is the time t? So here, by this time it has completed a time period of t. So from here, again it is repeating its motion as usually as it has repeated its motion, or as it has started its motion from t is equal to 0. Clear? So these type of motions are the motions which we have to study before studying simple harmonic motion. Clear? Similarly, if periodic motions, if they are represented in single sine or single cosine functions, then such type of periodic motions we can call them as harmonic functions also. Clear? For example, here what are the two functions we have taken? We have taken f of t is equals to sine omega t. Similarly, we have taken f of t is equals to cos omega t. So just now we have studied that they are periodic motions. They are repeating their motions after regular intervals of time. So they are called as harmonic functions also. Why they are called as harmonic functions? Because if periodic functions are represented in single sine or single cosine functions, so these are single sine and single cosine functions only. So such type of functions we can call them as harmonic functions also. So you make a note of this statement. So what is the note we have to write here? Let us write. Okay. So how can we define a harmonic function? Harmonic function is harmonic function. A periodic function represented in single sine or cosine function is called a harmonic function. Clear? For example, if I take a function f of t is equals to sine omega t plus sine 2 omega t. So is it a periodic function? So definitely this is a periodic function. So total motion will repeat after some time. Clear? But is it a harmonic function? This is not an harmonic function, because this is not represented in single sine or cosine function. Clear? So let us do some problems on this one so that we can understand what is meant by periodic motion. Clear? Let us see. Now let us see this question. So find the time period of sine omega t, sine 2 omega t and sine 3 omega t. Clear, ma? So here, what is meant by omega? Omega is called angular frequency. Clear? So in this function, angular frequency is omega. So if I compare this total function with sine omega t, then 2 omega becomes angular frequency, and here 3 omega becomes the angular frequency. Clear? So we know that angular frequency omega is equals to 2 pi by capital T. Now comparing this 2 pi by capital T with angular frequencies of each of these functions. So how can I calculate? First of all, if I take sine omega t. Clear? So here angular frequency is omega. So I compare this one by 2 pi by t1. So what is meant by t1? T1 is the time period for this function to repeat itself. Clear? So therefore, how can I calculate t1? T1 is equals to 2 pi divided by omega. So let it be our equation number 1. Similarly, let us take sine 2 omega t. Clear? So here angular frequency is 2 omega. And again comparing this one with, so 2 omega is equals to 2 pi by t2. So what is meant by t2? T2 is the time period of second function. That is, after how much time it is going to repeat its motion again. Clear? So from here I can calculate t2 is equals to 2 pi by 2 omega. Similarly, now if I take a third function, sine 3 omega t, then again I compare this one by 2 pi by t. So the angular frequency here is 3 omega. So 2 pi by t3 I can write. So therefore, what is T3? T3 is equals to 2 pi divided by 3 omega. So these are the time periods of individual functions which I got. Clear? So first function will repeat itself after a time of 2 pi by omega. Second function will repeat itself after a time of 2 pi by 2 omega. And third function will repeat itself after a time of 2 pi by 3 omega. Clear? Now the question is, after how much time total function will repeat itself? That is the question. Clear? Now let us try to compare their values by relative comparison. How can I compare them relatively? So if T1 is equals to 2 pi by omega, then how can I write T2? T2 is 2 pi by 2 omega, or I can write it as T1 divided by 2. I can write like this. Similarly, T3, again, how can I write in terms of T1? T3 can be written as, T3 is 2 pi by 3 omega, which can be written as T1 divided by 3. Okay? So if time period of first function is T1, time period of second function is half of T1. Time period of third function is 1/3 of T1. So what is the meaning of this? By the time first function completes one cycle, second function completes two cycles, because its time period is only half. Clear? Similarly, by the time first function completes one cycle, third function completes 3 cycles. Why? Because its time period is only 1/3. Clear? So therefore, graphically, how can I represent this one? Graphically, I can draw a diagram like this. Clear? For example, if I draw the function of the cycle of first function, which is called sine omega t, I can draw like this. If I draw like this, so by this time, first function completes one cycle, second function will complete 2 cycles. How it is able to complete 2 cycles? Because its time period is only half. So in a time of 2 pi by omega, it can complete 2 cycles. So what is meant by completing 2 cycles? So this is one cycle and this is another cycle. Clear? Similarly, what about the third function? By the time first function completes one cycle, third function can complete 3 cycles. So therefore, how can I divide this one? This time period, let us divide into 3 parts. So like this. So this is 1, this is 2, and this is 3. So it will complete 3 cycles. Clear? Now, after how much time they are going to repeat their motion? So after a time of first time period, what is the first time period? T1 is equals to 2 pi by omega. Okay, so we are considering that at t is equal to 0, all of them, they have started from here with the same phase. And after a time of 2 pi by omega, again all of them have started from the same phase. It means all of them, they have repeated their motion at the same time. So that is called as a period of a function or a time period of a function. So what is meant by time period? Time period means total motion should repeat itself. But here motion is depending on 3 factors. So all the 3 terms should repeat their motion once again. So this is happening only after a time of t1 is equals to 2 pi by omega. So therefore, the time period of this function will become 2 pi by omega, because only at a time of, after a time of 2 pi by omega only, all the functions, they are again starting from the same position and from the same phase. Clear? So therefore, time period of this function is t1, which is equals to 2 pi divided by omega. Clear? Now let us see here, 3 functions are given. So we are supposed to find out which of these functions are periodic and which of these functions are non-periodic. Clear? So first let us take the first function, which is log omega t. Clear? So as t starts increasing, that is as t tends to infinity, log omega t also tends to infinity. So it is as time increases, so log of omega t value also continuously increases. Clear? So it is never going to repeat its motion after regular intervals of time. So definitely this function, this is non-periodic function. So this is non-periodic function. Clear? Similarly, let us see the second function. So second function is E is equals to minus omega t. So E value is how much? Approximately 2.71. Clear? So as t increases, the negative power increases. So 2.71 power of negative power means minus 2, minus 3, minus 4. So negative powers will continuously increase. Then we know that this total value continuously it tends to 0. So therefore, what can I write? As t increases or t tends to infinity, e power minus omega t, it tends to 0. Clear? So here also motion is not being repeated after regular intervals of time. Okay, continuously the value is decreasing, but motion is not repeated. So this is also, it is also a non-periodic function. Clear? Let us see the third function which is given. So third function is sin omega t plus cos omega t. Clear? So let us try to convert this one in the form of sin a plus b. So how can I write this one? Very simply, I can write this one by multiplying and dividing by root 2. Clear? Why we are multiplying by root 2 only? Because only for cos 45, sin values and cos values are equal. Sin 45 is also root 2, cos 45 is also root 2. So root 2 into root 2, sin omega t plus cos omega t. So therefore, root 2 sin omega t into 1 by root 2 plus cos omega t into 1 by root 2. Clear? So root 2 times of sin omega t into 1 by root 2 can be written as cos 45, or 45 can be written as pi by 4, plus cos omega t into, and again 1 by root 2 can be written as sin pi by 4, sin 45. Sin 45 is 1 by 4. So I can write like this. Clear? So root 2 into, now this equation in the form of sin a cos b plus cos a sin b, which is equals to sin a plus b. So sin, what can I write? Omega t plus pi by 4. Clear? So definitely this is of the form of sin theta plus pi, where pi is a initial phase constant. So here initial phase constant is pi by 4. So what is meant by initial phase constant? At t is equal to 0, the body has already covered some phase of pi by 4. Clear? So phase constant means phase of particle at t is equal to 0. What is meant by t is equals to 0? When I started observing this motion, particle was already present at some phase. Clear? So therefore, whatever it may be, so this is following the rules of sin theta. And we know that sin theta is a periodic function. So definitely it will repeat its motion after regular intervals of time. So definitely this is a periodic function. Clear? So these two are not periodic, but this is a periodic function. Okay? Dear students, so welcome to simple harmonic motion part 2. So in the first part, we discussed about types of motions. So what are the different kind of motions that are present and what is meant by periodic motion, and we have discussed some examples of which of the functions can be called as periodic motions. Now we will study what is actually called as simple harmonic motion. So before studying that one, first of all we should study about Hooke's law. Clear? So Hooke's law. So what is Hooke's law? Let us try to understand. For example, if this is a spring which is present in its natural length. So what is meant by natural length of the spring? It means that spring is not elongated or spring is not compressed also. So it is in its unstretched position or uncompressed position. Clear? So now what I am doing is I am applying some force and then I am elongating this spring by a distance of x. So from the mean position, it is being displaced. So the last end of this spring, it is being displaced by a distance of x. Clear? So immediately when this displacement happens, spring develops a restoring force which starts acting exactly in opposite direction. Clear? So as spring is elongated in one direction, restoring force starts acting in backwards direction. So according to Hooke's law, the relation between these two can be written as Fr is proportional to minus x, and this law we call it as Hooke's law. Clear? So what is the meaning of this one? As the displacement from the mean position increases, restoring force also increases. Clear? It also means that when displacement from the mean position decreases, restoring force also decreases. Clear? So this we call it as Hooke's law. Clear? So then if I write a proportionality constant by removing this proportionality symbol, then I can write Fr is equals to minus kx, where k can be written as minus f divided by x. And this is called as spring constant. So this we can call it as spring constant, SHM constant, oscillation constant, or we can call it as vibration constant. Clear? So if I observe this relation, Fr is proportional to minus x, I can say that here restoring force, it is not a constant, restoring force is a variable. Clear? So what is meant by restoring force is a variable. It means that as x changes, what is meant by x? Displacement of the spring from the mean position. If it changes, then Fr value also changes. Restoring force developed in the spring also changes. Clear? Okay. Now after understanding this one, let us do one more experiment. So here what I do is, I take a spring and here I connect this one to a body. Then I am taking another similar spring whose K value is exactly equal to the first spring. So its restoring constant is also K. It's a SHM constant or vibration constant, spring constant is also K here. Now what is the mean position of this body? This body is present. Let us consider this position. We can call it as mean position. Clear? Now what I do is, by applying some force, I try to displace this body from here up to here. So what I have done, this body is displaced from here to this position. Clear? So this is my new position. So it is being displaced in right side by a distance of x. So in this direction, it is being displaced like this. Clear? Then how can I draw the new diagram? I can draw the diagram like this. Clear? And what about this side? This side, spring will be compressed like this. Clear? So this is what is happening. Clear? Now can you say what is the direction of restoring forces in both the springs? Clear? So in which condition restoring force will develop? Restoring forces will develop when spring is either compressed or elongated also. Clear? So I can see that this first spring is being elongated and second spring is being compressed. Clear? So therefore, if I take first spring, so let us call it as spring number 1, spring number 2. If I take this spring, displacement of the spring is in this direction. That is, the spring has displaced in this direction. Then definitely, according to Hooke's law, what can I say? According to Hooke's law, if displacement is in one direction, restoring force should be in another direction. So, restoring force starts developing in opposite direction. So, this is the direction of restoring force of the first spring. Clear? Now, what about the second spring? Second spring displacement is also in the same position, no? So this was the mean position. Spring was displaced in this position. Clear? So here also I can say displacement is in the same position. So again restoring force will develop exactly in opposite direction. So this is another Fr due to second spring. And restoring force is equals to minus Kx. Here also restoring force is equals to minus Kx. And both of them are in the same direction. So therefore total restoring force, Fr total, how can I write this one? This is equals to minus Kx plus minus Kx is equals to minus 2Kx. This is how I can write. Clear? So restoring force is equals to minus 2Kx. Clear? Now the question is, what happens? So I have displaced this body up to here and I am holding this one. Then I can see the restoring force developed in both the springs is minus 2Kx in total system. Now the question is, what happens if I release this system? If I release this body, then what will happen? This restoring force, because it is present in this direction, that restoring force tries to bring the body back to the mean position. Clear? Now, in the process of bringing this body to the mean position, what will happen? So what will happen when it tries to come to the mean position? Then continuously x value decreases. If x value decreases, according to Hooke's law, what can I say? Restoring force also decreases. Clear? So, x value is continuously decreasing, restoring force is also decreasing. Then what about velocity? What about velocity? So, force is applied according to Newton's second law. What can I write? I can write F is equal to ma. So, on this body, the only force which is acting is minus 2kx. Clear? So, with the help of minus 2kx, it starts moving in this direction. So, that is that minus 2kx is equals to ma initially. Clear? So initially, what is the net force acting on this body? Net force is equals to minus 2kx. Are you able to understand? So therefore, with the help of this restoring force, this body starts to come towards the mean position. Clear? So as net force is acting, acceleration is also produced. So what acceleration will do? Acceleration, it tries to increase the velocity of the body. So continuously velocity of this body increases as it comes to the mean position. But what about x value? X value is continuously decreasing, no? Then what about restoring force? Is it increasing or decreasing? Definitely restoring force is decreasing. But definitely restoring force has not become zero. So as restoring force has not become zero, acceleration is also not zero. If acceleration is not zero, definitely velocity of the body continuously increases. Okay? So x value becomes zero only at the mean position. So therefore, acceleration will become zero only at the mean position. So by that time, velocity continuously increases. And by the time this body reaches the mean position, its velocity will be maximum. Clear? Now, after traveling from x to 0, that is from maximum displacement to mean position, velocity of the body has increased. Clear? Now the body has reached the mean position. Now the question is, after reaching the mean position, will it stop there or not? Will it stop there or not? So from the extreme position, it has reached the mean position. By that time, its velocity has become maximum. So now, will it stop at the mean position or not? At mean position, what is the condition? At mean position, x is 0. At mean position, x value is 0. Okay, so as x is 0, will it stop at the mean position or not? If x is 0, then what I can write, restoring force is equals to minus kx is equals to minus k into 0 is also 0. Okay, so at the mean position, restoring force is also 0. Now the question is, will it stop at the mean position or not? It will not stop at the mean position, because at the mean position, its velocity is already maximum. So what it will do, it will start moving towards another extreme position. Clear? So how it is able to travel towards another extreme position if there is no restoring force? At the mean position, there is no restoring force. Then how it is able to travel to another extreme position? The reason is very simple, because of inertia. Clear? As velocity is maximum, this body cannot stop at the mean position suddenly, because it has the property of inertia of motion. So because of this inertia, this body starts to travel in opposite direction. It starts traveling in this direction now. Clear? So if it starts traveling in this direction, then what will happen? This spring will be elongated, second spring, and first spring will be compressed. Then again what happens? Then again restoring force starts developing again in opposite direction. Previously restoring force was in this direction. Now restoring force is in opposite direction. Clear? Now what this restoring force is doing? This restoring force is again trying to bring the body back to the mean position. So by this we understand the definition of simple harmonic motion. Clear? So continuously body is oscillating. If we neglect the damping forces will be definitely present in real time oscillations. But if I consider damping forces are 0, then this body will continue oscillating about the mean position. Clear? And what restoring forces are doing? Restoring forces are always trying to bring the body back to the mean position. So this is the definition of simple harmonic motion. So what is the definition of a simple harmonic motion? So let us write a definition here. So the definition of a simple harmonic motion is, it is a special case of oscillatory motion where restoring force always tries to bring the body back to the mean position. Clear? So this is called as restoring simple harmonic motion. Clear? So this is also an oscillatory motion. SHM is also an oscillatory motion, but what kind of oscillatory motion is this one? Restoring force is always trying to bring the body back to the mean position. But because of the inertia which is present for the body, it will go to another extreme position. So this is what happening in the case of simple harmonic motion. Clear? Now let us try to understand this one further. Okay? So here what can I write? Here I can write Fr is equals to minus Kx. So this one also I can write it as, this is the only net force acting on this spring. So minus Kx is equals to Ma, and Ma is the net force. Clear? So this is the only net force acting on this body, which is the restoring force. So therefore, according to this relation, what can I write? I can write, okay, so minus Kx is equals to M into A. So therefore, A is equals to minus Kx divided by M. So this is one relation which we got. Clear? And already we have studied previously that restoring force or spring constant of the spring K is equals to M omega square. So if I substitute this value here, then I will get A is equals to minus M omega square into X divided by M. So M and M if I get cancelled, so A is equals to minus omega square into X. When omega is a constant, then I can write A is directly proportional to minus X. Clear? So previously what was the result we got? Previously according to Hooke's law, Fr is directly proportional to minus X. Now here I got A is directly proportional to minus X. It means that restoring force and acceleration, always they are directed towards the mean position. So this is another definition of simple harmonic motion. Clear? So what is another definition here I can write for simple harmonic motion? Another definition which I can write is restoring force and acceleration are always directed towards the mean position. So this type of motion we can call it as simple harmonic motion, not only restoring force. Acceleration is also directed towards the mean position. Clear? So make a note up to here, then we will continue from here. Now let us see what are the equations which are present in a simple harmonic motion. So before that one, first let us study the differential equation of simple harmonic motion, which is very important. So let us see. So already we have studied in the last class that what is meant by simple harmonic motion. It is a special case of oscillatory motion where restoring force and acceleration, they are always directed towards the mean position. Clear? So therefore, if restoring force Fr is equals to minus kx, and if this is the only net force which is acting, then I can write net force is equals to mass into acceleration. Clear? So velocity can be written as dx by dt, and acceleration can be written as dv by dt, or also I can write it as d square x divided by dt square also. Already we have studied these equations in kinematics. So if I differentiate displacement with respect to time, I will get velocity. If velocity is differentiated again with respect to time, then I get acceleration. Or this equation dx by dt, if I differentiate again with respect to time, then I will get dx square by dt square, which is also called as acceleration. Clear? So therefore, what can I write? I can write minus kx is equals to mass into d square x divided by dt square. So I can write like this. So therefore, m d square x by dt square is equals to minus k into x. So already we have studied that k is equals to m omega square. So previously we have studied this relation. Clear? So instead of k, I can write m omega square into x. So m and m get cancelled. So therefore, what is the relation I am getting? D square x by dt square plus omega square x is equal to 0. Okay? So this form of the equation we call it as the differential equation of simple harmonic motion. Clear? Where here x I can call it as position of the particle from the mean position. Clear? Or distance of the particle or displacement of the particle from the mean position. Clear? So if any function is given, and if that particular function, if it is satisfying this relation, then definitely I can say that equation will be simple harmonic motion. Or the oscillations are formed by such particle, definitely they will be of SHM in nature, simple harmonic in nature. Clear? Let us take an example. For example, if I write the displacement of the particle is according to this equation, x is equals to a sine omega t. Clear? So let us consider, we have to find out whether this given function, it is simple harmonic motion or not. Clear? So what can I do? I will try to convert this relation in terms of d square x divided by dt square. Clear? So first I will find out dx by dt, that is differentiation of this x with respect to time, a sine omega t. A is a constant, so it will come outside. And the differentiation of sine omega t is cos omega t. And until now we have differentiated only sine theta. Theta we have not differentiated because omega t, it is what we are differentiating with respect to time. So differentiation of omega t with respect to time will become omega. So all this we have studied in mathematics part previously. Clear? So therefore dx by dt is how much? So therefore I got dx by dt is equals to a omega cos omega t. But what I want d square x by dt square. So therefore d square x divided by dt square is equals to, so a omega is a constant and differentiation of cos theta is minus sine theta minus sine omega t, and still we have not differentiated omega t. So again differentiation of omega t with respect to t, so this will be equal to omega. Clear? So therefore d square x divided by dt square is equals to minus a omega square sine omega t. So this is the relation up to which I got. Clear? Now if I see the original relation, x is equals to a sine omega t. So here I have a and here I have sine omega t. So a sine omega t should be equal to x. So therefore, how can I write this relation? I can write d square x divided by dt square is equals to minus omega square into x. So therefore, d square x by dt square plus omega square x is equal to 0. Clear? So definitely this function is satisfying the differential equation of SHM, which is d square x by dt square plus omega square x is equal to 0. Clear? So it means this definitely this function which we have taken, it is a simple harmonic in nature. Clear? Now let us see some more examples whether to find out the given functions if they are simple harmonic in nature or not. Clear? Dear students, now let us see this question. So, identify which of the following functions are simple harmonic in nature. So, here 3 functions are given. So, out of these 3, we are supposed to find out which of them are simple harmonic in nature. So, simple harmonic nature in the sense already we have discussed that they should follow the condition of d square x by dt square plus omega square x is equal to 0 if it is given in terms of x. But here all the functions are given in terms of y. So d square y by dt square plus omega square y is equal to 0. Clear? So let us take the first function. What is the first function given? So y is equals to a e power I omega into t. So therefore dy by dt is equals to a e power I omega t. So total differentiation we have done, but we have to differentiate I omega t. So differentiation of I omega t with respect to time will be I into omega. So which is equals to I a omega e power I omega into t. Clear? Now we are supposed to find out d square y divided by dt square. So this is I a omega e power I omega t. Now again I have to differentiate I omega into t with respect to time, which is again equal to I into omega. So therefore what is the relation I got? I got d square y divided by dt square is equals to I square a omega square e power I omega t. This is the function which we got. Clear? This is I square. So d square y divided by dt square is equals to, we know I square value is equals to minus 1. So minus 1 a omega square e power I into omega t. Clear? So therefore d square y divided by dt square is equals to, so minus omega square into a e power I omega t. Clear? So a e power I omega t is nothing but y here. So therefore what can I write? So d square y divided by dt square minus omega square y. So therefore d square y divided by dt square plus omega square y is equal to 0. Clear? So definitely this is following this relation of differentiation equation of SHM. So definitely this function, it is a simple harmonic motion. Clear? Let us see the second example which is given. Second question which is given is this one. A e power minus omega t is equal to y. So therefore dy by dt is equals to a e power minus omega t into minus omega. So therefore it is equals to minus a omega e power minus omega into t. So d square y by dt square is how much? So it is equals to minus a omega e power minus omega t into again minus omega. So d square y by dt square is equals to a omega square e power minus omega into t. So therefore d square y divided by dt square is equals to, so omega square if I take common, so a e power minus omega into t. Clear? So a e power minus omega t into t can be written as y. So therefore d square y by dt square is equals to omega square into y. But if I do this calculation, this function is not equal to this function. So definitely second function is not a differential equation. Second function is not the differential form of simple harmonic motion. Clear? Now let us see the third function which is given. Third function is this one, y is equals to a sin omega t plus b cos omega t. Now let us see if it is a differential function or not. Clear? So let us calculate from here. So third function is y is equals to a sin omega t plus b cos omega t. So therefore dy by dt is equals to a omega cos omega t and minus b omega sin omega t. I hope you know this differentiation of sin theta and cos theta. So therefore again I will write d square y divided by dt square, then it can be written as minus a omega square sin omega t minus b omega square cos omega into t. Clear? So this equation can be written as minus omega square into a sin omega t plus b cos omega t. Clear? So a sin omega t plus b cos omega t is nothing but y here. So therefore what can I write? I can write d square y divided by dt square is equals to minus omega square into y. So d square y by dt square plus omega square y is equal to 0. So therefore this is also following this differential form of simple harmonic motion. So third equation is also a simple harmonic motion. Clear ma? So this is the method in which we have to check whether the given function is a simple harmonic in nature or not. Clear? So just they should follow the equations of differential form of simple harmonic motion, d square x by dt square plus omega square x is equal to 0. Or if it is given in the form of y, then d square y by dt square plus omega square y is equal to 0. Okay? Now let us see the position time equation of a simple harmonic motion. Clear? So the position of a particle which is performing SHM. So let us try to understand this one with the help of a line diagram. So consider this is the mean position of the particle, and let us suppose the particle is performing SHM along this mean position. Then this is called a plus A and this is called as minus A. So where plus A and minus A represents amplitude of the particle. So what is meant by amplitude? The maximum displacement of the particle from the mean position is called as amplitude. Clear? Now, in a particular time of t, if I want to exactly calculate particle is present at which position, then we will write an equation for x is equals to a sin omega t. And this is the relation we use when particle has started motion from the mean position and in positive direction. So this direction we call it as positive direction, and this direction we call it as negative direction. Clear? So when particle has started its motion, or when we have started observation, particle was present at mean position, and when it was traveling towards positive extremity, then this is the equation of position of the particle with respect to time. So x is equals to a sin omega t. So before studying why we have written equation like this, first let us see what are the terms which are present in this position and time equation. So here what is x? X is called position of particle with respect to time. Clear ma? And position always we have to measure from the mean position. From the mean position, body is present at how much displacement, whether it is in positive displacement or negative displacement. Clear? And what is t here? T is time after we have started observation. Clear? So after the time after which we have started observation, that time interval we call it as t. Clear? So then we have a. A is called as amplitude of the particle. Amplitude is called maximum displacement of the particle from the main position. So then we have to study frequency. So what is meant by frequency? So the number of cycles or complete cycles the body is able to perform in a particular time of t. Or we can say the number of cycles it is performing in 1 second. So therefore number of cycles in a time of 1 second. So this is called as frequency. So let us try to understand this one. Frequency can be written as nu, frequency can be written as f also. So which is equals to, for example, if I write it is 2 cycles per 1 second, then what is the meaning of this one? It means that this body which is in a simple harmonic motion, it is able to complete 2 complete cycles in a time of 1 second. So that is called as frequency. Clear? And how frequency and time period they are related? Frequency nu is equals to 1 by t. This is the relation. Clear? Or I can write t is equals to 1 by nu or 1 by f. Nu and f both represent frequency itself. Clear ma? So this is how we can write a relation between frequency and time period. Clear? So after that we have to discuss about angular frequency. Angular frequency. So what is meant by angular frequency? So omega is equals to, so 2 pi if I multiply with f, then it is called as angular frequency. Clear? So 2 pi into f is called as angular frequency. So it is the frequency that the body is covering angle It means in a time of 1 second, how many 2 pi's? 2 pi means total one complete circular motion has an angle of 2 pi radians or 360 degrees. So in 1 second, how many 2 pi's or how many 360 degrees the body is able to cover? That is called as angular frequency. Clear? Let us try to understand this one by taking the same example. Let us consider frequency is 2. So therefore, then angular frequency can be written as 2 pi into 2. What is meant by 2 pi into 2? It means that it is able to cover 2 complete oscillations, which is making an angle of 2 pi into 2 is 4 pi in a time of 1 second. So this angle covered by the particle in one particular second, that is called as angular frequency. Clear, ma? So therefore, omega is equals to 2 pi into f. Then same relation, how can I write? I can also write it as 2 pi divided by capital T also. Because already here we have written frequency is nothing but 1 by T. So T is equals to 1 by F. So omega is equals to 2 pi into T is one relation. 2 pi into F is another relation. Clear, ma? So this is how, what we call it as the next term, angular frequency. Then we have to study a term which is called omega into T. And this omega into T is called as phase of the particle. Clear? So now we are studying about this term which is called as omega into T. So where omega into T is called as angle covered by particle, you can call it as theta or you can call it as phase of the particle. Okay? Phase of the particle is nothing but angle covered by the particle. So why we are saying angle here? Because SHM can be always compared with circular motion. SHM we can always compare with circular motion also. Clear? So that comparison we will do after some time. So just we remember up to here. So omega t is nothing but phase of the particle or angle covered by the particle. Clear? Okay. Now the same equation I can write it like this also. I can also write it as x is equals to a sin omega t plus pi. Okay, where this omega t plus pi, this is totally called as phase of the particle. And this pi we call it as epoch constant, or we can call it as initial phase. Clear? Now what is the importance of this epoch constant or initial phase? It means that when you make t to be 0, so at a condition when t is equal to 0, so what is meant by t is equal to 0? T is equal to 0 means the time when we started observing the motion, observing the SHM of particle. Clear, ma? So t is equal to 0 means it is at that instant when we have started observing that SHM. Clear? So if I place t is equal to 0 in this condition, then this total term will become 0 and this pi will remain, which is called as initial phase of the particle. It means that, let us try to understand this one. So for example, this is the main position and at t is equal to 0. What is meant by at t is equal to 0? So this term you should carefully understand. At t is equal to 0 means it is that instant when I have started observing the simple harmonic motion of the particle. Clear? So at t is equal to 0 when particle was here and it was traveling in this direction. Then I say that here initial phase pi is equal to 0. Here initial phase constant is 0. Clear? So what is meant by initial phase? Phase of the particle when we have started observation. That is called as initial phase or epoch constant or initial phase constant also we can say. Clear? Similarly, when I have started observation, particle was already present here. Clear? Then I say the initial phase of the particle is 90 degrees. It means the particle was present at what phase? When I have started observation. And the time at which I have started observation, that time we call it to be 0. T is equal to 0. Clear, ma? So this is called initial phase and these are the different terms which we have to study in the case of simple harmonic motion. Clear? And what is meant by time period? So this term also we have to remember. So time period is what? Time period is the time taken for the particle to complete one complete oscillation. Now the question is, what is meant by complete oscillation? Let us see. So next we are discussing about time period. Clear? So time period. So what is meant by time period? Time taken for one complete oscillation is called as time period. So it means that, let us consider particle has started from the mean position and it has started from here in this direction. then time taken from here to here, and again it will return back, again it will go to another extreme position, then again it will return to the same initial position from which it has started. So this complete movement, that we call it as one oscillation, and time taken for that oscillation is called as one time period. Clear, ma? So time taken for the particle to travel from mean position to extreme position to mean position, again mean position to another extreme position, and again from another extreme position to again mean position. So this is called as one oscillation, and time taken for one oscillation, time taken for one oscillation is called as time period of the particle, or time period of simple harmonic motion. Clear, ma? So after understanding the different terms which are present in this equation of x is equals to a sin omega t, now let us try to understand actually what is the meaning of this relation. Clear? Let us. Okay. So let us consider. So this is the path in which a particle is traveling. This is the mean position. So this is plus a and this is minus a. So particle has started from the mean position. So let us assume time taken from here to here, this time let it be t is equal to 1 second. And from here to here, let time taken is equal to another 1 second. And from here to here, let time taken is equals to another 1 second. And from here to here, let time taken t is equals to again 1 second. So from here to here 1 second, and from extreme position to mean position another 1 second, from mean position to second extreme position again 1 second, second extreme position to again the same mean position 1 second. Now the question is, what is the total time period in this condition? So definitely I can say total time period is 1 plus 1 plus 1 plus 1 is 4 seconds. Clear? So total time period is 4 seconds. Clear? Now we have already discussed that a particle has started from the mean position and it is traveling towards positive extreme position. Now after 1 second, I want to calculate with the help of equation what is the position of the particle. So by this diagram already we have seen that after 1 second, particle will be at plus a, positive extremity. Now with the help of equation I am supposed to prove this one. Let us see how we can do. So what is the equation we have taken? The equation which we have taken is x is equals to a sin omega t. Clear, ma? So x means position of the particle in a time of t. So x is equals to, what is the amplitude of the particle? A sin omega. Omega can be written as 2 pi by capital T into, now at what instant I want to calculate position? After 1 second. So my time interval will be 1 here. So x is equals to a sin 2 pi divided by, what is the total time period? Total time period is 4 seconds multiplied by 1. So therefore x is equals to a sin pi by 2. What is meant by pi by 2? 90, sin 90 value is plus 1. So plus into a, plus 1 into a is plus a. So this is the relation which I got. Clear? Satisfied now? So after 1 second, particle should be at plus a, positive extremity. So that is what we have proved by this relation. Clear? Now let us do one more example. So let us say I want to calculate position of the particle at t is equal to 2 seconds. What is meant by t is equal to 2 seconds? After I have started observing this particle, after a time of 2 seconds, what is the position of the particle? Clear? So again I can use the same relation. So I can use x is equals to a sin omega t. Now let us calculate. So x is equals to a sin omega can be written as 2 pi by capital T into t. So x is equals to a sin. So 2 pi divided by capital T is 4 seconds and time we are taking as 2 seconds. So 2 2s are 4 and 4 get cancelled. So x is equals to a sin 2 pi. Is it 2 pi? So sorry, it is pi, a sin pi. Clear? So therefore x is equals to sin pi, sin 180 value is 0. So therefore we got x value is 0. So again it is satisfied now. After 2 seconds, what should be the position of the particle? After 1 second, it should reach from here to here, and after second, it should again reach to the main position. So that is the same answer we got. X is equal to 0. Similarly, if you place x is equals to, t is equal to 3 seconds, then 1 second, 2 seconds, 3 seconds. So position of the particle should be at minus a. So you'll get sine 270. Sine 270 value is -1. So -1 into a is -1. Okay. So that is the importance of this equation, x is equals to a sin omega t. And we should be very careful that in which condition we can use this relation. In a condition when particle has started from the mean position, that is when we have started observation, particle was traveling across the mean position and towards the positive extreme position, then we are supposed to use this relation, x is equals to a sin omega t. Clear ma? So after this equation, let us see how we can derive the equations of velocity and acceleration with the help of this relation. Now let us see velocity of the particle in simple harmonic motion. So let us see. So position and time equation we have written previously, which is equals to x is equals to a sin omega t. So we can write y is equals to a sin omega t also. So x is equals to a sin omega t represents that particle is performing SHM along x-axis. Clear? Y is equals to a sin omega t represents that particle is performing SHM along y-axis. Nothing more than that. Generally, students will be getting confusion in this one. Y in some books it is x is equals to a sin omega t, and y in some books it is y is equals to a sin omega t. Clear ma? So along which axis particle is performing SHM? So that coordinate we will take. Clear? So now if I differentiate this one with respect to time. So dx by dt is called velocity of the particle. So velocity is equals to a omega cos omega t. So this is one equation for velocity of the particle performing simple harmonic motion. Clear? Now we know that sin square theta plus cos square theta is equal to 1. So according to this relation, cos omega t, how I can write? I can write it as square root of 1 minus sin square omega t. So therefore, now if I substitute in this relation, what I will get? I will get v is equals to a omega. Instead of cos omega t, I can write square root of 1 minus sin square omega t. Clear? So already we have a relation x is equals to a sin omega t. So sin square omega t will be how much? It will be equal to x square divided by a square. Now substitute this relation here. So a omega into square root of 1 minus x square divided by a square. So v is equals to a omega into square root of a square minus x square divided by a square. So this a and a square get cancelled. So v is equals to omega into square root of a square minus x square. So this is one more relation to calculate velocity of the particle which is performing simple harmonic motion. So therefore we have two relations, v is equals to a omega cos omega t and v is equals to omega into square root of a square minus x square. Clear? Same relation, let us try to modify this one further. Now if I square it on both sides, then what I will get? I will get v square divided by omega square plus is equals to a square minus x square. Now dividing all the term by a square, I can write like this. So v square by omega square a square is equals to 1 minus x square divided by a square. Same relation I can write like this also. So v square by omega square a square plus x square divided by a square is equal to 1. Okay. Now if I see this relation is of the form of an ellipse. So this is how equation of ellipse looks like. Clear? So if I draw the graph of velocity and displacement, then what is the graph I will get? For example, if I take velocity on y-axis and position of the particle along x-axis, then this is the graph I will get. This is plus v, this is minus v. So this is the graph which I will get. So graph will be exactly in the form of an ellipse. So this is not looking like an ellipse, but this is the graph which you will get. Clear ma? So here on the velocity axis, what is the maximum velocity which I will get? Plus a into omega. This one we will get. So here we have v by a omega whole square, no? So maximum value of velocity coordinate will be a into omega, plus a into omega. And in negative velocity, that is maximum velocity negative direction will be minus a into omega. Similarly, if I take position of the particle which is placed along x-axis, then maximum position will be plus a. So this term I can write x by a whole square. So plus a, and minimum that is maximum amplitude in the negative direction will be minus a. Clear ma? So therefore, what is the conclusion here we have to write? It means that the graph of velocity and displacement, it will be in the shape of an ellipse. Clear? Okay. So after this, let us do some more calculations. So let us calculate what is the maximum velocity of the particle. Clear ma? So for velocity equations, what are the equations of velocity we got? V is equals to omega into square root of a square minus x square. Clear? So already while giving introduction about simple harmonic motion, already we discussed that when particle reaches to the mean position, then its velocity will be maximum. Clear? Because consider when particle is here, at the particle is here, amplitude is maximum. So if amplitude is maximum, Fr is equals to restoring force is minus k into x. Here x value is a, so minus k into a, and a is the maximum value. So restoring force also will be maximum. Clear ma? So because of that maximum force, maximum acceleration also will be generated. So minus k into a is equals to mass into a maximum. So maximum acceleration also will be produced at this position. So therefore, velocity of the particle continuously increases. Okay. So as x value decreases, restoring force also decreases, but definitely there is some restoring force. So because of that, velocity of the particle continuously increases, and at the main position, velocity will be maximum. So here we get the position of maximum velocity. So therefore, V will become V max at which condition? When x is equal to 0. What is meant by x is equal to 0? At the main position is called x is equal to 0. So therefore, what is the equation I will get? I will get V is equals to omega into square root of a square minus 0. Clear? So therefore, V max is equals to omega into a, or I can write it as a into omega. Clear? So this is the equation of maximum velocity attained by the particle. Clear ma? So these are the different discussions which we have on velocity of the particle which is performing simple harmonic motion. Clear? Now let us study acceleration of the particle which is performing simple harmonic motion. Okay? So definitely acceleration is a variable quantity, no? Why acceleration is a variable quantity? Because force is variable, restoring force is variable. Why restoring force is variable? Because the displacement of the particle from the mean position is a variable. Clear? Okay. Now let us see. Acceleration of particle performing SHM. Clear ma? So already we have calculated V is equals to a omega cos omega t. So if I differentiate this one with respect to time, then I will get acceleration. So if I do this differentiation, I will get minus a omega square sine omega t. Clear ma? So a is equals to minus omega square into a sine omega t. So a sine omega t can be written as x. So therefore a is equals to minus omega square into x. So this is one equation of acceleration of the particle performing SHM. So you can write it as minus a omega square sine omega t, or just I can write a is equals to minus omega square into x. Clear ma? So here omega is a constant, so therefore I can write a is proportional to minus x. So this was the same equation which we have studied at the introduction of a simple harmonic motion. So acceleration is directly proportional to minus x. What is meant by minus x? It means if displacement is in one direction, acceleration always will be in opposite direction. So when x value becomes 0, acceleration also becomes 0. It means acceleration of the particle is always trying to bring the body back to the mean position. That is the meaning of this one. Clear ma? Okay. Similarly, how can I calculate maximum acceleration? So a is equals to minus omega square x. Okay. So at the extreme position, restoring force will be maximum. Fr is maximum at the restoring force. So therefore, acceleration also should be maximum at the extreme position. So therefore, A becomes A max. A becomes maximum acceleration when x value becomes equal to A plus or minus A. Clear ma? When x is maximum, A is also maximum. So therefore, A max, how can I write? I can write it as minus omega square into A. So this is the equation for maximum acceleration of the particle. Clear ma? So maximum velocity is a into omega and maximum acceleration is minus omega square into a. Clear? So these are the different equations which we have in displacement, velocity and acceleration of the particle performing simple harmonic motion. Clear? Now if I draw a comparative graph of all this velocity, displacement and acceleration, then let us see what is the graphical form which we get. Clear ma? So let us. So if I write equation like this, clear? See ma. So we have x is equals to a sine omega t, okay? V is equals to a omega cos omega t. So a is equals to minus a omega square sine omega t. So these are the different equations which we have. Clear? Now, so x is equals to a sine omega t, it is just following the rule of sine theta. So here we will get a sine graph. So therefore, how can I draw a graph? We can draw the graph like this. Clear ma? So this is x and this is time, or omega t also we can write, any graph we can write, x value with respect to time or x graph with respect to omega into t also. Clear? Then the graph which I will get is this one. So this is the graph which we will get. So let us try to draw a good graph. Clear ma? So let us have up to here. So this is the graph which we will get. Clear? So therefore, this is what kind of graph? This is a sinusoidal graph. Clear? When t is equal to 0, x is also 0. Clear ma? Because omega into t is 0. Sin 0 value is 0. 0 into a is 0. So x value will be 0. Clear? So this is from here to here, this is called one total oscillation, no? One complete oscillation we call this one. So here time taken is t at this position, one time period. Then this time is how much? This time is half time period, which is called t by 2. So this time is how much? This is the time of t by 4. Okay. So this is t by 4, which is 1 by 4th of the time period. So this is t by 2. Clear? And this should be 3t divided by 4. So 3 by 4th the time of the total time period. Clear ma? So therefore, this is how I can get the graph of displacement and time. Similarly, now if I am supposed to draw velocity and time graph, then how can I draw? Okay. So here already we have discussed that at the mean position, velocity should be maximum. Clear? And here body is starting from the mean position and it is traveling towards positive extremity. That is what we have considered now. So body has started from here and it is moving in this direction. Clear? So therefore, at this position, velocity should be maximum and in positive direction. Clear? So therefore, from where my graph will start? My graph will start from here. Clear? Then it will go to extreme position. Then again it will become 0. Then it will become like this. So this is the velocity and time graph. So you compare the different positions of the particle, then you compare how velocity of the particle will change. Clear ma? Similarly, how can I draw acceleration and a time graph? Clear? Now compare these two relations. So this is also a sin omega t. This is also a sin omega t. Just omega is another constant. But here I have plus a and here I have minus a. It means that if displacement is in one direction, acceleration is in opposite direction. Clear? So therefore, how can I draw the graph? Graph will be exactly in opposite direction. So this will be the shape of the graph. So this is called the graph of acceleration and time. Clear ma? So this is how the graphical representation of displacement, velocity and acceleration we can draw. Clear ma? So let us try to understand. A particle starts from mean position, reaches up to here. From here again it returns back. And from here it goes to another extreme position. And here again it comes to the mean position. Clear? So when particle goes from here to here, we call it as 0 to 90 degrees. Clear? So particle from here, it goes to the maximum displacement. At this position, what about velocity? Velocity is 0. At the extreme position, velocity is 0. So from here, again it returns back. It has covered an angle of 180 degrees. So from here, it returns up to here. So here displacement is 0. But what about velocity? Velocity of the particle is maximum. And what about acceleration? Acceleration is also 0. Clear? So in this sense, you can compare the position, velocity and acceleration of the particles at a different positions. Clear? Okay. Dear students, now let us see the comparison of SHM with circular motion. Okay. So for example, let us first consider, so this is the path in which body is performing simple harmonic motion. So this becomes our mean position. Clear? And if particle, if it is traveling in this direction with a particular velocity of v from the mean position, it means that when I have started observing this motion, then particle was traveling at the mean position towards the extreme position. Clear ma? Then this direction always we consider to be positive direction, and another direction we will consider this one to be negative direction. Clear ma? So this is the mean position, this is a positive extremity, and this becomes our negative extreme position. Clear? So when we have started observation, that is what? At t is equal to 0. T is equal to 0 means it is at that time when we have started observing this motion. Okay. So at t is equal to 0, body was at the mean position and it was going towards positive extreme position. Then how can I write an equation for this one? Equation of displacement can be written as x is equals to a sin omega t. Clear? So already we have studied this relation. Are you able to understand ma? So you substitute t is equal to 0 in this condition, then I will get x is equals to a sine omega into t will become 0. So therefore x value will become a as sine 0 value is equals to, sine 0 is 0, so total x value will become 0. So what is meant by x is equal to 0? It means the body is present at the mean position. Are you able to understand, ma? Now let us see one more condition. For example, at t is equal to 0, that is when we have started observing this motion, if this is the mean position, body was already present at positive extremity. Clear, ma? So it was already present at positive extremity. Now how can I write an equation for this one? I can write an equation like this. So x is equals to a sine omega t plus pi, where pi we call it as initial phase constant. So already we have studied this one, we are studying again initial phase constant. Okay, or you can call it as epoch constant also. Epoch constant. Clear? So here initial phase constant is 0 because body has already started from the mean position. Okay, but in this condition, body, when we have started observing this motion, body was already present at plus a. So therefore, at t is equal to 0, let us try to calculate what is the phase of this particle, or what is the initial phase of this particle. Then how can I write? X's value is how much? Plus a. So plus a is equals to a sine. Now here omega t is present and t value is 0. So 0 plus pi. So therefore, plus a is equals to a sine pi. Clear, ma? So then what can I write here? So sine pi is equals to a by a, which is equal to 1. So it is possible only when pi value is equal to 90 degrees. This is plus 1. So pi value is equal to 90 degrees. Clear, ma? It means that when I have started observing this motion, the initial phase of the particle was 90 degrees. It means when particle is present at a positive extremity of plus a, it means that particle has already covered 90 degrees. So therefore, what can I write? So this is 0 degrees, this is 90 degrees. Clear, ma? Okay. Now let us see one more condition. Second condition is, so when I have started observing the motion, body was present at the mean position, but it was traveling towards negative extremity. If this is plus a, it is traveling towards minus a. Clear? Now again, how can I write the equation? Again, x is equals to a sine omega t plus pi. I can write like this. Now in this condition, what is the initial phase of the particle? Clear, ma? So x is already 0 now. So in which condition sine theta will become 0 again? So first at sine 0, value is 0. Then at next which angle sine theta will become 0? It will become 0 only at 180 degrees. Clear, ma? So therefore, how can I write? 0 is equals to a sine omega t is 0 plus pi. Why sine omega t is 0? Because this is the observation when t is equal to 0. Are you able to understand? So 0 is equals to a sine pi. Clear, ma? So therefore, sine pi value is also equal to 0. Then pi become either 0 degrees or 180 degrees. 0 degrees is already completed. So next phase will become 180 degrees. Clear, ma? It means that particle, when it has started from here in the positive extreme position, it is phase angle is 0. It covered 90 degrees, and then when it is returning back, here phase of the particle will be 180 degrees. Clear, ma? So after this, let us see one more position of the particle. Now let us see position of the particle when it is here. Clear? Okay, now let us see. So, when I have started observation, that is at t is equal to 0, so particle was already present at positive extremity. Clear, ma? So particle was present at, negative extremity. So it was present at minus a. So this is mean position, this is positive extreme position. Clear, ma? So at t is equal to 0, x is equal to minus a. Then let us see how we can calculate the phase of this particle. So x is equals to a sine omega t plus pi, where pi is the initial phase constant. So x value is minus a. So minus a is equals to a sine 0 plus pi. 0 because this is when we have started observation, time is 0. So therefore, sine pi will become minus a by a, which is called as minus 1. So sine pi will become minus 1 for which angle? So for a first angle of 270 degrees, sine pi value will become minus 1. It means that this is 0, this is 90, and while returning back this is 180, and here angle is 270 degrees. Clear, ma? And then again it goes to the mean position, and here phase angle will be either 0 or 360 degrees. Clear ma? Why we are doing all this calculation? We are doing all this calculation to prove that SHM can be always compared with circular motion. When particle is at the mean position and it is traveling towards the positive extreme position, then its phase is 0. Clear? So let us try to write all these conclusions here. Clear ma? So when particle is present at the mean position, clear, and it was going towards a positive extreme position, its phase is 0. By the time it reaches the maximum position, it means it has covered an angle of 90 degrees. And from 90 degrees, when it is returning again to the mean position, it is equivalent to as if it has covered 180 degrees. And from 180 degrees, when it reaches to another extreme position, minus A, then it is equivalent as if it has covered 270 degrees. And from minus A to again, when it reaches to the mean position, it has covered 360 degrees. Clear ma? So this is called as one oscillation. And one oscillation is equal to as if body has completed one circular path. Clear? So SHM is always comparable with circular motion. So what is the statement here we can write? By the time particle has completed one oscillation, it is equivalent to as if it has completed one circular path. Clear ma? Now actually let us try to construct a circular path and let us see what is the analogy between this SHM and circular motion. Clear ma? Let us see. So for example, let us consider this is the circular path in which the particle is moving. Clear ma? Then we are drawing an x-axis and we are drawing a y-axis. Clear? So let us consider particle has started from this position, point A, and it is traveling in this circular path. Clear ma? So this line we call it as mean position. Okay? So this line we are calling it as mean position, and the particle is starting from the mean position. So if it becomes the mean position, the line above this one, this becomes a positive extreme position, and the point below this one becomes the negative. So this becomes our plus A and this becomes our minus A. Clear ma? So when particle is starting from here, then it does not have any length on y-axis. Are you able to understand? So what is meant by y-axis? This is our y-axis on which we are taking the amplitudes of plus A and minus A. Are you able to understand ma? Okay. Now if the person starts moving in the circular path, for example, let us consider this person has traveled some distance and he reached up to here. Clear? Then the radius vector which joins the center of this circle and this path. So if this is having an amplitude of plus A, then this also has an amplitude of plus A only. Are you able to understand ma? And now we take the projection of this body on the y-axis. Clear? So what we'll do, we take projection of this position of this body on y-axis. Clear? So what is meant by taking projection of this body on this y-axis? From that position, draw a perpendicular to y-axis. So if I draw a perpendicular to y-axis, it means that this is the displacement of the body from the mean position, because this total line we are considering to be the mean position, no? So from this mean position, it is as if body has reached this position and it is going towards positive extremity. Are you able to understand? Okay. Now when the particle has again further traveled and reached this position. Okay. Now if you draw the perpendicular again, clear ma? This is the radius vector, and from here if you draw the perpendicular, now body has reached this position. Actually it reached on this position in the circular path, but if you draw the projection, then on the y-axis from mean position to positive extreme position, body has reached up to here. Clear ma? And by the time it covers 90 degrees, so we know circle has 4 quadrants, no? First quadrant, second quadrant, third quadrant and fourth quadrant. Each quadrant has an angle of 90 degrees. Clear ma? So by the time it reaches to an angle of 90 degrees, so it is having the maximum displacement from the mean position. So this is plus A and this is the maximum displacement from the mean position. That's what we have studied previously also, no? So from the mean position, when particle has traveled, when it reaches to the maximum extreme position, then it is as if it has covered 90 degrees. So this is why it's satisfied here also. Clear ma? Now particle is present here at the maximum extreme position. Now when the particle starts again traveling, when it reaches to this position, clear ma? It is traveling and it has reached to this position, then again its projection on y-axis is this much. Now it means that now it is coming down. What is meant by coming down? So it means that again it is returning to the main position. So again it is returning back towards the main position. Clear? So when it reaches here, now it is as if it has reached to this position, again it is returning back. So by the time it reaches here, what is this position? This is covering an angle of 180 degrees. So by the time it has covered 180 degrees, particle is again present at the main position. Clear ma? So this is exactly what is happening now. So from extreme position, again when it is returning, again it has reached to an angle of 180 degrees. Clear? So similarly, when it reached here, then it means it has covered 90, 90 and 90, 270 degrees. So it is at a negative extreme position. So therefore at 270 degrees, it is at negative extreme position. And by the time it reaches here, it has completed one complete circle. It has completed 360 degrees. Clear ma? So again from negative extreme position to it reached to the mean position. So it is as if it has covered one circular path. Clear ma? So therefore SHM and circular motion, they are always comparable. Clear? Now let us see how we can easily do the problems by comparing SHM with circular motion. Clear? Let us see. So, let us take an example that clear ma? So let us consider particle has started from the mean position. This is the mean position. Clear ma? This is plus A and this is minus A. So let us consider the body has reached to a displacement of plus A by 2 and it is traveling towards positive extremity. Clear ma? So it has reached an angle of plus by A by 2 and it has reached to and it is traveling towards positive extreme position. Now by this time it covered a displacement of plus A by 2. I want to calculate how much angle it has covered. So SHM is always comparable with circular motion, no? So I want to calculate how much angle it has covered. How can I calculate? Again, displacement relation, I can use x is equals to A sine omega t. So A by 2 is equals to A sine omega t. Clear ma? So therefore, sine omega t can be written as A by 2 divided by A, which is called as 1 by 2. So therefore, theta is equals to omega t is equals to how much? 30 degrees. That is the meaning of this one. Clear? So by the time it has reached an amplitude of half of the amplitude, that is A by 2, body has covered only 30 degrees. Clear? That is from here to here, it covered only 30 degrees. Then from here to here, how much angle it has to cover? To travel from plus A by 2 to plus A, another half displacement. It has to cover 60 degrees because total 30 plus 60 is 90 degrees. So by the time it starts from the mean position, reaches the extreme position, it has to cover 90 degrees. Already we have discussed that one. So from mean position to half of the extreme position, it covered only 30 degrees. And then to travel remaining half distance, it has to cover 60 degrees. Clear? Then how can I calculate this calculation? By comparing this one with circular motion. Clear ma? So let us. So consider this is the path traveled by the particle, in which in this path the person is moving. So this becomes our main position. Clear? Then along the y-axis I am taking, this is plus A and this is minus A. Clear ma? So person is starting from here and he will reach to a displacement of plus A by 2. That is what we have studied now. So therefore it means if I draw a perpendicular onto this one, then this is the position up to which the body has reached. Now if I draw the radius vector, this will be the radius vector. If this is plus A, this is also plus A. Are you able to understand ma? Now here a right angled triangle is already constructed. Clear? So if I take this angle, or let us do one thing, this plus A by 2 I can draw here also. Clear ma? If this is plus A by 2, then this distance is also plus A by 2. Now if I take this angle to be angle theta, so this is the angle covered by the body, theta is equals to omega into t. Clear ma? So if I take this, how can I calculate this theta here? Here there is a right angle triangle, opposite side hypotenuse. So I will take a sine theta. Sine theta is the ratio of opposite side divided by hypotenuse. Are you able to understand? So therefore, sine theta is equals to opposite side value is A by 2, hypotenuse is A, so 1 by 2. So this is equals to, theta is equals to omega t is equals to 30 degrees. So this is how we have calculated. It means when it has covered a displacement of half of the maximum displacement, then it is equivalent to, it has covered 30 degrees in the circular path. Are you able to understand ma? So here we have calculated by using the equation and here we have calculated by using trigonometry. Clear? And not only by using this right angled triangle, by using the another right angled triangle also we can calculate. Let us see how we can do. So if I calculate this angle as alpha, clear? So to this right angle triangle, this becomes the hypotenuse, this is the adjacent side and this is the opposite side, clear? So I know the values of adjacent side, which is a by 2, and hypotenuse, which is a. So therefore I will use cos theta. So cos theta is equals to adjacent divided by hypotenuse. Are you able to understand, ma? So therefore adjacent value is a by 2, hypotenuse is how much? Hypotenuse is a. So cos theta is equals to a 1 by 2. So therefore theta is equals to, or this alpha value we have calculated as alpha, no? Okay. So alpha is equals to 60 degrees, because cos alpha is 1 by 2 only when our angle is 60 degrees. Clear? So this is 30 and this angle is 60 degrees. So if this angle is 60 degrees, definitely we can say this angle is 30 degrees, no? So by this also we can say body has covered an angle of 60 degrees. Are you able to understand, ma? So by using the concept of right angle triangle and trigonometry, very easily we can calculate the displacement of the particles and initial phase of the particle and what is the angle covered by the particle, all these values. Are you able to understand, ma? So let us see some more examples of this one. Okay. For example, let us consider so body has started from the main position, clear, ma? So body has started from the main position, and when I have started observation, body was present at minus a by 2 and it was traveling towards negative extreme position, clear, ma? So this is minus a and this is plus a. Okay. Then I want to calculate body has covered how much angle. So angle covered by particle in circular motion, clear? So particle has covered how much angle when body is present at this position. Definitely it started from the mean position, and when after some time it has reached to negative extreme position, and in the negative extreme position where it is moving towards negative extremity. It means that in terms of calculation, let us see simply how we can do. From here to here it should have covered 90 degrees, clear, ma? And then to return back from positive extreme position to main position, it should have covered one more 90 degrees. So therefore totally 180 degrees. By the time it reached here, phase is 180. So it has covered 180 degrees of phase, clear, ma? And from the mean position to go to another extreme position, it should cover how much angle already we have calculated now. From the mean position to go to a displacement of plus a by 2, body should cover an angle of 30 degrees, clear, ma? So therefore from here to here it should cover additional 30 degrees. So 180 plus 30 is 210 degrees. So therefore angle covered by the particle is equal to 210 degrees. This is how I can calculate, clear, ma? Now by using circular motion, let us see how we can do the same calculation, clear? Let us see. So therefore this is the circular path in which the body is moving, clear? So this becomes our main position. So this is a positive extremity and this is negative extremity. Particle has reached from the mean position. So from the mean position it goes to extreme position. So first it reached this position, and from negative extreme position it is returning back to the mean position. So it has returned to the mean position, clear, ma? So from here it reached to a displacement of minus a by 2, which is minus a by 2. This position will become minus a by 2, clear, ma? It means particle has reached up to here, clear? So if I draw the radius vector, so this is radius vector a. Are you able to understand? So if this is minus a by 2, then this distance is also equal to, magnitude wise it is equals to a by 2. Okay. So if I calculate this angle theta, to this angle theta, this becomes the opposite side, this becomes the hypotenuse whose value is a, clear, ma? So therefore I can calculate sin theta is equals to opposite divided by hypotenuse. So opposite side is how much? Opposite side is a by 2, adjacent side is a. So therefore sin theta is equals to 1 by 2, so therefore theta is equals to 30 degrees, clear, ma? So if this angle is 30 degrees, then how can I calculate total angle? Very simple. It has started from here, no? So to travel from here to here, this angle covered is 90 degrees. To travel from here to here, another 90 degrees. And to travel from here to here, an additional 30 degrees. So 90 plus 90, 180, 180 plus 30 is 210 degrees. So very simply we have done the calculation. So are you able to understand, ma? So with the help of circular motion, very easily we can do the calculations. Clear? So let us see one more example. Okay. So let us try to understand with the help of one more example. Clear? Okay. So Let us consider particle has started from the mean position. Clear ma? It has started from the mean position plus A. This is plus A and this is minus A. This becomes our mean position. Clear? So it has reached to minus A by 2, but it is going towards the mean position. It is going towards the mean position. Now when I see particle in this position, now can we say what is the phase of the particle or what is the angle covered by the particle? Let us see how we can calculate. First, with the help of this diagram, we will try to calculate. Clear? So 0 from here to here, it has to reach 90. Then it has to return back. Clear ma? So another 90, which is 180 degrees. Then from 180, it should reach to another extreme position. So 180 plus 90 is 270. From 272, it has reached up to here, no? So from extreme position to the displacement of half of the amplitude, it should cover 60 degrees. What is the reason? Already we have discussed this one, no? So from the mean position to reach to a displacement of plus A by 2, it has to cover 30 degrees. And from A by 2 to A, it has to cover 60 degrees. It means from extreme position to half of the displacement, it has to cover 60 degrees. Clear ma? So therefore, from the extreme position to a distance of A by 2, it has to cover an additional angle of 60 degrees. So 270 plus 60 is how much? 270 plus 60 is equals to totally 330 degrees it has to cover. Clear? Now same concept I will try to prove with the help of circular motion. Let us see how simply we can calculate by using circular motion concept. Clear ma? So this is our mean position. This is plus A and this is our minus A. So this is plus A by 2 and this is our minus A by 2. Clear ma? Minus A by 2. Now what is that position? Let us see. Clear? So from mean position to extreme position. So body reached up to here. Clear? So from extreme position to mean position, body again reached up to here. Clear? So from the mean position again to another extreme position. It means body already has reached here. So from here again it is returning back towards the mean position and now it is at a displacement of minus A by 2. It means body has covered all these displacements and finally it has reached up to this position. Are you able to understand ma? Now it is going towards the mean position. Still it has not reached the mean position. It is going towards the mean position. Clear ma? So this is minus A by 2. So if I draw the radius vector, then radius vector has a length of A. Are you able to understand? So therefore, let us calculate this as A. This is the radius vector. Clear ma? So therefore, if this is minus A by 2, this is also minus A by 2. So if I calculate this angle, you can calculate this angle also. I am calculating with the help of this angle. Clear? So in this right angle triangle, I can use sin theta again. So sin theta is equals to magnitude wise A by 2 divided by A, which is called 1 by 2. So again theta is equals to 30 degrees. Clear ma? It means that to reach to the mean position, it has to cover an additional angle of 30 degrees. Clear? Still it did not reach the mean position, no? Still it did not reach the mean position. It is about to reach the mean position. Clear ma? So if it covers additional 30 degrees, then total 360 degrees will be completed. But still it has to cover 30 degrees. Therefore, angle or phase of the particle, or you can call it as angle covered by particle, is equal to how much? 360 minus 30 is equal to 330 degrees. That's all very simple. Are you able to understand ma? So in this method, very easily we can calculate the values by comparing simple harmonic motion with circular motion. Point is very simple. Always we consider particle to be starting from the mean position. Clear ma? And this direction we take to be positive direction and opposite direction we always take to be negative direction. Okay? From the mean position, if it reaches one extreme position, it means it has covered 90 degrees. From extreme position to it reaches mean position, another 90 degrees. Clear ma? And from the mean position to a distance of A by 2, 30 degrees. From A by 2 to A, 60 degrees. Clear? So if you remember these concepts, very easily we can compare simple harmonic motion with circular motion and very easily we can do the problems. Clear? Okay. Dear students, now let us see the phase difference between two particles which are performing simple harmonic motion. Clear ma? So first of all, let us see two particles which are in phase. Clear? So what is meant by in phase? Let us see. So for example, this is the path along which the body is performing simple harmonic motion. So this is the mean position. And when I started observation, one particle was traveling in one direction and another particle was also traveling in the same direction. So both of them, they are present at the mean position and they are traveling towards positive extremity. Clear? So this is possible if phase difference between them is 0. What is phase difference? Angle covered by these particles, if it is 0, then definitely both of them, they will start at the main position and they will be traveling towards the same direction. Clear, ma? So definitely I can say here, phase of first particle can be 0 and phase of second particle also will be 0. So therefore, phase difference between them will be, so this is pi 1 phase of first particle, this is pi 2 phase of second particle. So pi 1 minus pi 2 is equal to 0 minus 0 is equal to 0. So I can say like this. So I can say these particles are in phase, they are in phase. Clear, ma? So it is also possible that, for example, let us see here. For example, let us consider one particle, it has started from the main position. This is the main position. Clear, ma? It started from here and it completed one oscillation. What is meant by completed one oscillation? It traveled from 0 to 90, then it went from 90 to 180, and 180 to 270, and finally to, again it returned to 360 degrees. So it means that it has completed one oscillation. So therefore, phase of the first particle, I can call it as 360 degrees or 2 pi radians. So at that instant, let us consider another body has started its motion. Clear, ma? So by the time first particle has completed one oscillation, second particle is ready to start its motion, or it has started motion from the main position. Clear, ma? Then also both the particles, they will be at the main position and they will be traveling towards the positive extremity. Now in this condition, what is the phase difference between them? So now phase of the first particle is 360 degrees and phase of the second particle is 0 degrees, because now just it is about to start its motion. Clear, ma? So therefore here I can write phase of first particle, I can call it is equal to 360 degrees or 2 pi radians. Clear, ma? Similarly, phase of second particle, I can call it to be 0 degrees. Now, what is the phase difference between them? Phase difference between them will be equal to, so if this is pi 1, I can call it as pi 2. So pi 1 minus pi 2 is equals to 360 minus 0 is equal to 360 degrees, or I can call it as 2 pi radians. Clear, ma? So definitely here also I can say the particles are in phase. Why particles are in phase? Because both of them are at the same position and they are traveling in the same direction. Clear, ma? So phase difference can be 0, but still the particles can be in phase. Phase difference can be 360 degrees or 2 pi radians, then also particles can be in phase. Similarly, how can I say at which angles the particles will be at phase? Definitely you can say when phase difference between them is 0, 360 degrees, 360 plus 360, 360 plus 360 plus 360. So for all these angles, for a difference of 2 pi radians, particles are always in phase. Clear, ma? So for example, we can consider that this particle has completed 2 oscillations starting from the main position. So if it has completed 2 oscillations, it means it has covered 4 pi radians. 2 pi plus 2 pi, 4 pi radians it has covered. At that instant, this particle is starting its motion from the main position. So phase of the second particle is 0. Clear? So phase difference, again both the particles will become 4 pi minus 0 is 4 pi radians. So therefore, what can I say? Therefore, particles are said to be in phase. Clear? When phase difference between them is 0, 360, 0 degrees, 360 degrees, 360 plus 360, comma, 360 plus 360 plus 360, and it goes on like this. Similarly, in the form of radians, how can I write? Phase difference should be 0 radians, 2 pi radians, 2 pi plus 2 pi, 4 pi radians, 4 pi plus 2 pi, 6 pi radians, and 8 pi radians, and it goes on like this. Clear, ma? So when phase difference between the particles is this much, then we can say the particles are in phase. So what is meant by particles are in phase? Both of them, they should be present at the same displacement from the main position, and they should be traveling in the same direction. Are you able to understand, ma? Then this is called as particles which are present in same phase. Clear? For example, if I say, so this is the main position, Clear, ma? And consider particles are present here. So one particle is traveling in this direction, another particle is traveling in the same direction. Both of them initially, they are at a displacement of plus a by 2. So definitely I can say these two particles are also in phase. Clear? Because both of them are present at the same displacement from the mean position, and both of them, they are traveling in the same direction also. Clear? Okay. Now after this, let us see what is meant by the particles which are out of phase. Okay. Now let us see particles which are out of phase. Clear, ma? So, if phase difference between particles is 180 degrees, then we say particles are said to be in out of phase. Clear, ma? So, let us try to understand this one by taking one example. So, for example, this is the particles performing simple harmonic motion. This is the mean position. And consider one particle is traveling in this direction, and one particle is traveling exactly exactly at the mean position, but in opposite direction. Clear, ma? So if I consider phase of this particle is 0 degrees, then what about the phase of this particle? Second particle, it should have started always from the mean position and towards positive extremity. Clear? So therefore from here it should have covered 90 degrees, and then again it should have returned to 180 degrees. Clear? So definitely you can say these two particles have a phase difference of 180 degrees. So here phase of first particle is how much? Phase of first particle is, this is our first particle, 0 degrees, and phase of second particle, I can call it to be 180 degrees. So therefore, what is the total phase difference? So, phase difference will be equal to, this is pi 2 and this is pi 1. So, pi 2 minus pi 1, so which is equals to 180 minus 0 is equal to 180 degrees. So this is the phase difference between these two particles. Are you able to understand? No? Similarly, one more condition is also possible. No? For example, how can I say? So this is one particle which is crossing the mean position and it towards the positive extremity. So second particle is traveling from the mean position towards the negative extremity in this direction. Clear, ma? So it should have been possible that, so this particle, it has covered already one more oscillation. So one more oscillation means it is coming to this position and to this direction for the second time. For the second time means what? It already completed one complete oscillation. Clear? So therefore, what will be the phase of this particle? Phase of this particle should have been an additional angle of 180 degrees. So therefore, total phase of this particle will be 180 plus 360. Clear? And for two oscillations and again one more additional oscillation of 180. So 360 plus 360 plus 180. And for third oscillation, 360 plus 360 plus 360 plus 180. Clear? So therefore, again the phase difference between these two particles are in the multiples of 360 degrees plus 180 only. So therefore, what can I write? So if it is completing a second oscillation, then this is particle 1, this is particle 2. So phase of first particle. Phase of first particle, I can call it to be 0 degrees. This is pi 1. And phase of second particle is, okay, so it completed one additional what you call oscillation. So total phase is 360 plus 180. Clear? So this is phase of second particle. So therefore, phase difference between both of them will be, so phase difference is equals to pi 2 minus pi 1. So which is equals to 360 plus 180 minus 0. So therefore, it is the phase difference is 360 plus 180. Clear, ma? So therefore, for which angles the phase difference will be 180 degrees, or for which angles, or what is the phase difference for which two particles will go out of phase. Clear, ma? So we can write like this. So therefore, particles will be out of phase. Particles will be out of phase for which angles? For 180, 360 plus 180, and for one more oscillation, 360 plus 360 plus 180, and it goes on like this. Are you able to understand? So for these angles, definitely I can say the particles will be out of phase. Clear, ma? Okay. Now similarly, how can I calculate phase difference between any two different positions? So let us see. Okay. For example, So let us consider, so this is the main position, this is the path in which bodies are traveling. So one particle is traveling in this direction, one particle is traveling towards opposite direction. So this is the plus A and this is minus A, and this becomes our main position. Are you able to understand me? So definitely I can say phase difference between them is, phase difference between them is how much? 180 degrees. Clear ma? So same phase difference I can represent with the help of circular motion also, because already we studied that SHM can be always compared with circular motion. So how we can compare? Let us see. So this one. Clear ma? So already we have studied that this will be our main position. Clear? So this is a positive extremity plus A and this is negative extremity minus A. Are you able to understand? And this total line will be our the position of zero displacement or main position. So first particle is present at the main position here and it is going towards positive extremity. So particle is moving actually in this direction. Clear ma? Now what about second particle? Second particle is also present on the main position, but it is traveling towards negative extreme position. It means particle is present here and it is traveling towards negative extreme position. Clear? So what is the phase difference between both of them? One particle is here and one particle is here. So phase difference between them is 180 degrees. So very easily I can calculate with the help of circular motion. Clear ma? Now let us see one more example. So consider one particle, this is the main position. So this is plus A and this is minus A. So let us consider this is at a distance of plus A by 2. Clear ma? So one particle was going towards plus A and another particle is going towards minus A. Clear ma? So, sorry, it is going towards main position and one particle is going towards positive extremity. Now can you say what is the phase difference between both of them? Clear? So by our previous knowledge, let us calculate phase of, this is our first particle and this is our second particle. So phase of first particle will be how much? Phase of first particle will be 30 degrees. Why? Because already we have studied, no? So to cover a displacement of half of the amplitude from the mean position, body should cover 30 degrees. Clear? Already we have calculated this one in the previous calculations. Clear? Now what about phase of second particle? Phase of second particle, how can I calculate? Let us see. Clear ma? Second particle is here, it is coming towards the mean position. Clear ma? So any SHM we consider to be starting from the mean position and towards positive extremity. So it means that this second particle also, it should have started from here. Then it should have gone to 90. Then from here to cover an amplitude of half of the amplitude, it should cover 60 degrees. Clear ma? From mean position to half of the amplitude, 30 degrees. From A by 2 to plus A, for second half displacement, it should cover 60 degrees. Already we have covered this one. We have studied this one. So from traveling from plus A to plus A by 2, it should cover an angle of 60 degrees. So totally 90 plus 60. 90 plus 60 is equals to 150 degrees. So this is the phase of second particle. Clear ma? So this is pi 1 and this is pi 2. Clear? Now what is the phase difference between them? Phase difference is equal to pi 2 minus pi 1. So pi 2 value is how much? 150. Pi 1 value is 30. So therefore 120 degrees is the phase difference between these two particles. Clear? How can I calculate the same calculation by using circular motion? Let us see. So very easily we can do this calculation. Sigma. So this is the circular motion. This becomes our main position. And this is on the y-axis. This is positive extremity and this is negative extremity. Are you able to understand ma? And this distance is plus A by 2, half of the amplitude, and this distance is minus A by 2, half of the amplitude in the negative direction. Clear? So where is our first particle? First particle started from the mean position. It is at a displacement of plus A by 2. It means that particle is present here. It started from the mean position and it is going towards the positive extremity. Clear ma? So if I draw the radius vector, this should be the radius vector whose magnitude is also A. So this displacement is plus A by 2. So therefore I can say this displacement is also equal to plus A by 2. Clear ma? Now what about second particle? Second particle, it is traveling from the positive extreme position. It is traveling from the positive extreme position and it is going towards the mean position. So particle should have been somewhere here. Are you able to understand ma? Because it is returning from plus A and going towards the mean position. This is our mean position. So particle is traveling in this direction and it reached this position. Are you able to understand ma? So therefore again if I draw the radius vector, this is also having an amplitude of A, and this height which is equals to plus A by 2 because it has covered half of the amplitude from the mean position. Okay, ma? So now what is the phase difference between these two particles? So this is our first particle, this is our second particle. So this is the phase difference between them. Are you able to understand, ma? So how can I calculate this phase difference? Let us see. So here I will try to construct a right angle triangle like this. So if this is a by 2, this is also a by 2. Clear, ma? So let this angle be theta 1 and let this angle be theta 2. Here also I am constructing a right angle triangle. So this is theta 2. So how can I calculate cos theta 1? This is adjacent side, this is hypotenuse. Adjacent side is a by 2. This is a by 2, this is also a by 2. So a by 2 divided by a is equals to 1 by 2. So therefore theta 1 is equals to how much? 60 degrees. Because cos 60 value is 1 by 2. Similarly, what about this angle? So here also adjacent side is a by 2, hypotenuse is a. So therefore cos theta 2 is also equal to a by 2 divided by a, which is called 1 by 2. So therefore theta 2 is again equal to 60 degrees. Clear, ma? So theta 1 plus theta 2 is 120 degrees. So therefore phase difference between these two particles is how much? Theta 1 plus theta 2, which is equals to 60 plus 60 is equals to 120 degrees. So that was the same answer which we got previously. Are you able to understand, ma? So not only by using this right angle triangle, by using this right angle triangle also we can calculate the value. Clear, ma? So total angle in a straight line should be 180 degrees, no? So if I take this one as alpha 1 and this one as alpha 2. So alpha 1, how can I calculate? Sin alpha 1 is opposite by hypotenuse. So a by 2 by a, so alpha 1 will become 30 degrees. If this is 30, this is also 30. So 30 plus 30 is how much? 60. So 180 minus 60 is 120 degrees. So like this also we can calculate. So either you can use sin theta concept or cos theta concept in the case of circular motion. Are you able to understand, ma? So this is how we can calculate phase difference between two particles. Now let us take one more example. So which example shall we take? Let us. So let us consider, clear, ma? So let us consider this is the path traveled by the particles in SHM. This is the main position. So this is plus a and this is minus a. Clear? Now let us consider this is minus a by 2. This is a displacement of minus a by 2 from the mean position. So let us consider one particle was traveling in this direction, one particle was traveling in opposite direction. This is particle number 1 and this is particle number 2. Clear? Then let us see how can we calculate phase of first particle. Clear, ma? Phase of first particle is how much? Clear? So already we discussed that phase always we should measure from the mean position and towards the positive extremity. So every particle we assume as if it has started from the mean position and towards the plus a. From there we start measuring the angle. Clear, ma? So therefore this first particle, it should have traveled, reached up, initially it should have started from here. So it should have covered 90, another 90, 180, another 90, 270 and returning back. While returning back from extreme position to an amplitude of a by 2, particle should cover 60 degrees. Already we have studied this one. So phase of the first particle is how much? 90 plus 90 plus 90 plus 60. So total how much? So 180, 270, 330 degrees is the phase of the first particle. Clear, ma? Now what about phase of second particle? Phase of second particle, how we can calculate? Let us see. Clear, ma? So this is pi 1, pi 2 we are calculating. See. So this particle also it should have started from the mean position, no? So 90, 180, 180 plus 30. From the mean position to a displacement of half of the amplitude, angle covered by the particle is 30 degrees. Already we have calculated this one. So therefore 90 plus 90 plus 30. So 180 plus 30 is 210 degrees. So which is equals to pi 2. Clear? So therefore what is the phase difference between them? Phase difference is equal to, so 330 minus 210 is equals to how much? 120 degrees. This is the phase difference between these two particles. Clear, ma? So similarly, how can I prove the same thing by using circular motion concept? Let us. So again we are using the same concept of circular motion. Clear, ma? So first of all, identify the positions of these particles in this circular path. Clear? So this is the circular path. So this is plus a by 2 and this is minus a by 2. Clear, ma? This is plus a and this is minus a and this becomes our main position. Clear? So what about the position of the first particle? First particle is present at a displacement of minus a by 2 and it is going towards the main position. So therefore what can be the position of the particle here? Why it is here? Because Clear ma? So it is traveling towards the mean position. It already crossed negative amplitude. It is crossing the negative amplitude. No, it is returning from minus a, and it is at a displacement of a by 2 and going towards the mean position. So definitely this is the position of the particle. Clear ma? So therefore, if I draw the radius vector whose amplitude is a, so this is the first position of the first particle. Now what about second particle? Second particle, it crossed the mean position and it is going towards minus a. So therefore, it is coming towards minus a, and it has just crossed the mean position. So therefore, its position should be here. It is crossing the mean position going towards minus a. Clear ma? So again, if I draw the radius vector, so this is the position of the second particle. Are you able to understand ma? Now what is the total phase difference between them? This is the total phase difference between these two particles. Clear ma? Angular displacement is that much. So how can I calculate that phase? So definitely let it be theta 1 and let it be theta 2. How can I calculate theta 2? So construct a right angle triangle. Here also one right angle triangle. Here also one right angle triangle. So this becomes the adjacent side, which is having an amplitude of a by 2, and this is the hypotenuse, which is having an amplitude of a. Clear ma? So therefore, cos pi by 2 cos theta 1 is how much? Adjacent by hypotenuse. So a by 2 divided by a is equals to 1 by 2. So therefore, theta 1 is equals to 60 degrees. So if this is 60, theta 2 is also equal to 60 degrees. So therefore, what is the total phase? Total phase difference between them is how much? It is theta 1 plus theta 2, which is equal to 120 degrees. So that was the same result which we got by this calculation also. No? So this is how I can calculate phase difference between any two particles. Okay, so make a note up to here. Now let us see how we can write a general equation to calculate phase difference and time difference between two particles. Clear ma? So angular frequency of two particles, angular frequency of two particles is same. Clear ma? That is omega 1 is equals to omega 2 is equal to omega. So what is meant by angular frequency is same? So both the particles, they are covering the same angle in same time. Or you can say angular velocity is also equal. Clear ma? Then how can I calculate this angular frequency? This is called angle covered in unit time. Are you able to understand ma? So therefore, this I can write it as for first particle, omega is equals to pi 1 divided by t1. So that is the angular frequency of first particle is angle covered by the particle divided by time taken. Similarly, angular frequency is same for both the particles. No? So for second particle, I can write angle covered is pi 2 divided by t2. So therefore, what can I write? Pi 1 is equals to omega into t1. Pi 2 is equals to omega into t2. Clear ma? So this becomes the phase of the first particle, phase of the second particle. Phase is nothing but angle covered by the particles. Clear ma? So therefore, how can I calculate phase difference between them? Phase difference is nothing but pi 2 minus pi 1. Pi 2 value is how much? Omega into t2. Pi 1 value is omega into t1. So therefore, phase difference between them, pi 2 minus pi 1, can also be written like this. So omega into t2 minus t1. So therefore, this equation can also be written like this. Already we know that omega is equals to 2 pi divided by capital T, equation for angular frequency. So therefore, how can I write? Phase difference between them is equals to 2 pi by capital T into T2 minus T1 can be written as delta T. So this is the relation which can be used to calculate phase difference between two particles if I know the time difference. What is delta T there? Delta T is called as the time difference. Okay, if I know the time difference between these two particles, very easily I can calculate the phase difference. Clear ma? So let us calculate, for example, time difference is equal to T. What is meant by time difference is equal to T? So time difference between both the particles is equals to one time period. So therefore, what can I write? Phase difference between them will be equal to 2 pi by capital T into T, which is called as 2 pi radians. Similarly, let us see second one. So delta T is equals to T by 2. Phase time difference between both the particles is half of the time of oscillation. So therefore, phase difference between them will be equal to 2 pi by capital T into T by 2, so which is called as pi radians. So this is how I can calculate the phase difference between two particles as well as time difference between the particles. Clear? So this is a very important equation by which very easily we can calculate the phase difference if I know the time difference. Similarly, if I know the phase difference, I can calculate time difference also. Clear ma? That's all. Dear students, now let us see this question. So an SHM is given by x is equal to 10 sin 20t plus 0.5. So write down its amplitude, angular frequency, time period and initial phase. Units are given in meters and seconds. So let us see what is the equation given. X is equals to 10 sine 20t plus 0.5. Clear ma? So if I compare this one with the original equation of SHM, I can write X is equals to a sine omega t plus pi. So this is how I can write. So what is the first equation? First one he is asking amplitude. So amplitude is nothing but 10 here. So A is equal to 10 meters. Clear ma? Second one he is asking angular frequency, nothing but omega. So compare this one. Omega is equal to 20 radians per second. Clear? And what is the third one he is asking? Third one is frequency. So omega is equals to 2 pi into f. So therefore f is equals to omega divided by 2 pi. So f is equals to omega is 20 divided by 2 pi. So this is equal to 20 divided by 2 into pi value is 3.14. So therefore the answer which I should get is 20 divided by 6.28, approximately 3.18 hertz. Clear ma? And what is the fourth one he is asking? Time period. So time period is reciprocal of frequency. So 1 by 3.18, which is equal to approximately 3.14 seconds. And the fifth one he is asking initial phase. Initial phase is nothing but pi. So directly here answer it is given pi is 0.5. So pi is equals to 0.5 radians. Clear? So just we have compared the given equation with the equation of SHM. So we got these answers. Okay. Dear students, now let us see the next question. So a particle executes SHM with a time period of 2 seconds and amplitude 5 centimeter. After 1 by 3 seconds, find displacement, velocity and acceleration starting from the mean position. So what is meant by starting from the mean position? It means that initial phase constant is 0. So therefore, how can I write the equation of this one? I can write, so x is equals to a sine omega t plus pi. Actually, this is the equation of simple harmonic motion. And he is saying that particle is starting from the mean position, and let us assume that it is traveling towards positive x-axis. So therefore, I will write pi value to be 0. So therefore, x is equals to, amplitude is already given 5 sine, omega can be written as 2 pi by capital T into t. So x is equal to 5 sine 2 pi by, time period is given as 2 seconds, and at what instant? 1 by 3 second. So x is equals to 5 sine, so pi by 3. Pi by 3 is nothing but 60 degrees. So therefore, x is equals to 5 sine 60 is root 3 by 2. So 5 root 3 by 2 centimeters. So this is the displacement of the particle after 1 by 3 seconds. Similarly, let us calculate velocity. So how can I calculate velocity? Velocity is nothing but a displacement of differentiation of displacement. So therefore, velocity is equals to d by dt of, and what is the displacement given? Displacement equation already we have written, which is equals to a sine omega t. So therefore, if I differentiate this equation, then I will get a omega cos omega t. So already we have done this differentiation previously. So therefore, v is equals to, what is a value is amplitude 5 into 2 pi by t cos 2 pi by t into t. So therefore, v is equals to 5 into 2 pi by, instead of capital T, 2 seconds, because time period is given as 2 seconds, cos 2 pi by 2 into 1 by 3. Clear? So therefore, v is equals to 5 pi, and this is cos 60 value is 1 by 2. So therefore, is equal to 5 pi by 2 centimeters per second. So this is the velocity of the particle. Clear? Let us see next, third one, which is given as acceleration. Also we are supposed to find out. So let us see how we can calculate acceleration of the particle. So acceleration is the differentiation of velocity with respect to time. Clear? So a is equals to d by dt of velocity. Velocity is a omega cos omega t. So therefore, a is equals to d by dt of a. So already we have differentiated this equation previously. So we will write minus a omega square sine omega t, sine omega into t. So therefore, a is equals to minus, a value is 5 and omega is 2 pi by 2 whole square, and sine 2 pi by t is 2 and time is 1 by 3 seconds. So therefore, a is equals to minus 5 pi square sine 60. Sine 60 degrees is root 3 by 2. So therefore, it is equals to minus 5 pi square into root 3 divided by 2 centimeters per second square. Clear? So this is how we can calculate displacement, velocity and acceleration. Okay, so let us go for the next question. So now let us see the next question. So a particle in SHM, it has a time period of 3 seconds. Clear? And amplitude is given as 25 centimeters. So what is the minimum time required by the particle to move between 12.5 centimeters on either side of the main position? Clear? So what is meant by on either side of the main position? So let us see what is the meaning of this one. So 12.5 centimeters is exactly half of the amplitude, that is 25 centimeter. So therefore, so this is amplitude which is 25 centimeter plus 25, and this is minus 25 centimeters. Are you able to understand? So therefore, this is plus a by 2 and this is minus a by 2, which is called 12.5 centimeters. Okay. So he is asking minimum time to travel from plus a by 2 to minus a by 2 or minus a by 2 to plus a by 2. Now what is meant by minimum time? Let us see. So for example, particle can start from here, that is from the mean position. It can travel from the extreme position and it can return to the another extreme position or up to a displacement of minus a by 2. Clear? So time taken from here to here also, it is the distance from plus a by 2 to minus a by 2. So that is traveling throughout this motion, returning up to here. Clear? But it's not, this is not what he is asking. He is asking only time taken from here to here. That is when it is returning back to travel from my plus a by 2 to minus a by 2, only this much time taken he is asking. Okay, so how can I calculate this one? So first of all, I will calculate the time taken to travel from mean position to plus a by 2. This distance I will calculate. Clear? Because if time taken from mean position to plus a by 2 is 1 second, then from plus a by 2 to mean position also will be 1 second only. Are you able to understand, ma? So therefore, first of all, I will calculate from mean position to plus a by 2. Because this calculation is very easy. Because already we have studied that a particle starting from the mean position and going towards positive extremity, for that already we have relation x is equals to s sin omega t. No need of considering the initial phase constant. Clear? So in that method I want to do. So this is our first method of doing the problem. Are you able to understand? So therefore, what can I write? I can write x is equals to a sin omega t. In which condition we can use this relation, ma? When particle is starting from the mean position, particle is starting its motion from the mean position and going towards positive extremity, then we can use this relation. Clear? So up to which distance it is moving? Up to a distance of 12.5 centimeters. Amplitude is 25 sin omega into t. So therefore, this is 1 by 2. 1 by 2 is equals to sin omega t. So therefore, I can write omega t is equal to 30 degrees, which is called as pi by 6. Clear? So therefore, omega can be written as 2 pi by capital T into T is equals to pi by 6. Clear? And time period, how much? Time period he gave it is 3 seconds, so substitute here. So 2 pi by 3 into T is equals to pi by 6. Clear, ma? So 3 1s are, 3 2s are, and this pi and pi gets cancelled. So T is equal to 1 by 4 seconds. Clear, ma? So therefore, time taken from 0 to plus a by 2 is equal to 1 by 4 second. So therefore, time taken from plus a by 2 to mean position also will be plus 1 by 4. But this is not what I want to know. I want from plus a by 2 to minus a by 2. So plus a by 2 to 0 is 1 by 4. 0 to minus a by 2 is another 1 by 4. So therefore, total time taken will be 1 by 4 plus 1 by 4, which is called as 1 by 2 seconds. Clear? So in this method, I can do the calculation. Clear? And let us see, by using circular method, how we can do the calculation. By comparing a system with circular motion, very easily we can do the calculation. So let us see how we can do. So this is second method of doing the calculation. Are you able to understand, ma? So let us see from where to where we are studying the motion. We are studying the motion from this plus a by 2 to minus a by 2. From here to here. This motion we are studying. Clear? So directly we cannot take this motion, no. Body should have started from the mean position initially. Body should have started from the mean position towards positive extremity. Clear? Therefore, first of all, he should have reached maximum position. Now he is returning from maximum position to mean position. Clear? So therefore, how can I draw a circular graph diagram of this one? Let us see. So this is the circular path in which particle is moving. So this is the mean position, and this becomes plus a and this becomes minus a. Clear, ma? Now the question is, where shall I mark the points from where to where the particle is moving? So first of all, particle started from the mean position from here. Then it went to positive extremity. This is positive extremity. From here it is returning back. Then we will get this point. Clear? So this is plus a by 2 and this is minus a by 2. Clear, ma? Now particle is where it is returning from the mean extreme position to a displacement of a by 2. It means from here the particle has reached up to this position. So this is my initial position. Are you able to understand? And from this position, now it crosses the mean position. This is the crossing of mean position. And after the mean position, it will go to minus a by 2. And this is our minus a by 2. Clear, ma? So therefore, this is the point. So this is how I can draw the radius vector. It means the particle has started from here and he reached up to this position. So this is the comparison of SHM on circular motion. Are you able to understand? Now, what is the phase difference between them? Let us see. Clear, ma? So let us consider this angle is theta. Then this angle also will be theta, equal angles. Because this is also a by 2 and this is also a by 2. Clear, ma? So therefore, if this is plus a by 2, this is also a by 2. And if this is plus a by 2, then this is also equal to a by 2. Magnitude wise, it is a by 2. Clear, ma? So therefore, how can I calculate sin theta? I will try to calculate here. So sin theta is equals to opposite by hypotenuse. So opposite side how much? It is equal to a by 2. And hypotenuse is nothing but radius of the vector, which is called plus a. So divided by a. Clear? No need of plus a, just a. Magnitude wise we can write. So therefore, sin theta is equals to 1 by 2. So therefore, theta is equal to 30 degrees. Clear, ma? So if this is 30 degrees, then this is also equal to 30 degrees. So therefore, what is the phase difference between them? Phase difference between them is 60 degrees. Clear? That is a particle traveling from plus a by 2 to minus a by 2 in minimum distance. That is equal to covering a phase of 60 degrees. Clear? So if a phase difference is 60 degrees, how can I calculate time taken? For that already we have written a relation previously. What is that one? So phase difference is equals to 2 pi by capital T into delta T. This is the relation which we have written. Relation between phase difference and time difference. Clear, ma? So therefore, phase difference is how much? 60 degrees. So 60 degrees can be written as pi by 3 is equals to 2 pi divided by capital T. Capital T is the total time. And what is the total time he gave? 3 seconds. So 3 into delta T. Clear, ma? So 3 and 3 get cancelled. So therefore, what can I write? Pi and pi gets cancelled. So delta T is equals to half second. Okay, so that was the same result which we got previously. Clear? So by comparing SHM with circular motion, very easily we can do this calculation. Okay. Now let us see the third method of doing this problem. So we are saying that particle is traveling from plus a by 2 to minus a by 2 in this path. Clear? So initially, what is the phase of the particle when I have started observation? Clear, ma? So to travel from mean position to this position, it has to cover 90 degrees. And from extreme position 2 to reach half of the amplitude, it should cover another 60 degrees. So total initial phase of the particle can be written as t plus 60, which is equal to 150 degrees. Clear, ma? So therefore, directly I can use the relation. Now x is equals to a sine omega t plus pi. And what is this pi? This is the initial phase constant. So therefore, x, what is the position of the particle now? Minus a by 2 is equals to, because it has to reach to a position of minus a by 2 only, no? So minus a by 2 is equals to a sine omega t plus 150 degrees, because 150 degrees is the initial phase of the particle. That is, particle when it is present here and it is going towards the mean position, then phase of the particle is 150 degrees. Clear? So therefore, a and a I can cancel. So therefore, minus 1 by 2 is equals to sine omega t plus 150 degrees. Clear, ma? So at which angle sin theta will become minus 1 by 2 for 210 degrees. So therefore, I can write. So for what is the total angle now? For omega t plus 150 degrees, sine of become minus 1 by 2. This total angle should be equal to 210 degrees. So therefore, omega t should be equal to 210 minus 150, which is equals to 60. Clear, ma? Omega can be written as 2 pi by capital T into T is equal to 60 degrees. So 2 pi divided by, what is the time period? Time period is 3 seconds. Into T is equal to 60 can be written as pi by 3. So 3 and 3 gets cancelled, pi and pi gets cancelled. So therefore, T is equals to 1 by 2 seconds. This was the same answer which we got in previous methods also. So in this method also, we can do the problem. Clear, ma? So once you are good at your basics, then you can do the problem in any method you like. Clear? Okay. Question. The equation of SHM is x is equals to a sine 2 pi t. If t1 is the time taken by the particle to travel from x is equals to 0 to a by 2, and t2 is the time taken by the particle to travel from x is equals to a by 2 to x is equal to a, then find the ratio of t1 by t2. This is the given question. Clear, ma? Now this question also we will try to do in different methods and see how we are using our knowledge of SHM to do the problems in all the methods. Okay, so first let us see the first method of doing this problem. See, ma. So initially what he is saying, time taken to travel from 0 to plus a by 2, that is from here to here. So 0 to plus a by 2. Clear, ma? So therefore, if a particle is present at the mean position and traveling towards positive extremity, then its initial phase is 0. So therefore, how can I directly write the relation x is equals to a sine omega t is equals to a sine, and what is the relation he gave? 2 pi into t. Clear, ma? So therefore, a by 2 is equals to a sine 2 pi into t. Clear? So a gets cancelled. So 1 by 2 is equals to sine 2 pi into t. So sine theta is equals to 1 by 2 for theta is equal to 30 degrees. So therefore, 2 pi t should be equal to 30 degrees, or in the form of radians, I can write it as pi by 6. So pi and pi gets cancelled. So t is equals to 1 by 12 seconds. Are you able to understand, ma? Similarly, now let us study the second condition. Second condition is time taken by the particle to travel from plus a by 2 to a. That is from here to here, what is the time taken? That we are supposed to find out. Clear? So that is, when I started observation, particle was already present at a displacement of a by 2. It means that already it has covered an angle of 30 degrees. Okay? In previous calculations already we have studied this one, Nama. So to cover a first angle of 30 degrees, body will take, to cover an amplitude of half of the amplitude, body will take 30 degrees. Then from a by 2 to a, it will take another 60 degrees, because from here to here, total phase it should cover is 90 degrees. Okay. So first a by 2, half of the amplitude 30 degrees, next half of the amplitude it will take 60 degrees. This already we have studied in the previous classes. So when I have started observation, body was already present at a by 2. It means already it has covered an angle of 30 degrees. So therefore, my initial phase, or you can call it as initial phase constant or epoch constant, is how much? It is equals to pi by 6, 30 degrees. Clear? So therefore, how can I write the relation? X is equals to a sine 2 pi t plus pi by 6. This is the initial phase constant. From here, particle should reach an amplitude of a. So a is equals to a sine 2 pi t plus pi by 6. Clear, ma? So therefore, this a and a gets cancelled. So I will get 1 here. So sine 2 pi t plus pi by 6, this is equal to 1. So sine theta is equals to 1 only when theta is equal to 90 degrees, or we can write pi by 2. So therefore, 2 pi t, here instead of this pi by 6, I will write 60 or 30 degrees. So this is equal to 90 degrees. Clear, ma? So 2 pi t is equals to 60. 60 can be written as pi by 3 also. So therefore, pi and pi gets cancelled. So t is equals to 1 by 6 seconds is our answer. Clear? So t1 is 1 by 12, t2 is 1 by 6. Now he is asking the ratio of t1 divided by t2. So therefore, ratio of t1 by t2 can be written like this. So 1 by 12 divided by 1 by 6. So 6 by 12 is equals to 1 by 2 seconds. 1 by 2, sorry, not seconds, half ratio. Ratio is t1 by t2 is 1 by 2. Clear, ma? So this is the first method of doing this problem. Clear? Now let us see the second method of doing the same problem. So second method, how can I say, what given equation is x is equals to a sine 2 pi into t. Clear, ma? So therefore, x value is so much from a displacement of 0 to a by 2. So a by 2 is equals to a sine 2 pi into t. Clear? So a gets cancelled. So sine 2 pi into t is equal to 1 by 2. So therefore, this total angle should be equal to 30 degrees or pi by 6. So t pi by 2 pi t is equals to pi by 6. So pi gets cancelled. So t is equals to 1 by 12 seconds. So this is our t1. So now let us see if I compare this relation with a sine omega t. Clear, ma? then definitely I can say here omega is equal to 2 pi. So omega is what? Omega is 2 pi by capital T is equals to 2 pi by 1. So therefore I can write time period is equal to 1 second. Clear? Now the question is, what is meant by time period? Let us see. Clear? So already we have discussed this one now. So when particle starts from the mean position, so time period is 1 by seconds means what? So it starts from here to here. So this is a t by 4 seconds, from here to here, another t by 4 seconds, from here to here, another t by 4 seconds, and from here to here it is another t by 4 seconds. So total time period I can divide into 4 parts. Clear? So therefore, from here to here, that is from 0 to a plus a, the time taken is t by 4. So which is equals to 1 by 4 seconds is the time taken from 0 to plus a. Are you able to understand, ma? Now already we have studied that time taken from mean position to this displacement. From 0 to plus a by 2, the time taken already we have calculated, which is equals to 1 by 12 seconds. Now how can I calculate time taken from plus a by 2 to plus a? So here already we have calculated, no? From 0 to plus a, time taken is 1 by 4 seconds. Clear, ma? So therefore, time taken for the particle to travel from time taken by the particle to travel from plus a by 2 to a. This will be how much? This will be equal to 1 by 4 minus 1 by 12. Because from 0 to an amplitude of a, time taken will be 1 by 4 second. So 1 by 4 minus 1 by 12 second. So therefore 12, if I take the LCM, then 3 minus 1. So 2 by 12 is equal to 1 by 6 seconds. So which is called as a T2. Clear, ma? So therefore time taken for the body to travel from 0 to a by 2 is 1 by 12, and from a by 2 to a is 1 by 6. So therefore very easily I can calculate the ratio. T1 by T2 is equals to 1 by 12 divided by 1 by 6. So 6 by 12, which is equals to 1 by 2 seconds. Clear? So this is the second method of doing the problem. Clear? Now let us see the third method of doing the same problem also. So let us see the third method. Clear, ma? So now particle is traveling from where to where? So it is traveling from 0 to a by 2 and from a by 2 to a. Clear? So in third method, that is comparing a system with circular motion. Clear, ma? So in this third method, what can I write? So this is our main position. So this is positive extremity and this is negative extremity. Clear, ma? And this is an amplitude of plus a by 2. Okay. So initially particle will travel from here to here by covering an angle of theta 1. Clear? So that is from 0 to a by 2. So 0 to plus a by 2, it will cover an angle of theta 1. Clear? Then from a by 2 to a, then it has to cover an angle of theta 2. Clear, ma? So therefore, what is theta 1? So if this is plus a by 2, this is also plus a by 2, no? This magnitude is also a by 2. So therefore, and this radius vector is having a magnitude of a. So if I apply sine theta, because I know the opposite side and I know the hypotenuse. So sine theta is equals to a by 2 divided by a, which is called 1 by 2. So therefore, this is theta 1, no? So theta 1 is equals to 30 degrees. Clear? So therefore, particle has to cover an angle of 30 degrees. Okay? So if this angle is 30, then what is the remaining angle? We know that to travel from 0 to a by 2, the particle should cover 90 degrees. So if this is 30, this angle will be 60 degrees. Clear? So to cover an angle of 30 degrees, if time taken is, for example, t, then time taken to cover 60 degrees will be how much? Time taken to cover 60 degrees will be 2t. Clear? So therefore, this is the time taken called t1 and this is the time taken called t2. So therefore, t1 by t2 is equals to t by 2t, which is called as 1 by 2. So that is our ratio. Are you able to understand? That's all. Now let us see this question. So if the displacement and velocity of a particle are connected by this relation, 4v square is equals to 25 minus v square, then show that this motion is SHM and find its time period. Clear, ma? So again here, displacement and velocity, they are connected to each other. So therefore, the equation which gives a relation between displacement and velocity, what is that relation? V is equals to omega into square root of a square minus x square. This is the relation. And this is the x when particle is displacing along the x-axis. Clear? So therefore, if I can try to convert this relation in this form, then definitely I can say this motion is a simple harmonic motion. Clear? Ma? So therefore, let us see how we can convert. So v square is equals to 1 by 4 into 25 minus y square. So v is equals to 1 by 2 into root of 25 minus y square. Okay. So if I compare these two, definitely this equation is of this form. Okay, ma? So definitely I can say this motion is simple harmonic in nature. Then how can I find out time period? So we know here if I compare these two values, definitely I can say omega is equals to 1 by 2 and omega is nothing but 2 pi by capital T. So therefore, time period is equals to 2 pi divided by 1 by 2, which is called 4 pi seconds. Clear? So this is the answer for this question. Let us see this question. At displacements of x1 and x2, a particle in SHM has velocities v1 and v2. Show that the time period of oscillation is given by t is equals to 2 pi into x2 square minus x1 square divided by u1 square minus u2 square power 1 by 2. Clear, ma? So here a relation is given between velocities and displacements. Clear? So already previously we have studied two equations of velocity, no? One equation of velocity depending on time and another equation of velocity depending on displacement of the particle from the mean position. Clear, ma? So what is that equation? Let us see. So v is equals to omega into square root of s square minus x square. This was the relation which gives a relation between velocity and displacement. Clear? So therefore, I will try to write these equations also. So these are velocities v1 square and v2 square. Okay. So therefore, how can I write them? So v1 is equals to omega into square root of a square minus x1 square. v2 is equals to omega into square root of a square minus x2 square. This is how I can write the relation between them. Clear? Now by using these two relations, how can I calculate a time period? Clear? So omega, I know omega is equals to 2 pi by capital T, no? So from this omega, I am going to derive this equation of time period. But in the given equation, I see that there is no term called a amplitude is absent. So what can I do? So let us square both these terms and let us let us subtract them so that this omega square a square and omega square a square terms get cancelled. So what can I do? So squaring the terms, squaring the equations, what I will get, let us see. So first equation I will get v1 square is equals to omega square into a square minus x1 square. Similarly, second term v2 square is equals to omega square into a square minus x2 square. Clear? So here I have omega square a square, here also I have omega square a square. So why not subtract both of them? Clear? And here also I have the term v1 square minus v2 square. So v1 square minus v2 square, we will subtract them. So subtracting the equations, what we will get? So v1 square minus v2 square is equals to omega square a square minus omega square x1 square minus of omega square a square, minus of minus will become plus, so plus omega square x2 square. So omega square a square get cancelled. So therefore, if I take omega common, then I can write omega square into x2 square minus x1 square is equals to v1 square minus v2 square. Clear? So therefore, omega can be written as 2 pi by t, can be again written as, so it is a square root of v1 square minus v2 square divided by x2 square minus x1 square. Clear, ma? So therefore, what can I calculate for t? T is equals to, so 2 pi into square root of x2 square minus x1 square divided by v1 square minus v2 square. This is the relation which we got. Clear? Now compare this relation with the given answer. So this is the relation. So exactly it is correct. So this is how we can do this calculation. Now let us see the next question. So a particle has a velocity of 4 meters per second at a distance of 3 meters from the mean position and a velocity of 3 meters per second at 4 meters. Then find the time taken to travel 2.5 meters from the positive extremity. Clear, ma? So this is what we are supposed to find out. Clear? So again, this is a relation between velocity and distance. So again, we have to use the same relation which we have studied previously. So v is equals to omega into square root of a square minus x square. Clear? So let us write the first relation. So I have velocity of 4, angular velocity I don't know, amplitude also I don't know, but displacement is 3 square. Similarly, second relation is velocity is 3, Angular velocity is omega, square root of a square minus, and now displacement is 4, so 4 square. So this is the relation which we got. So let us do one thing. So let us square it and divide both of them. So if I square them and divide them, then I will get 16 divided by 9 is equals to omega, and omega get cancelled. So square root is going cancelled now. So a square minus 3 square divided by a square minus 4 square. This is the relation which we got. Okay. Now I will try to cross multiply this one. Then let us see what will happen. So 16a square minus 16 into 16 is 256. So this is equals to 9a square minus 9 9s are 81. Clear ma? So therefore 16a square minus 9a square is how much? 7a square. So this is equals to 256 minus 81 is how much? 175. So 175. So a square is equals to 175 divided by 7. So 7 3s are and 7 2s are, 7 5s are, so 25. So a is equals to 5. So 5 meters. Meters only, no, on 5 meters. So this is the amplitude of this particle. So amplitude of the particle is 5 meters. Maximum displacement from the mean position. Clear ma? So still with the help of this data, I cannot solve this problem. So he is asking time taken to travel from 2.5 meters from the extreme position. So only with the help of amplitude I can't do anything. So let us see. Let us try to calculate omega also. So therefore, take this amplitude and substitute in one of the relation. Then let us see how we can calculate amplitude. So therefore, I will use the first equation. So 16 is equals to, or let us write the original equation only. 4 is equals to omega into square root of 5 square minus 3 square. So 4 is equals to omega into square root of, so 25 minus 16 root 16 is 4. So omega is equals to 4 by 4 is 1 radian per second. Clear? So this is, I got angular velocity also, amplitude also I have. So now how can I calculate what is the time taken to travel from travel 2.5 meters from the positive extreme position? Clear ma? So let us see. For example, this is the path in which particle is traveling, and this is our mean position. So total amplitude is plus 5. So from here particle is starting. Okay. So in which condition particle will start from here? Particle will start from the positive extreme position only if it has covered initially 90 degrees. So it means initial phase of the particle is 90. So what is meant by initial phase of the particle? Already we have discussed many times previously, refer those lectures. So when we started observation, what was the position of the particle? That is called as initial phase. Clear? So already we discussed that every particle will start from the mean position. And in which direction? Towards the positive extremity. So from here to here, first of all, when it traveled, here phase is 0, and when it reaches this position, it is equivalent to, it has covered 90 degrees. Clear? So when I started observation, particle is already present at this position. So therefore, which equation I can use? I can use x is equals to a sine omega t plus pi, and here pi value is 90 degrees or pi by 2. Clear? Because when I started observation, particle was already present at a phase of 90 degrees. Okay. Now what is the sine omega t plus 90? It can be written as a cos omega t also. So therefore I will write x is equals to a cos omega t. Clear ma? Now what is the displacement? Displacement is from the extreme position, it should cover 2.5. Then what is the position from the mean position? Sima, position of the particle always we have to take from the mean position only. Clear? So from the mean position, what is the displacement? From the mean position also it is 2.5 only, because from the extreme position if it is 2.5, from mean position also it will be 2.5, because total amplitude is 5. Clear? So therefore what can I write? I will write 2.5 is equals to a value is 5, so 5 cos omega t. So 1 by 2 is equals to cos omega t. Cos omega t will be 1 by 2 only when theta is equals to omega t is equals to 60 degrees, which is called pi by 3. Clear ma? So therefore omega value already we have found out now, it is 1 radian per second, so substitute 1 here. So 1 into t is equals to pi by 3. So therefore time taken is equals to pi by 3 seconds. Clear? So this is our answer. Okay. So in how much time a particle will travel a distance of 2.5 meters from the extreme position in a time of pi by 3 seconds. That's all. Very simply we have done this calculation. Okay. Make a note of this one. So now let us see this question. So a particle in a system has maximum velocity of 40 centimeters per second and maximum acceleration of 50 centimeters per second square. So find its amplitude and time period of oscillation. Clear ma? So what is meant by maximum velocity? So we know v is equals to omega into square root of a square minus x square. Clear ma? So already we have discussed that velocity of the particle will be maximum only at the mean position. That is when x is equal to 0. So if I substitute x is equal to 0 in this condition, then I will get V max is equals to omega into a, or a into omega. Clear? Similarly, maximum acceleration. Acceleration of the particle, we know it is minus omega square into x, and a will be maximum when x will be maximum. That is, at the extreme position, particle will experience maximum acceleration. So therefore, a will be maximum when I write it is equals to omega square into a. Clear? So this is the equation for maximum velocity. This is the equation for maximum acceleration. Now see what are the terms which are given. Maximum velocity. So V max is equal to 40 is equals to omega into a. Similarly, maximum acceleration is how much? Maximum acceleration is equal to 50 is equals to omega square into a. Clear ma? So he is asking time period and amplitude. So if I can calculate omega, then I can calculate time period. So I will divide both of them. So if I divide both of them, what I will get? Omega is equals to 50 divided by 40, which is called as 5 by 4. So omega is 2 pi by capital T is equals to 5 by 4. So therefore T is equals to 2 pi into 4 by 5. Clear ma? So which is called 8 pi by 5 seconds. Clear? So that is the time period of oscillation. Now take this time period or take this omega value and substitute any one of the relation. Then I will get equation of value of amplitude also. So I will use this relation. So 40 is equals to omega. Omega value is how much? Omega value is 5 by 4 into amplitude. So amplitude is equals to 40 into 4 by 5. So 5 1s are 5 8s are, so 8 4s are 32 centimeters will be the amplitude of this particle. Okay. Friends, now let us see the next question. So a vertical motion of a huge piston in a machine is almost a simple harmonic with a frequency of 0.50 second inverse. A block of 10 kg is placed on the piston. So what is the maximum amplitude of piston for block and piston to remain together? Clear ma? So consider there is some vertical piston which is moving, which is making simple harmonic motion along the y-axis. So it is moving like this. So it is performing simple harmonic motion with a frequency of 0.50 S inverse. Clear? Now on this piston, we are supposed to place a mass of M. So if this is a piston, clear? So on this piston, we have to place a mass such that, so if piston is moving, this block also should move along with this piston. Clear? And what is the question he is asking? So maximum amplitude of the piston such that piston and this block, they remain together. Clear ma? So when the piston is moving upwards, then along with the piston, block also moves upwards without any problem. Clear ma? Problems comes when the piston is coming downwards. Clear ma? So this mass, it has an acceleration of minus g, which is equals to minus 9.8 meters per second square. Clear ma? Because this piston, it behaves like a freely falling body. So the maximum acceleration with which it can fall is 9.8 meters per second square if there is no piston. Clear ma? So therefore, piston's acceleration is also, if it is 9.8 or less than 9.8, then it is not a problem. Both of them, they will move as a single body. Clear ma? And where will be the acceleration of the piston maximum? Maximum acceleration of the piston will be at the extreme position. For example, if I take this piston, so consider this is the bottommost position and let it be our mean position. So are you able to understand? So at the extreme position, this position and this position, the acceleration of the piston will be maximum. Clear ma? So when the body has reached one extreme position and if its acceleration is 9.8, so from here it starts coming down, no? It starts coming down with an acceleration of 9.8. This mass also starts coming down with an acceleration of 9.8. Then no problem, both of them, they will come together as a single body. Clear? But the problem is, if this piston starts coming down with an acceleration greater than 9.8. So let us consider this piston is coming down with an acceleration of 12 meters per second square. Then what will happen? So this piston starts coming down with a greater velocity because its acceleration is greater. But this mass, it has only an acceleration of 9.8 because no force is acting on this mass except gravitational force. Clear? So if the piston has an acceleration greater than 9.8, then this piston will come with a greater velocity. But this mass, it will come down only with an acceleration of 9.8. Then temporarily, these two bodies, they get separated. Clear? So this is falling with a greater velocity, this is falling slowly. So they will get separated. Clear? So the maximum acceleration possible for this piston is only 9.8. Clear? And for maximum acceleration, already we have written equations previously, no? What are the equations? So A max is equals to omega square into x. So this is the maximum acceleration possible for the body, and instead of x here we will write A. Clear? So piston should have a maximum acceleration of 9.8 meters per second square at the extreme position. So if acceleration is greater than 9.8, then these two bodies, they will get separated. Are you able to understand? So therefore, omega can be written as 2 pi into f. So 2 pi f into whole square into A should be equal to 9.8. Clear, ma? What is actually asking? Maximum amplitude only. So therefore, A value is equals to 9.8 divided by 2 pi into frequency is already given into 0.5 whole square. Clear? So if I do this calculation, then the answer which you should get is approximately 0.99 meters. Clear, ma? So if amplitude is 0.99 meters, that is the maximum amplitude. Clear, ma? So then acceleration will be 9.8 for the piston. Clear, ma? So if acceleration is greater than 0.99, then what will happen? So as amplitude increases, this acceleration also increases. Then bodies, they will get separated. Clear? Okay. Now let us see the next question. So a person normally weighing 60 kg stands on a platform which oscillates up and down at a frequency of 2 seconds and with an amplitude of 5 centimeter. If mission on the platform gives the person's weight against time, find the minimum and maximum readings it will show. Clear, ma? And take G value to be 10 meters per second square. So this is the question. So let us try to understand what is happening here. So this is a platform, clear, on which there is one weighing machine. So this is our weighing machine. Clear? So on this weighing machine, a person is standing. And what is the mass of this man? Mass of the man is 60 kg. 60 kg only, no? So this piston, it is performing simple harmonic motion. So let this be our mean position. Clear? And let this one be another extreme position. It means if this is the platform, so again this is the weighing machine, and again this is the man who is standing. Are you able to understand? So it is performing simple harmonic motion along this path. Now the question is, what will be the minimum and maximum reading that is shown by the weighing machine? So already we have studied in Newton's laws of motion that weighing machine, what does it read? Weighing machine always reads normal reaction which is acting on that weighing machine. Clear, ma? So for example, if you take this position, that is the topmost position, so every body in SHM, how does it oscillate? It performs SHM such that acceleration is always towards the mean position. Are you able to understand, ma? So acceleration is direction is towards the mean position. Here also acceleration direction is towards the mean position. Clear? So therefore, this man is also accelerated downwards with an acceleration of A, and that acceleration will be maximum only at the mean position. Sorry, only at the extreme position that already we have studied. Clear? So here at the topmost position, if I draw the free body diagram of the man, so free body diagram of man I am drawing now. Clear, ma? So on this man, his weight mg is acting downwards. Clear? And normal reaction is acting upwards, and man is accelerating downwards with an acceleration of A. Clear? And that A, how can I calculate? A is equals to omega square into A, that we will calculate afterwards. So therefore, if I do this calculation, how can I write Newton's laws in this condition? As it is accelerating downwards, definitely mg should be greater than n here. So therefore, I will write mg minus n is equals to mass into acceleration. So normal reaction is equals to mg minus ma. So therefore, m into g minus a. Clear, ma? So this is the normal reaction which this weighing machine experiences at the topmost position. Clear? Now let us see how we can calculate at the bottommost position. Here, how can I write? So at bottommost position. Clear? So at the bottommost position, let us again draw the free body diagram of the man. So for this man, his weight mg is acting downwards. Normal reaction is pushing this man upwards, and the man is accelerating in upwards direction with an acceleration of a. Clear? So therefore, n should be greater than mg because acceleration is in upward direction. So therefore, what I will write, n minus mg is equals to mass into acceleration. So n is equals to m into g plus a. Clear? So previously we got m into g minus a. Clear, ma? So therefore, if this is n1 and this is n2, definitely I can say n2 is greater than n1. Clear? So the normal reaction that is experienced by this weighing machine, it is maximum only at the bottommost position. So at the bottommost position, definitely I can say body will show greater reading, or this weighing machine will show greater reading. Clear? Now what about acceleration? How I can calculate this acceleration? Mass I know it is 60 kg, g value is 10, and a value we are supposed to find out. Are you able to understand, ma? How we can calculate a value? A is the acceleration at the maximum displacement from the mean position, no? So therefore there a will become a max, maximum acceleration, and already we have studied equation for maximum acceleration, which is omega square into a. Clear, ma? So therefore omega square value is how much? Omega can be written as 2 pi f. So 2 pi f into a, 2 pi f whole square into a. So therefore 4 pi square into f square multiplied by, what is the amplitude he gave? It is 5 centimeters. Clear? So if you do this calculation, I will get acceleration. Take this acceleration, substitute here, I will get normal reaction at the bottommost position. Similarly, you calculate, you substitute a value there, then you will get acceleration at the topmost position. Clear? Come on, calculate these values. So 5 centimeters we are rating, and if I convert in terms of SI system, then the acceleration which I will get is 7.9 meters per second square. So take this acceleration, substitute in this relation, I will get the maximum reading shown by the weighing machine, 1074 Newton. And here, again if I substitute a value here, then I will get it is 126 Newton. Clear, ma? But always we have studied that weighing machines, they study normal reaction in terms of kg force, that is mass they will show. So how can I convert the readings in terms of mass? Just divide this 1074 divided by 10, then it is equals to 107.4 kgs. And similarly 12.6 divided by g value is 10, so the reading shown will be 12.6 kgs. Clear, ma? That's all. Dear students, now let us see this question. So a particle executes a system with amplitude a and angular frequency omega. At an instant, the particle is at a distance of a by 5 from the mean position and is moving away from it. So find the time after which it will come back to the original position again. Clear, ma? So let us see, let us try to understand this one with the help of a line diagram. So this is the mean position. So initially particle was present at a displacement of a by 5 if amplitude is a. Clear? And it was going away from the mean position. Then we are supposed to find out the time taken after which it will return back to the original position again. Clear? So therefore, how can I solve this one? So this particle will travel from here, travel throughout this journey, travel up to the mean position, then again returns back and reaches to the same position. So this is what is happening. Clear, ma? So until this instant, we are supposed to find out the time taken. Clear? So very easily we can solve this problem by using a circular method, by comparing a system with circular motion. So let us see. So if this is the circular path, clear? So this becomes our main position. So this is the positive extremity plus a, and this is the negative extremity minus a. And let us identify a by 5. So let us consider this height to be a by 5. Clear, ma? So initially the particle was present at a by 5. So on the circular motion it is equivalent as if particle is traveling in this direction. Clear, ma? So this is the radius vector which also has a magnitude of a. Clear, ma? And from here what is happening? First of all it should go to the extreme position, then it should return back. So from here the particles goes to the extreme position, then again it returns back to the same position. Clear, ma? So same position means what? This is the same position. So particle will travel here. It will cross the extreme position, then it will go to the again same position of a by 5 and in the same direction. Okay, so this is positive extremity, negative extremity. So this total is present in the same direction from the main position. Are you able to understand? So therefore, now if I join another radius vector here, now this is the total angle covered by the particle. Clear ma? Or we can say phase difference between this position and this position is this much. And what is meant by phase difference? The angle covered by the particle in a particular time is this much angle. Clear? So if I can calculate this phase difference, time difference very easily I can calculate. That is the time taken. Are you able to understand? So let us see. So let us consider this angle is theta, then this angle is also theta. So therefore, total angle covered by the particle, total angle covered will be how much? It will be equal to 2 theta. Clear? Now how can I calculate this theta? I can use either sin theta or cos theta. If I take this right angle triangle, then I have to consider sin theta. If I take this right angle triangle, I have to consider cos theta. So I will take this right angled triangle. So therefore, if I write cos theta, it is equal to adjacent by hypotenuse. So adjacent value is a by 5 and hypotenuse is a, so 1 by 5. Clear? So therefore, theta is equal to cos inverse of 1 by 5. So I got values up to here. Are you able to understand? But what is the total phase angle? Total phase difference. So total phase difference or angle covered by the particle is how much? 2 theta. So which is equals to 2 into cos inverse of 1 by 5. Are you able to understand ma? So therefore, if I know phase difference, I have a relation for calculating time difference. And what is the relation? Delta pi is equals to 2 pi by t into small t. Clear? 2 pi by t is so called as omega. And omega is already given. Just you have to consider this one as omega. So delta pi is equals to omega into t. So therefore, what is t? T is equals to delta pi divided by omega. Delta pi value is how much here? So it is equals to 2 cos inverse of 1 by 5 divided by omega. Clear ma? So this is the time taken by the particle to travel from here to and reach this point. Or in simple harmonic motion, how can I compare this one? So particle is initially traveling from here, going to the extreme position and returning back and again reaching to the same position. Clear? So for this, the time taken is this much. Clear? Same answer we can calculate in terms of sin theta also. How I can calculate sin theta? So this angle, if I take it as alpha, then I can calculate sin alpha. So sin alpha is equals to, if this is a by 5, then this is also a by 5. So opposite by hypotenuse is a by 5 divided by a. Clear ma? So therefore, alpha value is how much? Sin inverse of 1 by 5. Clear? So if this is sin inverse of 1 by 5, this is also sin inverse of 1 by 5. Then what is the total angle covered? Total angle covered is 180 minus 2 alpha. Clear ma? So here there is alpha, here and one more alpha, but angle covered is only this much. So total 180 minus 2 alpha will be the phase. Clear? Phase difference. So again you can use the same procedure and do the calculation. Okay? So very simply we can do the values by comparing the simple harmonic motion with circular motion. Okay? Then you do one thing, you try to do in second method also, that is by using the equations of simple harmonic motion also you can do and try to do and see if you can get the same answers or not. Okay? Now let us see this question. So two particles executing a system with the same angular frequency and amplitudes a and 2a on same straight line with the same mean position cross each other in opposite direction at a distance of a by 3 from the mean position. So find the phase difference in the two systems. That is the question. Clear ma? So let us try to understand this one by drawing a diagram. Clear? So this is the path of one particle. Then this will be the path of another particle. So both of them, they have the same mean position. So this is the mean position. So this is plus 2a and this is minus 2a. So this is plus a and this is minus a. Clear ma? So in this condition, what is happening? So both of them, they are crossing each other at a displacement of a by 3 from the mean position. So if I consider this position to be a by 3 from the mean position, so let us assume that this particle is traveling in this direction and second particle is traveling in opposite direction. Are you able to understand ma? So they are crossing each other such that their directions are in opposite direction at a distance of a by 3 from the mean position. Then calculate the phase difference between these two systems. Clear ma? So one important point is that they have same angular frequency. Clear? So what is meant by same angular frequency? They will cover same angle in same time. That is the meaning of this one. It means that if one body is completing 4 oscillations in 1 second, second body also completes 4 oscillations in 1 second. That is the meaning of this one. So definitely we can solve this problem by comparing this simple harmonic motion with circular motion. Clear? So let us see. So for example, let this one be the path traveled by the particle whose amplitude is plus a. Then let us consider, let this one be the path traveled by the second particle which is having an amplitude of 2a. Clear ma? So this becomes our mean position. Clear? So this is plus 2a and this is plus a minus 2a. So where is the position of a by 3? So let us consider this is the position of a by 3. Clear? So what we have assumed here, this particle which is having an amplitude of a, it is going away from the mean position towards positive extremity. So therefore in this diagram where can I represent? I can represent a by 3 is very large here. So let us consider this to be a by 3. Clear ma? So my path is present here. Particle is traveling in this direction and crossing the mean position. It means it is going away from the mean position. Are you able to understand? And second particle is also present at the same displacement, but it is going towards the mean position now. Clear? It means this particle should have started from the mean position only, no? So this sign convention always you should remember. So any particle we consider, it has started from the mean position towards plus a. So it should have traveled like this, then it should have reached to 2a, now it is returning back. Clear? So therefore, it should have started from here, reached the extreme position, now it is returning again to the main position. Now while returning, where it has reached to this position. Clear ma? So therefore, this will be the radius vector. Clear? So this distance is a by 3, this distance is also a by 3. Are you able to understand? So therefore, what he is asking, find the phase difference. Phase difference means just this angle, if I can calculate, what is the angle difference between them, that is called as a phase difference. Clear? How can I calculate? So let us consider this angle to be theta 1 and let us consider this angle to be theta 2. Then by considering this right angled triangle, how can I calculate cos theta 1? So cos theta 1 is equals to adjacent by hypotenuse. So hypotenuse is how much for the first particle? A. Clear ma? So adjacent side is a by 3 divided by a, which is called 1 by 3. So theta 1 is equals to cos inverse of 1 by 3. Clear? Now what about second particle? For second particle theta 2, this is the phase. Clear ma? So therefore this also I can consider by considering this right angled triangle. So how can I calculate? Again I can calculate cos theta 2 is equals to again adjacent by hypotenuse. So adjacent value is definitely a by 3, but what about hypotenuse? Hypotenuse value is 2a. Magnitude of hypotenuse is 2a. Clear? So cos theta 2 is equals to adjacent value is a by 3 divided by 2a. So a gets cancelled, so 1 by 6. So theta 2 is equals to cos inverse of 1 by 6. Clear ma? So therefore what is the total phase? Total phase is nothing but total phase, or you can call total phase difference between them is how much? It is equals to theta 1 plus theta 2. Clear? So theta 1 is how much? Cos inverse of 1 by 3 and theta 2 is cos inverse of 1 by 6. Clear? So this is the answer. Same value you can calculate in terms of a sin theta also. For example, let us see that calculation also, how we can calculate in terms of sin theta. So let us. Clear? So instead of considering this right angled triangle, I can consider this right angled triangle also. Clear? So this angle is, let it be alpha 1 and let this angle be alpha 2. Clear ma? Then how can I calculate sin alpha 1? Sin alpha 1 can be calculated as opposite by hypotenuse. So if this is a by 3, this is also my a by 3. Clear ma? So a by 3 divided by a, so is equals to 1 by 3. So alpha 1 is equals to sin inverse of 1 by 3. Clear? Similarly, I can also calculate this alpha 2. So if this is a by 3, this distance is also a by 3. Clear? So sin alpha 2, how can I calculate? So again a by 3 divided by, now what is the hypotenuse? Hypotenuse is 2a in the second figure. So therefore 1 by 6. So therefore how can I calculate alpha 2? So alpha 2 is equals to sin inverse of 1 by 6. Clear? So I have calculated alpha 1 and alpha 2. Clear? But what is the phase difference between these two particles? This is the phase difference. So how can I calculate this angle? So this total angle is 180 degrees, no? So 180 degrees, from 180 degrees you remove alpha 1 and alpha 2, then very easily we can get the answer. So therefore, how can I calculate? So therefore, phase difference is equals to pi minus of sine inverse of, so that is pi minus of alpha 1 minus alpha 2. Clear? Or we can write pi minus of alpha 1 plus alpha 2, I can write like this. So pi minus alpha 1 is how much? Sine inverse of 1 by 3 plus sine inverse of 1 by 6. Clear? So in this method also we can do the calculation. Clear? So you should search for the options. In options, if you find this relation, then you are supposed to solve by using cos theta. In the options, if you see this one, then you are supposed to solve with the help of sin theta. That's all. Clear? Dear students, now let us see energy concept in simple harmonic motion. So a particle in a system, does it have energy? So definitely it has energy, because particle has velocity. So because of velocity, it has kinetic energy. Clear? Similarly, when it is displaced from the mean position, clear? Spring develops a restoring force. Not only spring, any restoring force will be developed. Clear? So this restoring force, so it will do some work on the body, it will do negative work on the body. Clear? Not every time negative work. When body is moving from mean position to extreme position, then restoring force will do negative work. Clear, ma? So this amount of work done will be stored as potential energy inside the body. Clear? So definitely body in a simple harmonic motion, it has both kinetic energy as well as potential energy. Clear? So first of all, let us study about potential energy stored in the body. Clear, ma? So for example, let us consider this is a spring which is present at the mean position. Clear? Then this spring, I have elongated this one by a distance of x. This is the direction of elongation. Clear? So therefore, spring develops a restoring force which is Fr, and this restoring force is directly proportional to minus x. So here minus indicates that if elongation is in one direction, restoring force will be in opposite direction. Clear, ma? And if I remove this proportionality constant and place a symbol and place a constant, then Fr is equals to minus kx. So this is the amount of restoring force which is developed in the spring. And what is meant by K here? K is nothing but spring constant, SHM constant, oscillation constant, or you can call it as vibration constant. Clear, ma? Now for a small displacement, the amount of work done we can write dW is equals to F into dx. Already we have studied these concepts in work, power and energy topic. Clear, ma? So therefore, if I am supposed to calculate a total displacement for a displacement of x, then you have to integrate it on both sides. Then work done is equals to integration from 0 to x. So F into dx. What is F here? The restoring force applied by the spring. So F value is minus k into x. So work done is equals to minus integration of 0 to x. Instead of F, I can write kx into dx. Clear, ma? So therefore, work done is equals to minus k integration of x into dx. Limits are applied from 0 to x. So therefore, integration of x is x square divided by 2. So therefore, minus k x square divided by 2. Therefore, half k x square. Clear, ma? So this is the amount of work done by the spring for a displacement of x. And spring has done negative work in this condition. Why negative work? Because spring is moving in one direction, restoring force is developed in opposite direction. And restoring force is not a constant, it is a variable. Clear? So that is the reason why we have applied integrations here and we have calculated the work done by the spring. Clear, ma? Now this amount of work done by the spring, it will be stored as a potential energy inside the spring. Clear? So therefore, what can I say? Therefore, potential energy stored in the spring is nothing but half k x square. So this is the amount of potential energy stored inside the spring. Are you able to understand? And what is K? K is called spring constant, SHM constant, oscillation constant, or vibration constant. So this K has a magnitude. K is equals to m omega square. If I substitute this relation, then potential energy is equals to half m omega square into x square. So this is one equation of potential energy. Are you able to understand, ma? So therefore, how can I calculate kinetic energy now? Clear? What is kinetic energy? So kinetic energy is equals to half mv square. Because kinetic energy depends on velocity, no? So therefore kinetic energy is equals to half mv square. Clear? And already we have studied an equation for velocity in terms of displacement of the particle. Clear? V is equals to omega into square root of a square minus x square. So take this relation, substitute here. So kinetic energy is equals to half m omega square into a square minus x square. So this is the relation of kinetic energy which we got in terms of total displacement through amplitude A and displacement x. Clear, ma? So therefore potential energy is half m omega square x square, kinetic energy is half m omega square into a square minus x square. Clear? So after this, let us try to calculate the sum of these two energies, which is called as a total energy. Clear? So let us see. So now we will study about total energy. So what is meant by total energy? It is the sum of kinetic energy plus potential energy. So kinetic energy is how much? Half m omega square into a square minus x square, and potential energy is how much? Half m omega square x square. So if I take half m omega square common, then I can write a square minus x square plus x square. So plus x square and minus x square get cancelled. So half m omega square a square. So this is the equation for total energy of the particle. Clear, ma? Now if you see this relation, what do you understand? So total energy is half m omega square a square. So what do you understand by looking at this relation? Clear, ma? So what is the difference you find in potential energy, kinetic energy and this one? Clear? In potential energy and kinetic energy, we have a term called x. But here this total energy is independent of x. Clear? Similarly, it is independent of time also. T is also not present, no? T means small t, instant of time. That is also absent. It means the total energy, it does not depend on displacement. Similarly, it does not depend on instant of time also. So therefore, we make a note of this statement. So what is the note point here? We write total energy is independent of instant of time and displacement from the mean position. Clear, ma? So this is called as total energy. Okay. Now if you see here, mass is a constant, omega is a constant, amplitude is a constant. It means total energy is also a constant. Clear? So total energy of the particle performing simple harmonic motion, it is always a constant. Then what are the variables? Variables are kinetic energy and potential energy. So continuously kinetic energy changes into potential energy when body is traveling from mean position to extreme position. When body is returning from extreme position to mean position, potential energy slowly converts into kinetic energy, and at the mean position, potential kinetic energy becomes maximum. Clear? So potential energy and kinetic energy, they interchange with each other, but total energy is always a constant. Clear? So this is one method of understanding these equations. Now let us see if we can write some more relations based on them. Let us see. Another form of potential energy and kinetic energy. Now these are the equations of potential energy, kinetic energy in terms of displacement of the particle from the mean position. Now we will study dependence of this kinetic energy and potential energy in terms of time. Clear? So let us see how we can write. See, ma'am. Potential energy is equals to half kx square. So half k can be written as m omega square. X can be written as a sin omega t. What is this relation? This is the relation of displacement of the particle from the mean position with respect to time. Similarly, if I differentiate this one, dx by dt is nothing but velocity, no? So it can be written as a omega cos omega t. Clear, ma? So here if I substitute x value is a sin omega t, then I will write, so a square sin square omega t. Similarly, kinetic energy can be written as half m v square. So half m, instead of velocity, what can I write? I can write a square omega square cos square omega t. This is the relation which I can write. Clear? So therefore, again if I calculate total energy, then again it is the sum of kinetic energy plus potential energy. So therefore, if I add both of them, half m omega square, here also half m omega square a square, I can take common. So half m omega square a square, and in the brackets what I will get? I will get sin square omega t plus cos square omega t. So sin square theta plus cos square theta is 1. So here I will write 1. So therefore, total energy is how much? Total energy is half m omega square into a square. Clear? So this was the same relation which we got previously, no? So previously also we got the same relation, half m omega square into a square. Clear? So here now you see what is the difference between potential energy, kinetic energy and this total energy. So here potential energy and kinetic energy, you see the term T here. But here in total energy, we don't have the term T. Clear ma? So therefore total energy is always a constant. So this we can understand by this mathematical analysis. Are you able to understand? Now let us see how these kinetic energies and potential energies, they will change. Clear ma? Let us see. Clear? So, see ma. So if I take the path traveled by the body in SHM, then what can I say? This is the mean position. Clear? So at the mean position, when body is traveling from the mean position towards a positive extremity, then its velocity will be maximum. So here velocity is maximum. So velocity is maximum, and what about displacement from the mean position? It is 0. Clear? So therefore total energy can be written as sum of kinetic energy plus potential energy. Kinetic energy is half m v max square. Potential energy is half k x square. So half m v max can be written as a into omega, already we have studied, and x value is 0. So therefore total energy is half m omega square into a square at the mean position. So this is the total energy at mean position. Clear ma? Similarly at the extreme position, here what can I study here? Here I can say that velocity is 0, displacement is maximum, which is plus a, positive amplitude. Clear ma? So therefore again if I calculate total energy, which is the sum of kinetic energy plus potential energy, kinetic energy is half mv square, potential energy is half kx square. So this value is 0 because velocity is 0, and instead of x I can write a. So half k x square. So therefore total energy is how much? Total energy is half k x square. So total energy is half k. Instead of k, what can I write? I can write m omega square. Sorry, this is a, no? So maximum amplitude is a. This is a square. So therefore instead of k I will write m omega square. So m omega square into a square. Clear ma? So this is the total energy at extreme position. Clear? So therefore if you observe here, total energy at the mean position is half m omega square a square, and this is the energy only because of kinetic energy. Similarly, if you see energy at the extreme position, it is half m omega square a square only, but this is the energy because of potential energy. Clear ma? So in between mean position and extreme position, what is happening? So from mean position to extreme position, here kinetic energy is maximum, no? So this kinetic energy slowly converts into potential energy, and at the extreme position, potential energy will become maximum. Clear? Similarly, while returning back, what will happen? Again, potential energy slowly converts into kinetic energy, and at the mean position, kinetic energy is maximum. So this is how energy changes. Clear ma? Okay. Now let us try to represent a graphical representation of this one. How can I represent the variation of energy with respect to displacement as well as time also? Clear? So let us see. So variation of energy with respect to displacement. Clear? So, or we can say graphical analysis also. Variation of energy with respect to displacement from mean position. Clear ma? How can I draw a graph? Let us see. So this is the mean position, and on the x-axis we are taking energy as our parameter. So this is plus a and this is our minus a. Clear ma? And this is the mean position. Are you able to understand? So if I draw kinetic energy graph, then how can I draw kinetic energy graph? Kinetic energy, it is maximum at the mean position, and at the extreme positions it is 0. Clear? So if I calculate kinetic energy at different positions and draw the graph with respect to position, that is displacement of the particle from the mean position, then this is the graph which I will get. The graph which I will get will be this one. Are you able to understand? So graph will be like this. Clear? So then how can I draw? Let us draw first of all total energy graph. Clear ma? Then if I draw potential energy graph, potential energy at the mean position is 0, no? So therefore we get a graph like this. Are you able to understand? So what is this line? This is the line of total energy. Clear? So this is the graph of kinetic energy, and this is the graph of, This is the graph of potential energy. Clear ma? So this is how energies are changing with respect to time. Clear ma? So at the mean position, kinetic energy is maximum, potential energy is 0. Clear? At the extreme position, kinetic energy, which is kinetic energy, this one, kinetic energy is 0, potential energy is maximum. But total energy is always a constant. This is the total energy graph. It is always a constant. Are you able to understand ma? So this is how I can draw what you call energy and displacement graphs. Are you able to understand? So now similarly, let us draw the graph of displacement and, time and energy graph. Clear ma? Let us see. So first of all, let us understand what is meant by time period. Already we have studied this one more. So if this is the mean position of the particle, clear ma? If this is the mean position and total time period, if it is a t, then from mean position to extreme position, time taken will be t by 4. And from extreme position to mean position, again time taken will be another t by 4. So t by 4 plus t by 4 will be t by 2. Clear? And from mean position to another extreme position, another t by 4 will be taken. So total it is 3t by 4. Clear? And from negative extreme position to mean position, another t by 4 will be taken. So total time taken will be t. So this is called as time period. Already we have studied this one. Now with respect to time, let us see how energy is changing. Clear ma? So therefore this is the energy graph and this is our time graph. Clear ma? So here energy is indicated on the y-axis. Clear? And this is time. Clear? So initially this is a 0 time. Now let us take equal intervals. So this is a time of t by 4 and similarly this is a time of t by 2. So this is a time of 3t divided by 4 and this is a time of t. Clear ma? Now from the mean position, what is meant by mean position? This position. When particle is traveling away from the mean position, from there we have calculated time. So 0 means what? 0 time means particle is present at the mean position. And at the mean position, kinetic energy is maximum because velocity is maximum. So therefore, if I draw the graph from a time of 0 to t by 2, 0 to t by 4, what will happen? This kinetic energy which was maximum, it will become 0 by the time it reaches to the positive extreme position. Because at extreme position velocity is 0, so kinetic energy becomes 0. So therefore from 0 to t by 4, graph will change like this. Graph will change like this. Clear ma? From t by 4 to t by 2, what will happen? Again body is reaching to the main position, so again its velocity becomes maximum, so potential energy also becomes maximum. So therefore from t by 4 to t by 2, the graph will be like this. This will be the graph. Are you able to understand? And from t by 2 to 3t by 4, so again velocity will become 0, so again kinetic energy becomes 0. So therefore graph will be like this. And similarly from t by 4 to t, again body reaches the main position and velocity will be maximum. Are you able to understand ma? Similarly, if I draw graph of potential energy, what about potential energy? So this is the graph of kinetic energy. What about potential energy graph? At the main position, potential energy is 0. But from 0 to t by 4, body is reaching to the extreme position, no? So potential energy becomes maximum. Clear? So therefore, how can I draw the graph? This is the position. So potential energy changes like this. And from next time interval, again potential energy becomes minimum. So for the next interval, potential energy again becomes maximum. And from another time, for another t by 4, again potential energy becomes 0. Clear ma? So this is how potential energy and kinetic energy, they will change. Then what is this straight line graph? This is the graph of total energy. Total energy always remains a constant. Clear ma? So here, one thing which we can observe is that in a time of t, in a time of 0 to t, body oscillates one time. That it has a frequency of 1 in a time period of 1. That is, in one time period, it will complete one oscillation. For example, let us consider. Clear ma? So therefore, in the same time period of t, potential energy and kinetic energy, they are oscillating 2 times. Clear? How? So this is one maximum and this is another maximum. So potential energy has reached to maximum 2 times. Clear? Similarly, this is one maximum of kinetic energy. This is second maximum of kinetic energy. So potential energy and kinetic energy, they are oscillating 2 times. Clear? So therefore, what can I write? If frequency of a body in SHM is F, then frequency of kinetic energy and potential energy is 2F. Clear ma? So if body is oscillating one time, in the same time, potential energy and kinetic energy are oscillating 2 times. Clear? So this is a very important factor in the case of total energy. Okay, ma? So this is our energy concept. So let us have further discussion. So therefore we have written equation for total energy. So total energy is equal to half m omega square a square. Clear, ma? And let us see some more additional forms of this total energy. So omega can be written as 2 pi by capital T also. So if I substitute this one, so total energy is equals to half into m into, so 2 pi by capital T whole square into a square. Clear, ma? So this is 4 pi square divided by T square into m a square divided by 2. So 2, and here I will get to 2. So 2 pi square m a square divided by T square. So this is the equation for total energy of the particle in terms of time period. Are you able to understand, ma? Similarly, we have omega is equals to 2 pi f also, or 2 pi nu also, where nu and f they are called frequency. So if I substitute again in that relation, then total energy is equals to half m. Instead of omega, I will write 4 pi square f square multiplied by a square. So therefore, total energy is equals to, so 2 pi square m f square a square. So this is also one more relation for total energy, but in terms of frequency. Are you able to understand, ma? So therefore, these are the other 2 forms of writing total energy equation. Clear? Similarly, if I want to calculate, or if I write equations of kinetic energy and potential energy for complete oscillation. What is meant by for complete oscillation? In a time, the particle completes one complete SHM, one total cycle. So for one complete cycle, if I take average kinetic energy, then it is equals to 1 by 4 m omega square a square. Similarly, average potential energy is equals to 1 by 4 m omega square a square. Clear, ma? So these are the average kinetic energy and average potential energy for one complete cycle. Are you able to understand? And there are some calculations of this one which we are not doing. So just you are supposed to remember these 2 equations. Okay? Dear students, now let us see some questions on energy concept in simple harmonic motion. So it is given that a block of mass 1 kg is attached to a spring of spring constant 50 Newton per meter. The block is displaced 10 centimeters from the mean position. Then we are supposed to calculate kinetic energy, potential energy, and total energy also when it is 5 centimeters from the mean position. Clear? So first of all, let us see how we can calculate kinetic energy. So kinetic energy is half m omega square into a square minus x square. So this is one equation of kinetic energy in terms of displacement. We have written one more equation of kinetic energy also, no, in terms of time, instant of time. But this is the equation in terms of displacement from the mean position. Clear, ma? Then what is this m omega square? K is nothing but m omega square. Already we have discussed this one. So if I substitute instead of m omega square k value, then I can write half k into a square minus x square. Clear? So kinetic energy is equals to half into k value is how much? K value is 50. A is amplitude, is how much? This is amplitude, maximum displacement from the mean position. So it is given in centimeters, so I will write in terms of meters. So a square, so 10 into 10 power minus 2 whole square minus x square. X value is how much? Where he is asking us to find out this energy is at 5 centimeter. So 5 into 10 power minus 2 whole square. Clear? So if I do this total calculation, then the kinetic energy which I will get is 0.1875 joules. 0.1875 joules. So this is our answer. Clear? Similarly, let us see how we can calculate potential energy. So potential energy, how I can calculate? Potential energy is half kx square. So k value is already given. So half into k value is 50. X is at a displacement of 5, no? So 5 into 10 power minus 2 whole square. Clear? So if I do this calculation, then the potential energy which I should get is 0.0625 joules. So this is the answer which you should get. Then he is asking total energy. How can I calculate total energy? Total energy I can calculate by half m omega square a square. So m omega square can again be written as half into k into a square. So half into k value is 50, amplitude is 10 into 10 power minus 2 whole square. Clear? If I do this calculation, then it will be equal to 25 into 10 square into 10 power minus 4. Clear? So therefore 0.25 joules. So what is one more method of doing the same equation for total energy? Just add potential energy and kinetic energy. So 0.1875 plus 0.0625. If you do this calculation, again you should get the same answer of 0.25 joules. Clear? So this is our answer. Dear students, now let us see this question. So time period of a particle in a system is 8 seconds. So mass is 0.1 kg. Velocity is 4 centimeters after 1 second of crossing the mean position. Then find its kinetic energy, potential energy and total energy. So first let us list out what is the data which is given. Time period is 8 seconds. Mass is given as 0.1 kg. Velocity is 4 meters per second after a time of 1 second. So t is equal to 1 second. Velocity is equal to 4 meters per second at a time of t is equal to 1 second. Clear, ma? So we are supposed to find out kinetic energy, potential energy and total energy. So kinetic energy is very easy to calculate because kinetic energy is half mv square at a displacement of this time period at t is equal to 1 second. Velocity is already given as 4 meters per second. So therefore half into mass of the body is how much? 0.1. Velocity is 4 square which is 16. So this is equal to 0.8 joules. Clear? So this is the kinetic energy. Now the question is, how can I calculate potential energy? Potential energy can be written as half m omega square x square. Clear, ma? So mass is present. Omega also I can calculate. Omega is equals to 2 pi by capital T. But x value is not there. Okay. So to calculate x value, what can I do? To calculate x value, I have to use the equation x is equals to a sin omega t. So from this equation, I can get x value. Clear? But again, we have a problem here. A value is also not given. Amplitude of motion is also not given, no? So first of all, let us try to calculate amplitude. Can I calculate amplitude with this equation? Can I calculate amplitude with this equation? I cannot calculate because in this equation I have two unknown quantities, no? X is an unknown quantity, amplitude is also an unknown quantity. So definitely I cannot find out. But velocity is given as 4 at 1 second, no? So I will use the equation of velocity. So we know that V is equals to A omega cos omega t. Clear, ma? Already we have written this equation. Velocity is how much? Velocity is 4, amplitude I don't know. And omega value is 2 pi by capital T cos. Omega can be written as 2 pi by capital T into T. Clear, ma? So therefore 4 is equals to A into 2 pi by, instead of capital T I can write 8. So cos, so 2 pi by 8 into instant of time is 1 second. Clear? So therefore 4 is equals to A into pi by 4 cos pi by 4. So cos pi by 4 value is cos 45 1 by root 2. So therefore 4 is equals to A into pi by 4 into 1 by root 2. So 4 4s are 16. So 16 root 2 by pi. So A is equals to 16 root 2 divided by pi meters. Clear, ma? So this is the amplitude of the particle. Are you able to understand? So once I have calculated the amplitude, you can substitute that amplitude in this relation because I have omega and t also. So I can calculate x value. Once you calculate x value, substitute in potential energy, you can get the answer. Clear? So any other method of doing this one? Any other method of doing this second method is calculate total energy. Total energy is half m omega square a square. This relation already we have now. So therefore half into mass of the particle is how much? Mass is 0.1. Omega is 2 pi by 8 whole square. Clear, ma? And amplitude just now we have calculated. So 16 root 2 divided by pi whole square. Clear, ma? If you do all this calculation, then I will get total energy is equals to 1.6 joules. This is the answer which I get. So once I get total energy, so from total energy you subtract this kinetic energy, then the remaining energy is potential energy only, no? So therefore potential energy is equal to total energy minus kinetic energy. So total energy is 1.6, kinetic energy is 0.8. So therefore potential energy is 0.8 joules. This is our answer. So in this method also we can do. So this is a bit easier method. So you can substitute A value in this one, calculate x value, then you substitute in potential energy. In this method also we can calculate the potential energy. Okay. Now let us see this question. So at a time when displacement is equal to half of the amplitude, what fraction of total energy is kinetic and what fraction is potential? So here, what is the given data here? Displacement is half of the amplitude. So x is equals to a by 2. Clear now? So I want to calculate how much percentage of total energy is kinetic and what fraction is potential. So kinetic energy, how I can calculate? Half m omega square into a square minus x square. Clear? So half m omega square into a square minus, instead of x, what can I write? I can write a square divided by 4. So therefore, half m omega square into, so 3a square divided by 4. Clear ma? So this is 3 by 4th of half m omega square a square. Clear? So therefore, half m omega square a square, we know it is total energy. So at a displacement of half of the amplitude, kinetic energy is 3 by 4th of total energy. So therefore, I can write kinetic energy is equals to 3 by 4th of total energy at what displacement? At half of the amplitude. Clear ma? So therefore, if 3 by 4th energy is kinetic, then remaining energy should be potential. So therefore, remaining energy is nothing but a potential energy, and potential energy is how much? It is, so total 3 E minus 3 by 4 will be 1 by 4. So 1 by 4th of total energy. Clear? So this is the fraction. So same value, if I want to calculate in terms of percentages, then 3 by 4 into 100. 3 by 4 into 100 is how much? 75%. So 75% of total energy will be kinetic energy. And remaining 25% of energy will be potential energy. Okay. Now let us see this question. A particle of mass 0.1 kg is executing a system with an amplitude of 0.1 meter. When particle passes through the mean position, its kinetic energy is 8 into 10 power minus 3 joules. So this is the kinetic energy when particle is passing through the mean position. So obtain equation of motion if its initial phase is pi by 4. Clear ma? So let us see how we can write this equation. So equation of motion, x is equals to a sine omega t. Clear? So this is the equation of motion. So a value is already given, it is 0.1 meter. But omega value is not given, and initial phase is also given, no? So I can write it as omega t plus pi by 4. So this is already given. Now I am supposed to find out omega value. So how can I calculate omega value? Let us see if I can find out with the help of the kinetic energy at the mean position. So kinetic energy at a mean position, we know it will be maximum. Clear? So therefore, how can I write? It can be written as half m v maximum whole square. And Vmax, we know it is equals to A into omega. So maximum velocity is A into omega. This already we have studied. So therefore, it is equals to half into A square omega square. So this is equals to kinetic energy maximum. So this is also the total energy also. Because at the main position, already always total energy is kinetic energy is maximum. And at the main position, only energy possessed by the particle is kinetic energy. Are you able to understand? So, what is the value of kinetic energy given? It is 8 into 10 power minus 3 is equals to half into, what is the mass of the particle? Mass of the particle is 0.1, and amplitude is how much? Amplitude is 0.1 whole square, and omega value, that is what we are supposed to find out. Clear ma? So, omega square. If I do all this calculation, then omega value will be 4 radians per second. This is the answer which I will get. Clear? So these calculations I am not doing just to save time. So omega is equals to 4 radians per second. Now just substitute in this equation. So x is equals to A. A value is how much? 0.1. Okay, sine omega. Omega value is 4. So 4t plus pi by 4. So this will be our required equation for equation of a particle performing simple harmonic motion. Now let us see this question. So a particle of mass 0.5 kg executes a system under a force of F is equals to minus 50 Newton meter into x. So if it crosses the center of oscillation with a speed of 10 meters per second, Then find the amplitude of motion. Clear ma? So A value we are supposed to find out, amplitude of motion. Clear? So here it is given that it crosses the center of oscillation with a speed of 10. So what is meant by crossing the center with a speed of 10? It means that is the maximum velocity, no? So a particle crosses the mean position always with a greater velocity, highest velocity. So therefore what can I write? V max is equals to A into omega. We know this relation. So V is equals to A into omega is equal to 10 meters per second. Clear ma? So he is asking to find out A value, but omega is also an unknown quantity. So two unknown quantities are present here. So therefore let us see how we can calculate omega value with the other data which is given. So mass is 0.5 kg and force is following according to this relation. So F is equals to minus 50 Newton per meter into X. Clear ma? So therefore force is given as minus 50 Newton per meter into X. So if I compare this one by minus K into X, K can be written as 50 into Newton per meter. Okay, and we know that K value is equals to m omega square. So therefore K is equals to m omega square. So 50 is equal to mass of the particle is 0.5 into omega square. So if I do this calculation, omega is equals to 10 radians per second. This is the value of omega which we got. Now take this omega value and substitute here. So therefore maximum velocity 10 is equals to A into omega. Omega value is 10. So therefore A is equals to 1 meter. So therefore the amplitude of the particle in SHM is 1 meter. So just this given force equation we are comparing with the restoring force equation minus K into X. Clear? Dear students, now let us see the next continuous topic in simple harmonic motion. So it is the oscillation of spring mass system. So in this spring mass system, we have two what you called cases. First one is horizontally loaded spring and next one is vertically loaded spring. So first let us try to understand this horizontally loaded spring. Clear ma? So for example, this is a spring which is present at its mean position, and to this spring we are attaching a mass of m. Clear? So we have attached this mass m, and this is the mean position of this spring. Now if this spring is pulled by a small displacement of x, then for that condition how can I write the case? So this is the spring and it is being elongated by a small distance of x. Clear? So this is body of mass m. So when compared to the original mean position, so spring is shifted by a distance of x. Clear? So immediately we have already studied that if a spring is displaced by a distance of x is in one direction, then restoring force which will be equal to minus K into X, it will be developed in opposite direction, where K is the spring constant of this spring. So this is the restoring force which is developed. So already we have studied why we have written minus symbol here, because if displacement is in one direction, restoring force will be in opposite direction. Clear ma? And on this mass, this is the only restoring force which is acting. There is no other restoring force. So therefore on this mass, this minus K into X becomes the net force. And we know what is meant by net force. Net force is nothing but mass into acceleration. So therefore what can I write? So minus Kx is equals to mass into acceleration, which is the net force acting on this mass. Clear? So therefore same relation I can write like this also. Acceleration can be written as dv by dt, and same acceleration can also be written as d square x by dt square also. If I differentiate displacement with respect to time, that it will become velocity, change in velocity by time. So again, if I do change in velocity by time, then it is called as acceleration. Clear ma? So therefore, A can be written as d square x by dt square. So if I substitute in this relation, I can write minus K into X is equals to m into d square x divided by dt square. Okay? So if I rearrange this relation, I can write d square x divided by dt square is equals to minus K by m into x. So I can write up to here. Clear? Now if I send this minus K by m multiplied by x to the other side, then I can write like this also. So d square x by dt square plus K by m into x is equal to 0. So I can write relation up to here. Clear? So previously we have derived an equation which is called as basic equation of simple harmonic motion. So what was that equation which we have derived? We have derived, so d square x divided by dt square plus omega square x is equal to 0. So we have done some problems also based on this relation. So if any function, if it is satisfying this condition, then we have called that type of function to be simple harmonic motion. Clear ma? So d square x by dt square plus k by m into x, it is also just looking like this equation. But what is omega? So if I compare this omega square and k by m, definitely I can write omega square will be equal to k by m if this equation also should be simple harmonic in nature. Clear? So therefore, omega can be written as square root of k divided by m, and we know omega is nothing but a 2 pi by capital T. So is equals to square root of k divided by m. So therefore, if I calculate the value of t here, then it should be equal to 2 pi into square root of m divided by k. Clear? So this is the equation for time period of a body which is connected to a horizontal spring, or this is the time period of the horizontally loaded body. Clear ma? So t is equals to 2 pi root m by k. So let us see how we have calculated this one. If I just elongate this spring and release this spring, then this body will perform simple harmonic motion. So when it is displaced by a displacement of x, the restoring force developed is minus k into x. That is the only net force acting on this body. Clear ma? So therefore, acceleration can be written as d square x by dt square. Double derivative of displacement is called as acceleration with respect to time. So just we have tried to convert this equation into the basic equation of simple harmonic motion, and by comparing these two equations, I got the equation for time period. Clear? So this is one method of calculating the time period of a body. Okay, make a note of this one. Now, previously we have done by first method. That method I can call it as force method of analyzing a horizontally loaded spring. Now we are trying to understand by one more method, which is called as energy method. So what is meant by energy method here? So total energy of a simple harmonic oscillator, it is always a constant. Already we have studied about this one. So what is meant by total energy? The sum of kinetic energy plus potential energy, it is always a constant. So how can I write kinetic energy? Kinetic energy is nothing but half mv square. Potential energy is nothing but half kx square. This is equal to constant. Clear ma? So if I differentiate this relation with respect to time, then differentiation of constant should become 0. Why? Because totally it is a constant, you know. So if I try to differentiate this one with respect to time, it is 0. 0 represents that this constant is not going to change with respect to time. That is called as differentiation, no? Okay. Now let us try to differentiate this one with respect to time. Then what I will get is, let us see, half m is a constant. So half m into, so 2v, differentiation of v square is 2v, and v we have not differentiated, so I will write dv divided by dt. Clear ma? So plus half kx square. So differentiation of half k is how much? Half k is a constant, so I will take it outside. So half k into, and differentiation of x square is 2x, and I have not differentiated x still, so I will write dx divided by dt. So this is equals to differentiation of d by dt of a constant. Clear? So differentiation of constant is 0. So therefore, let us see what are the terms we got. So I got, so here, okay, first of all, let us make a note of this one. So half into m into 2v into dx by dt can be written as acceleration, change in velocity by time, and half into k into 2x into dx by dt can be written as velocity. So totally it should be equal to 0. Clear? So I got relation up to here. Now let us see what we can do. So here half and 2, they will get cancelled. Now are there any terms? Velocity and velocity also get cancelled. So what are the remaining terms now? So m into a plus k into x is equal to 0. Clear ma? So therefore m into a is equals to minus k into x. So therefore what is a value? So minus k by m into x. So I got relation up to here. Clear? So already we have studied equation of acceleration previously. So acceleration of equation can also be written like this also. A is equals to minus omega square x also. This is also an equation for acceleration. Clear? Now if I compare these two relations, definitely I can say omega value is equals to square root of k by m. And omega is nothing but 2 pi by capital T. So this is again equal to square root of k by m. So therefore, what is the equation of time period we get? T is equals to 2 pi into square root of m by k. Clear? So this is how we can calculate the time period of a horizontally loaded spring, again with the second method, which is called as energy method. And that first method we have used by calculating restoring force method. No, restoring force is the net force acting on the body. So therefore, by that method we have calculated, and that method I can call it as force method, and this method we can call it as energy method. Okay, make a note up to here. Dear students, now let us see this vertically loaded spring. See ma'am. For example, let us consider we have taken a massless spring. So this is a spring which is massless. Clear? Now to this spring, so if it is massless, what will happen? It will not elongate. It will mean the spring is present in its natural length only. There is no elongation produced in this spring. Now to this spring, I attach a small mass. Clear? So I attach a mass of m. So if I attach a mass of m, so weight of this mass mg will be pulling this spring downwards. So there will be one elongation produced in this spring. So how much will be the elongation? Elongation produced will be this much. So if this is x naught, clear? So definitely I can say if the body is in equilibrium, then on this body two forces will be acting. One force is weight of this block which is acting downwards, and if displacement is in one direction, then restoring force should be in opposite direction, which is called k into x naught, where k is the spring constant of this spring. Clear? So mg is downwards, kx naught is upwards. Definitely these two are balanced. So definitely I can say mg is equals to kx naught. Clear? And this relation, it is always satisfied. Whether the spring is in rest position, whether the spring is being oscillating, whatever it may be, this is always satisfied. So mg will be equal to kx naught. So the weight of this body is pulling this spring downwards, and the restoring force kx naught, it is pulling this body upwards. That is the restoring force developed in this spring. Are you able to understand? So these two are always balanced. Clear? Now what I do is, I will apply some force, then I will pull this spring a bit to another what you call the distance, to some more elongation. So if this is the previous position when mass is suspended, now by applying some force F, clear, I have further expanded this spring to an elongation of x. Clear? So this is the further elongation produced. Clear? So further, if the spring is elongated by applying a force of F, then spring will develop an additional restoring force. So this is the restoring force which is balancing mg. Kx naught is the restoring force which is balancing this mg. But because of some additional elongation, there will be some additional restoring force. And how much will be that additional restoring force? Additional restoring force will be k into x, which is acting in upward direction. Are you able to understand, ma? So as we are seeing that mg is always balanced to kx naught, we need not consider this force, because mg is always present, kx naught is always present, and both of them, they are balancing with each other. Clear? Now therefore on this block, if I pull this body up to here and remove this force, what is this force? This is the external force with which I have elongated this spring by an additional distance of x. So if I remove this force value, external force, then only kx will be the net force acting on this mass. Clear? So there is another restoring force, kx naught, but it is balanced by mg, so I am not considering this restoring force. So the only restoring force now present is k into x. Clear? And restoring force, we represent it by negative value now, because if displacement is in one direction, restoring force is in opposite direction. So therefore what I will do, so now the net restoring force will be equal to minus k into x. Clear? So which is equals to mass into acceleration. So minus k into x is equals to mass into acceleration, can be written as d square x divided by dt square. Okay? So therefore, so d square x divided by dt square is equals to minus k by m into x. So again d square x divided by dt square plus k by m into x is equal to 0. Now we compare this equation with the basic equation of SHM. Basic equation of simple harmonic motion. So what is the basic equation of simple harmonic motion? So d square x by dt square plus omega square x is equal to 0. Clear, ma? So if I compare with both of them, definitely x we forgot here, into x is equal to 0. Definitely I can say omega square is nothing but k by m. Clear? So therefore right here, so by comparing both of them, omega square is equals to k divided by m. Clear? So omega is equals to square root of k divided by m. Omega can be written as 2 by capital T is equals to root k divided by m. So t is equals to 2 pi into square root of m by k. So this is the relation which we got. Clear? So for horizontally loaded spring also, we got the same relation. T is equals to 2 pi root m by k. For vertically loaded spring also, we got the same relation. It means that there is no effect of this mg is equals to kx naught. Clear? So whatever may be the initial mass attached to the spring, Time period of horizontally loaded spring and vertically loaded spring always remains the same for the same mass. So T is equals to 2 pi root m by k. That is our answer. Okay. Same concept we can try to understand with the help of Newton's laws also. So let us see how we can see. So this is the initial length of the spring without any elongation, and this spring we are considering to be massless. So therefore, with its own mass, this spring is not elongating because we are considering its mass to be very less. So less that we are considering it to be massless. Clear, ma? Now we have attached a mass of m. So if I have attached a mass of m, so there is an elongation of x naught. Clear? So, and this mass is in equilibrium position after attaching to this spring. If it is in equilibrium position, it means mg, the force which is acting downwards, and the restoring force kx naught which is acting in upward direction, both of them they are balanced with each other. Clear? Now by holding this mass, I am pulling this mass downwards by applying a force of F, so that the spring is elongated by an additional distance of x. Clear? Now what are the total restoring forces which are acting, that we will study. Initially, already there was a restoring force of kx naught, so this is that kx naught. And when the body is further displaced by x displacement, then a restoring force of kx. This is the additional displacement produced kx, which is again acting in opposite direction. Now what are the downward forces? Applied force F and mg, these are the two downward forces. And again, as far as I am, as long as I am holding this mass is in equilibrium. It means as long as I apply this force of F, this body is in equilibrium. So therefore, how can I write a Newton's law equation for them? So kx naught and kx, they are acting in upward direction, no? So restoring forces we are representing by negative symbol. So what I can write, so minus kx naught plus kx. And what about this force and mg, they are acting in the downwards direction. So their sign I will write to be positive. So this is minus kx naught minus kx plus mg plus F, totally it should be equal to 0 because the net force acting on this mass is 0. Clear, ma? Now, after pulling up to here, now if I remove this force, then what will happen? If I remove this force, the force which is acting in downward direction, then these two forces will become greater than this force. It means there is some restoring force which is acting in upward direction. Clear? And how much will be that restoring force? How can I calculate? Let us see. So this is after removing the external force. After removing the external force. How can I calculate this one? So restoring force will be, so these two forces are in upward direction, no? Their direction I will consider to be negative. So minus kx naught minus kx, and this mg is in downward direction, so plus mg. So this becomes the restoring force which is acting. Clear? This is in which condition? After removing the external force which is responsible for elongating this spring by a displacement of x. Clear? Okay. Now here already we have written that mg is equal to kx naught. Clear? So instead of this mg I can write minus kx naught also. So therefore restoring force will be minus kx naught minus kx. Instead of mg I will write kx naught. So this kx naught minus kx naught get cancelled. So therefore restoring force is equals to minus k into x. So this becomes the net restoring force in this condition. This was the same result which we have studied previously, no? In the first type of explanation what we said. So mg and kx naught, they are always balanced. So we have neglected that term there. But here by using Newton's laws we are solving this one, and again these two forces get cancelled, and I will get again restoring force is equal to minus kx. Clear, ma? So therefore restoring force is equals to minus kx, and this is the only force now which is acting on this mass m. It means this force becomes the net force. And what is net force? Net force is equals to mass into acceleration. Clear? So therefore minus kx can be written as mass into acceleration can be written as d square x by dt square. Clear, ma? So therefore d square x divided by dt square is equals to minus k by m into x. Clear? So I got relation up to here. So again comparing this one with the basic equation of SHM. What is the basic equation of SHM? D square by x by d square x by dt square plus omega square x is equal to 0. So therefore if I compare with this one, then I will get omega is equals to root k divided by m. So omega is nothing but 2 pi divided by capital T. So again t is equals to 2 pi root m by k. Clear? So again I got the same answer. But here we have tried to understood this situation by using Newton's laws of motion. Clear, ma? That's all. So here the question is, this body will oscillate about which mean position? So this was the mean position before the mass was attached, this position. And this is the new mean position after attaching this mass. Clear, ma? Now when you move this mass up to a displacement of x, and if you release this mass here, this body will oscillate about which mean position? Will it oscillate about this mean position or this mean position? Which one can you say? Which one? Clear? So definitely body will oscillate along this mean position. What is the reason? Because this condition should be always satisfied, no? So mg is equals to kx naught. So this additional force mg, this is balanced by kx naught. So because this condition should be always satisfied, this becomes our mean position and body will oscillate about this mean position. Clear? So therefore, for the case of horizontally loaded spring or vertically loaded spring, our equation of time period remains same. T is equals to 2 pi root m by k. And time period is depending on what factors? It is depending on the mass being suspended and also upon the spring constant, a system constant, oscillation constant or vibration constant of the spring. Okay? See these conditions. So this is an inclined plane which is present at an angle of theta. So this is the spring whose spring constant is k and it is attached to a mass of m. Clear? So here there is a spring, the thread which is passing through a pulley, and again mass of m is attached. And this is also a spring which is attached here, and a string is passing through a pulley, other end of the string is connected to the mass. Now what about the time periods of these systems? Clear, ma? So generally for horizontally loaded spring and vertically loaded spring, what was the equation of time period we have written? We have written T is equals to 2 pi root m by k. Clear? Now what about these conditions? For these conditions, how can I change this relation? Clear? Answer is, we need not change this relation because mass is not changing, k value is also not changing. So not only for horizontally loaded and vertically loaded springs, for any type of combination where only one mass is oscillating with the help of a spring, definitely I can use this relation of time period, T is equals to T pi root m by k. Because the oscillations produced in the spring are only because of the restoring force produced in the spring. Clear? Come on, make a note of this one. Students, now let us see the combination of springs. So first one we are studying about series combination of springs. Clear? So for example, if this is one spring, this is another spring. So spring constant of this one is K1, spring constant of this one is K2. Clear? So to these springs, to the bottom, to this second spring, if I am connecting a mass of M. So let this one be first spring and second spring. So to the second spring, if I attached a mass of M, then what will happen? Then the springs will elongate. So first spring as well as second spring, both of them will elongate. Clear? Now the question is, why both of them will elongate? So we are attaching this mass to this bottom mass, no? Then why this spring also should elongate? That is our question. Because, for example, if I want to elongate this spring, clear, ma? Then without holding on the other side or without being attaching this spring to a rigid support, I cannot apply force on the first spring. Clear, ma? If I want to elongate a spring, there should be equal and opposite force on the both sides. Clear? So definitely, if I attach this mass to this lower spring, first of all, this spring will elongate. Clear, ma? And restoring force will be given on the first spring also. So therefore, definitely both the springs will elongate. And what about the restoring force? If in the first spring, this is the second spring, no? In the second spring, if restoring force produced is Fr, so here also restoring force produced will be Fr only. So in both the springs, definitely same amount of restoring force will be developed. That is what we have understood, no? If I want to elongate any spring, definitely I should apply equal forces on both sides. Clear? So restoring force produced in both these springs will be equal. So this is the important point of springs in series combination. So therefore, what is the note point here I can write? In series combination, restoring force produced will be same in every spring. What is meant by every spring? For example, if two springs are present, in both the two springs, restoring force will be equal. Similarly, if 10 springs are present, in all the 10 springs also, restoring force produced will be equal. Clear ma? Okay. But they are having different k values, no? This one is having a k value of k1 and this is having a k value of k2. Clear? So what is meant by restoring force? Restoring force is equals to k into x magnitude wise. Clear? So therefore, if their k values are equal, then x values also should be equal. Clear ma? For example, if k values are equal, if elongation produced in this spring is 2 centimeters, then elongation produced in the first spring also will be 2 centimeters. But if k values are different, then elongation produced also will be different. Clear? So therefore, if elongation produced in this spring is x1 and elongation produced in this spring is x2, then what is the total elongation? Total elongation will be this much, which is equals to x1 plus x2. Clear ma? Now if I write here, so total elongation, I can write x total is equals to x1 plus x2. Clear ma? And what is meant by k total? K total can be written as Fr divided by k equivalent. Clear? What is meant by x total? X total is the total elongation produced in the spring. If I consider this total spring as one spring, then total elongation will become x total. Clear? And throughout the spring restoring force is Fr only. Clear? Now what about k equivalent? K equivalent is the k value of total combination. So Fr divided by k equivalent, how I can write? I can write this one as F1 divided by K1 or Fr divided by K1 plus Fr divided by K2. So this is the elongation first spring, this is the elongation second spring. In every spring restoring force is Fr only. So we have written Fr throughout this equation. Clear? So therefore Fr and Fr gets cancelled. So I can write 1 by K equivalent is equals to 1 by K1 plus 1 by K2. Clear? So this is the result I got. Similarly, if there are 10 springs, if there are 2, 3 springs, 4 springs, then how can I write the same relation? Same relation can be written as like this. K equivalent is equals to 1 by K1 plus 1 by K2 plus 1 by K3 and it goes on. Are you able to understand? Ma? Now, by looking at this relation, what do you understand? So, do you understand whether K value has increased or decreased? So, K1 and K2 are the K values are individual springs. K equivalent is the K value of total combination. Clear? Now, by looking at this equation, total K equivalent has it increased or decreased in series combination. Clear? So, definitely by looking at this equation, definitely I can say that K equivalent has decreased. Clear? Because we are writing all the equations in reciprocals. So, definitely what is the note point here we have to write? Note point is in series combination, total K value or I can write it as K equivalent decreases when compared to individual springs. Clear? So therefore now the question is it easier to elongate one spring or is it easier to elongate two springs which are connected in series? Clear? Come on, think about this one. Okay? So the question is it easier to elongate one spring or is it easier to elongate two springs which are connected in series? Okay? So definitely elongating two springs is easier. Why? Because K value has decreased, you know. And what is meant by K value? We will write here. So K is nothing but Fr divided by X. What is meant by Fr divided by X? So to produce an elongation of X, how much restoring force is developed in the spring? If restoring force developed is greater, it means applied force is also greater. That is the meaning of this one, no? So if K value is lesser, it means restoring force developed is lesser. It means applied force is also lesser to elongate that spring. So if K value reduces, it is easy to elongate that particular spring. So for a series combination, K value is reducing. So therefore, to elongate one spring, it is tougher. To elongate two springs in series, it is a bit easier. To elongate three springs in series, it is much easier. To elongate four springs in series, it is very, very, very easier. That is the meaning of this one. Are you able to understand, ma? So total K value in series combination decreases and that is the equation. 1 by K equivalent is equals to 1 by K1 plus 1 by K2, 1 by K3 and it goes on for any number of springs. Students, now let us see about parallel combination of springs. Clear? So consider these are two springs which are having same length but their K values are different. It is having spring constants of K1 and K2. Now we are attaching both these springs to a mass, clear, whose mass is M. Clear? Now if I have attached both of them, then one thing which I can observe is the elongation produced in both the springs will be equal. So therefore, in parallel combination, one point which you should always remember is the elongation produced in both the springs will be equal. So let us make a note here. So in parallel combination, elongation produced is same in all the springs. What is meant by all the springs? Any number of springs may be present, no? 2 springs, 3 springs, whatever it may be. So in every spring, the elongation produced is same. Clear? Now the question is, what about restoring force? So is restoring force also equal or not? So let us see. So restoring force is written by K into X, no? So K into X. So X values are definitely same. So elongation in this one is also X. Similarly, elongation in the second spring is also X. But K values are different, no? If K values are same, definitely you can say restoring force produced is also same. But we have taken different K values, so therefore restoring force produced in this one, if it is FR1, then restoring force produced in the second spring is FR2. Clear? Now what these restoring forces are doing? These restoring forces, they are balancing the weight of this body. Clear? Weight mg is acting downwards, no? So this mg is being balanced by both of these restoring forces, because this mass is being supported by both these springs, no? So therefore total restoring force produced in this combination is Fr1 plus Fr2. So therefore what can I write? So equivalent restoring force is equals to Fr1 plus Fr2. I can write like this. Clear? Now equivalent restoring force, how I can write? I can write it as K equivalent into X, because in a total combination the elongation produced is X. And what is K equivalent? For this total combination I am calculating the K value, which is called K equivalent. So K equivalent into X is equals to Fr1 plus Fr2. What is Fr1? Fr1 is K1 into X, Fr2 is K2 into X, because X values are same in all the springs. So therefore X and X gets cancelled, so I can write K equivalent is equals to K1 plus K2. So this is the total equivalent spring constant of this combination when springs are connected in parallel. Clear, ma? So if more than 2 springs, 3 springs, 4 springs are connected in parallel, then how can I write? K equivalent is equals to K1 plus K2 plus K3, and it goes on continuously. Clear, ma? Now by looking at this equation, what do you say is total K equivalent of this combination? Has it increased or decreased? So this is the addition of K values, no? So it means definitely total K equivalent has increased in this condition. So therefore what can I write? Total K value or K equivalent has increased. Clear, ma? So total K equivalent has increased definitely. So increased means what? So is it easier to elongate one spring or compress one spring, or is it easier to elongate this combination of springs in parallel? So definitely elongating a parallel combination of springs is tougher. Why? Because K value has increased. No? If there is K value is greater, then restoring force developed will also be greater for same amount of displacement. If restoring force developed is greater, it means that applied force also should be greater. So definitely, what can I write here? I can write, it is easier to elongate or compress one spring rather than a combination of springs in which connection? In parallel connection or parallel combination. Clear? So these are the two important points which we have to remember about series combination and parallel combination. Clear, ma? So what is the point which we have to remember in series combination? In series combination, we have to remember that the restoring force produced in every spring is equal. That is what we have discussed, no? But in parallel combination, what we are supposed to remember, in parallel combination, the elongation produced in both of them will be equal. Are you able to understand? So elongation produced are equal. Restoring forces may be equal, may not be equal. It again depends on K values. Clear? That's all. Some examples in series and parallel combination of these springs. So first of all, this is the given question. Two springs whose K values are K1 and K2 and mass of M is attached. So what is the total time period of this combination? So they are connected in parallel, no? Series. So therefore I can write 1 by k equivalent is equals to 1 by k1 plus 1 by k2. Clear? So if I take LCM, then I can write k equivalent is equals to k1 k2 divided by k1 plus k2. So I can write like this. So therefore, so what is the total time period for this combination? So time period is equals to 2 pi root m by k equivalent. So 2 pi root m by k equivalent is how much? So k1 k2 and this k1 k2 goes to the numerator. So m into k1 plus k2 divided by k1 k2. So this will be our answer for first one. Now what about this one? Clear ma? So this is a mass which is connected to springs or two springs. One spring is above this mass, one spring is below this mass. Now first of all, is it a series combination or parallel combination? So how to identify this one? Okay, this is very important. So in combination of springs, to identify which one is a series combination and which one is parallel combination, this is very important. Now can you say, how can I identify whether this combination is series or parallel? Very simple. So you hold this mass, you displace this one by a small factor, by small distance of 1 centimeter. So hold this mass, pull it downwards. Then what will happen? This spring elongates downwards, no? So this spring elongates downwards and this spring compresses downwards. Clear? So if it elongates in this direction, then it develops restoring force in opposite direction. Similarly, if it compresses in downwards direction, then again it develops restoring force in opposite direction. Clear ma? So both these masses, they are attached to this mass, no? So definitely both of them will provide restoring force on this mass. So this is a property of parallel combination. That's what we have studied in parallel combination, no? In parallel combination, both the springs will provide restoring force. And what is the one more property? One more property is that, so the elongation or compression produced in both these springs should be equal. Clear ma? So if this spring compresses by 1 centimeter, then this spring elongates also by exactly 1 centimeter only. Clear ma? So elongations or compressions are equal, and one more property is both of them are providing restoring force. Clear? But in the case of a series combination, so on this body who is providing restoring force? Only this spring is providing the restoring force. Then what is this first spring is doing? It is supporting the restoring force which is provided by this spring. Clear ma? So in this condition, so both the springs are providing the restoring force. So this is definitely a parallel combination of springs. So for parallel combination, what is the total K equivalent? K equivalent is equals to K1 plus K2. So therefore is equals to 2 plus 3 is equals to 5 Newton meter. So therefore T is equals to 2 pi root m by K. So 2 pi root, mass is how much? Mass is 2, K value is 5. So this is our answer for time period in this condition. Clear ma? Now what about this question? So here, so 1, 2, 3, 4 springs are connected to this mass of M. Clear? So definitely I can say these two springs are in series. Similarly, these two springs are in series. And this total combination and this total combination, they are again in parallel. Clear? So same what you called connection, I can draw like this also. How I can draw? I can draw like this. So this is total one spring. Clear? Similarly, this is total another second spring. And both of them, they are supporting this mass of M. Okay? So I can write like this. So these two are connected in series, no? So total K equivalent of this one will be how much? So K1, K2 divided by K1 plus K2. Similarly, these two springs are connected in series, no? So what is the total combination of this combination? K3, K4 divided by K3 plus K4. Because 1 by K equivalent is equals to 1 by K1 plus 1 by K2. Clear ma? Now this spring and this spring, again they are in parallel connection. So if they are in parallel connection, then how can I draw a diagram? So let us see. Here we will try to draw. Clear ma? If both of them are in parallel connection, then I can draw like this. Clear? So this is one spring, this is another spring, and both of them they are connected to this mass of M. So this one is having a spring constant of K3 K4 divided by K3 plus K4, and this one is having a spring constant of K1 K2 divided by K1 plus K2. Clear ma? Now what is the total K equivalent? Addition of these, because these two they are connected in parallel. So K equivalent is equals to K3 K4 by K3 plus K4 plus K1 K2 divided by K1 plus K2. Clear ma? So therefore how can I calculate time period? T is equals to 2 pi root of M divided by K equivalent. In the place of K equivalent, substitute this relation. So that is our answer. Clear, ma? So this is how we have to identify whether the springs, when are they connected in series or parallel. Clear? Similarly, let us see one more question. Which question can we see? Let us see this one. Clear, ma? For example, this is one spring. This is a arrangement like this. Clear? So here there is one spring which is connected like this. Clear, ma? Similarly, here there is one more spring which is connected like this. So this is having a spring constant of K1, and this is having a spring constant of K2, and this is mass M. Now for this total combination, you try to calculate T value. What is the time period? If I move this mass by a small distance of x and release, then what will be the time period of oscillation? Clear? So here also we have to identify whether this, whether this connection, if it is series connection or parallel connection. So how can you identify? Others, again same logic, just displace this one by a small distance of x. If I displace this one by a small distance of x, then what is the elongation produced in the first spring? The same will be the compression produced in the second spring. And both of them, they give restoring force in the same direction, and both of them are providing restoring force on this mass. So definitely this combination is a parallel combination. So when they are connected in parallel, then what is the total K equivalent? It is equals to K1 plus K2. That's all. So therefore, again, the relation is T is equals to 2 pi root M divided by K1 plus K2. So this is the time period. So this is how we have to identify whether the springs, they are connected in series or parallel combination. Okay. So dear students, now let us see this question. So pan attached to a spring balance has a mass of 1 kg. So a weight of 2 kg when placed on the pan stretches the spring by 10 centimeter. Then what is the frequency with which this empty pan can oscillate? That is the question. Clear? So what is the spring balance? This I can consider as a simple spring balance. So a spring will be present, and here readings will be present. And this consists of a pan. And what is the mass of this pan? It is given as 1 kg. Clear? So because of this mass of the pan, there will be already some elongation produced in this spring. Clear? Now what he is saying, we are placing a weight of 2 kg into this pan. So this is a mass of 2 kg. Then what he is saying, it is saying that the spring stretches by 10 centimeter. Clear, ma? So this stretching in spring is only to balance this additional weight, because mass of the pan would have been already balanced by initial elongation. Now this elongation will be only to balance this weight. Weight is a kind of force. Clear, ma? So therefore, the force which is now applied is equal to how much? Weight of the body, which is called mg. So mass is 2 kg, g value is 9.8. So we can take it as 19.6 Newton. Clear? So if this is the weight which we are placing in this pan, then what will be the restoring force? Restoring force also will be 19.6 Newton. Clear? So therefore we have a relation between restoring force and elongation produced. So what is that one? Magnitude of restoring force is equals to K into X. So 19.6 is equal to K value I don't know. And what is the elongation produced? 10 centimeters. So 10 into 10 power minus 2 meter. So therefore K value will be 196 Newton per meter. So this is the K value. Clear? Now what is the frequency with which this empty pan will oscillate? That is, if I remove this 2 kg mass, I pull this pan a bit downwards and release this one, then with what frequency it will oscillate. Clear, ma? So we know that time period is equals to 2 pi root m by k. Already we have discussed this one previously. So frequency is what? Frequency is 1 by time period. So this is equals to 1 by 2 root k by m. Clear? This is the relation. So k value we have, and mass is mass of the pan we have to take here, because this what you call spring balance is oscillating only because of mass of the pan. Clear, ma? So therefore what can I write? So it is 1 by 2 pi root k value is 196 divided by mass is 1. So 1 by 2 pi root 196 is 14. So therefore 7 divided by pi hertz or oscillations per second. So this is our answer for this first question. Let us see this question. An impulsive force gives an initial velocity of minus 1 meters per second to a mass in the unstretched spring position. So what is the amplitude of motion? So that is our first question. And write an equation for x as a function of time. Mass is given as 3 kg and spring constant is given as 1200 Newton per meter. Clear, ma? So what is meant by impulsive force? A force acting for a very small instant, it is called as impulsive force. So here a small impulse is acting for a very small time, f into t. Clear? So instantaneously the mass gains a velocity of minus 1 meters per second. Clear? Minus 1 meters per second indicates that velocity is in this direction. Clear? So, and it is in unstretched position. Unstretched position means what? It means body is present at the mean position. If it starts oscillating, it will oscillate from that position. Clear? Ma? And velocity given minus 1 meters per second, it is at the mean position. It means that is the maximum velocity that body can have. And already we have calculated equation for maximum velocity, which is called as A into omega. Clear? So maximum velocity is 1, A value I don't know, omega value I also don't know. So let it be our equation number 1. But still there, K value and mass are given, no? So we know that K is equals to m omega square. Clear? So then from this I can calculate omega, no? So therefore K by m root is equals to omega. So therefore if I substitute these values, omega is equals to square root of K is 1200 and mass is how much? Mass is 3. So therefore omega is equals to root 400 is 20 radians per second. Clear? So this is the angular frequency which I got. Now substitute in equation number 1. If I substitute in equation number 1, so 1 is equals to A into omega. So therefore A is equals to 1 by omega. So 1 by 20 meters, that is the amplitude of oscillation. Clear, ma? So the same method I can use by law of conservation of energy also, no? So I can also use energy concept also. So what is meant by energy concept? At the mean position, simple harmonic motion will have highest velocity at the mean position. It means there the total energy possessed by the body in simple harmonic motion is only because of kinetic energy. Clear? Because there is no elongation at the mean position, there is no potential energy. So, and at the extreme position, this total kinetic energy would have been converted into potential energy. So therefore, what can I write? At the mean position, total energy is only kinetic, and at the extreme position, total energy is only potential. So therefore, half mv square is equals to half ka square. Why a square? Generally potential energy equation is half kx square, no? But at the extreme position, x value converts into a, that is maximum amplitude. Sorry, amplitude is called maximum displacement. Okay. So half and half gets cancelled. Mass is so much? 3. Velocity is 1 square. K value is 1200. Amplitude I don't know. So a square. So therefore, a square is equals to how much it is? It is 3 by 1200 is 1 by 400. So therefore, a value is 1 by 20 meters. That is the same result which I got previously also. Clear? So this is second method of doing the problem. Then he is asking one more question, no? Write an equation for x as a function of time. It means he is asking to find out displacement equation. So how can I find out displacement equation? Let us see. So displacement equation is very simple. X is equals to minus a sine omega t. Clear, ma? Why I have written minus a sine omega t? Because body is traveling towards negative extremity, no? So already it should have covered an angle of 180 degrees. So now we are writing this value in minus. So therefore x is equals to, amplitude is how much? 1 by 20 sine. Omega value is how much? Omega value did we calculate? Omega value is 20. So 20t. So this is our equation for displacement with respect to time. Okay. Dear students, so now let us see this question. So a particle suspended from a vertical spring oscillates 10 times per second. So at the highest point of oscillation, spring becomes unstretched. So find the maximum speed of the block and find the speed when spring is stretched by 0.2 centimeters. That is the question. Clear? So in the data, so this is the mass which is attached. So in the data itself it is given frequency of oscillation is 10 hertz. Clear? Then again what he gave, at the highest point of oscillation, spring becomes unstretched. So let us try to understand what is the meaning of this one. Sima. So this is the initial position of the spring. Initial condition when there is no mass which is attached. Then in this condition, it will be in unstretched position. Clear? So what is meant by unstretched position? There is no elongation, so its original mean position will be this much. Now if I suspend a mass to this spring, then what will happen? So this spring will elongate by a small distance of, so let the distance elongated by x. Clear? And how can I calculate this x? So we know that on this mass two forces are acting. Weight of this mass is acting downwards, mg. Kx, restoring force, is acting in upward direction. So equate both of them. So Kx is equal to mg. So therefore x is equals to mg divided by k. So this is the elongation produced when we are attaching a mass of m. So now the question is, if I further pull this body downwards and release, then it will oscillate along which mean position? Okay, ma? Now here we have two mean positions. So this is the first position of the spring and this is the second position of the spring. Clear, ma? Okay. So, clear? Now if I pull this body further downwards and release, definitely we have discussed previously, no? It will oscillate along the new mean position. Along this mean position it will oscillate. Clear? So it is given that spring becomes unstretched when it reaches the highest point of oscillation. So here what is the highest point of oscillation? So spring becomes unstretched at this position. Okay, and this he gave, it is the highest point of oscillation or amplitude of the spring is A. Clear? And what is this distance? This distance is nothing but x only, no? Clear? So indirectly he gave that previously what was the elongation produced, with the same amplitude the body is oscillating. That is the meaning of this one. It means from here I am pulling this spring downwards by a distance of x and I have released this one. So therefore from the mean position upwards also it will move by the same distance of x. That is the meaning of this one. So therefore here mg by k I can write to be A also. Okay? Okay. Now let us see what is the first question he is asking. First question he is asking is, what is the maximum speed of the block? So maximum speed already we have discussed, it is equals to A into omega. Clear, ma? So therefore maximum amplitude is A into omega. A value already we have calculated, which is mg divided by k. So mg by k into omega. Clear? But k value is not given. So what can I do? K value already we have studied that k is equals to m omega square. So substitute that value there. So therefore I can write mg divided by m omega square into omega. So m and m, omega, this square and omega gets cancelled. So V max is how much? It is equal to g divided by omega. Clear? And g value he said us to take it as pi square. Why pi square? G value is 9.8, approximately 10, no? So pi square also will have same value. Pi is 3.14. So 3.14 multiplied by 3.14, almost it will have same value of that of g only. Clear? So therefore pi square divided by omega, how I can write? 2 pi into f. So pi square get cancelled. So therefore pi divided by 2 into frequency already he gave, it is 10. Okay? So therefore pi by 20 meters per second. So this is the answer for our first question. Okay? So this is the maximum velocity with which this body will oscillate. And that maximum velocity always exists at the mean position, no? So here when this body reaches to this, which position? Not this position, this position. To this new mean position, then our velocity will be maximum. Clear? Okay. Now let us study the second question also. What is the second question? Find the speed when spring is stretched by 0.2 centimeters. Clear? So for calculating speed we have two relations, no? One relation of speed is V is equals to A omega cos omega t is one relation. Another relation is V is equals to omega into square root of s square minus x square. This is another relation. So V is equals to omega into square root of s square minus x square. This is the velocity depending on displacement. And displacement already he gave 0.2. So definitely I will use that equation for velocity. So V is equals to omega into square root of s square minus x square. This relation I will use. So A value is not given, so how I can calculate? Previously we have calculated, no? A is equals to mg divided by k. So mg divided by k can be written as m omega square. M gets cancelled. So g by omega square can be written as 4 pi square into f square, because omega value is 2 pi into f. G and pi square get cancelled. So A is equals to 1 by 400, because frequency is given as 10, no? 10 tens are 100, 4 into 10 is 400. So this is 1 by 400 meters. So 1 by 400 meters, how can I write in terms of centimeters? Because their displacement is given in centimeters only, no? So meters, 100 centimeters, so 1 by 4. So therefore I can write 0.25 centimeters. Clear, ma? Now substitute in this relation. So V is equals to omega into square root of a square minus x square. So therefore omega value 2 pi into f value is 10. So multiplied by square root of a value is so much 0.25 whole square minus x value already it is given, no? 0.2. So 0.2 whole square. So if I do this calculation total, the answer which you should get is 15.4 centimeters per second. So this is the answer for velocity of the particle when it is at a position of 0.2 centimeters from the mean position. Clear, ma? Come on. Now let us see this question. So this is a frictionless surface. All surfaces are considered to be frictionless. So this is a spring whose spring constant is K and a mass of M is present, and initially this spring is present in relaxed position or unstretched position. So here there is a mass of 2m which is traveling with a velocity of v. So it is given that after collision these blocks will stick together. So what is meant by sticking together? So it means that this is a perfectly inelastic collision. Okay, then we are supposed to find out what will be the amplitude of motion of this system. So here amplitude of motion is nothing but what is the maximum compression produced in the spring. So I can calculate like that also. Clear, ma? Now whether it is an elastic collision or an inelastic collision, momentum is always conserved. No? Clear? So therefore writing momentum equation, what can I write? So m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Clear? So therefore what is the mass of this one? 2m, and velocity is v, and this total momentum will become 0 because it is in rest position. So 0 is equal to, finally what is happening? Both the bodies, they are sticking together. So sticking together means now they will start traveling with a common velocity. So therefore both the masses, I can write 2m plus m is 3m and velocity is v dash. Clear? Common velocity v dash. So mass and mass gets cancelled. So therefore v dash is equals to 2v divided by 3. So this is the velocities with which these blocks will start compression in the spring. Clear, ma? So therefore, what is the maximum compression? At maximum compression, what will happen? So just after sticking together, this spring is in relaxed position. It means that there is no potential energy still which is stored in this system. Clear, ma? Now the blocks have only kinetic energy. And in the time of compression, that is at the time of maximum compression, this total kinetic energy possessed by these blocks will be converted into potential energy. So therefore we can use the law of conservation of mechanical energy. What is the law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. This is the value. Clear? So initial kinetic energy, blocks have initial kinetic energy. So half into what are their masses? 3m. And what are their velocities? Velocities are 2v divided by 3 whole square. So initial potential energy is 0. Final kinetic energy is 0. Why final kinetic energy is 0? Because at the instant of maximum compression, all the bodies are in rest position. Clear, no? And what is U2? Final potential energy. So only spring has potential energy. So I can write half k x square. X is nothing but compression, no? And maximum compression, I can write it as amplitude. So amplitude is square. So half and half gets cancelled. Clear? So therefore what can I write? So 3m into 4v square divided by 9 is equals to k into a square. So 3 1s are 3 3s are, so 4mv square divided by 3 is equals to, or by 3k is equal to a square. So therefore a value is how much? So 2v into square root of m by 3k. Clear? So this is our answer. So this is our answer for maximum amplitude produced in this spring. Clear? Make a note of this one, dear students. Now let us see this question. So the system oscillates vertically. So this system is oscillating vertically. So this is a capital M and this is a mass small m which is placed on this capital M on a spring whose spring constant is k. Clear? Then the first question is, find the resultant force on smaller block at a displacement x above the equilibrium. So above the equilibrium, if this system has gone upwards by a distance of x, then in that position, so what is the resultant force acting on the small block? Clear, ma? So let us see. So for example, if you take this capital M, for example, if this is our capital M, clear? So on this one, a mass of small m is present, and let us consider this was our equilibrium position. Clear? So this was our equilibrium position. So above the equilibrium position, masses were displaced by a displacement of x. Clear? So when masses get displaced by a displacement of x, then what is the acceleration produced in the masses? So already we have calculated, no? So acceleration produced, so a is directly proportional to minus x. So, or I can write a is equals to minus of omega square into x. So omega indicates the direction here. So just if I write a magnitude, so a is equals to omega square into x. Clear, ma? So this is the acceleration experienced by the masses. Now this is the acceleration experienced by which mass? So is it the acceleration experienced by capital M or small m? Clear? So both of them, they will experience the same acceleration. No? So both of them, they were displaced by same displacement from the mean position. So therefore, acceleration in this total system produced is A. This is the acceleration. Clear? So if acceleration produced is A, then what I am supposed to find out? Resultant force. Clear? It means the net force which is acting on this volume. Clear? Who produces acceleration? Always net force can only produce acceleration. This we have been discussing again and again. Clear, ma? So net force always produces acceleration. Clear? So therefore, net force acting is equals to mass into acceleration. So I can write net force acting is equals to mass of the small is a capital M, and mass of this small m is a small m. And what is meant by acceleration? Acceleration is nothing but omega square into x. Clear? But is omega value given here? Omega value is not given. Then what can I do? Omega value is not given. Now what can I do? So very simple. So omega can be written as 2 pi by capital T, no? So therefore what can I write? So m into, so omega square can be written as 2 pi by capital T whole square multiplied by x. So therefore m into, so 4 pi square divided by T. How I can write? T I can write like this, no? So T is equals to 2 pi root m by k. Clear? But here two masses are present, so total mass will become m plus m divided by k. Clear, ma? So therefore, T how can I write? I can write, so this is square, no? So 4 pi square, and these values, they will go to the numerator. So k divided by capital M plus small m multiplied by x. Clear, ma? So this is the force which is acting on this small m. So therefore, what is the total value of force? I can write T is equals to, so F is equals to mkx divided by m plus capital M. Clear, ma? So this is the net resultant force which is acting on small m. Clear? So if displacement is x, then acceleration produced is omega square into x. And who produces acceleration? Only net force can produce acceleration. So mass into acceleration, acceleration is omega square, omega into x. Omega value is 2 pi by capital T, T value this one. So that is how we got this answer. Clear, ma? So now let us go for the next question. Next question is, find the normal force on a smaller block at this position. So this is our second question. And second question, we have one more question that we will solve afterwards. So find the normal force on a smaller block at this position. At which position? At a displacement of x. Clear, ma? So let us see. So let us solve second question, first question in the second question. So therefore, if I take this one as my small m, so what are the different forces which are acting? Its weight mg will be acting downwards, and normal reaction given by capital M will be acting on small m. So this is the direction of normal reaction, and acceleration will be in downwards direction. This is the acceleration. Clear? So therefore, according to Newton's law, how I can write? I can write mg minus n is equals to mass into acceleration. So therefore, n value is equals to m into g minus a. Clear, ma? So a value already we have calculated, no? So equate both of them. So acceleration will become kx divided by capital M plus small m. So therefore, n is equals to m into g minus acceleration can be written as kx divided by capital M plus small m. Clear? So this is the acceleration which is this is the normal reaction which is acting on small m. Clear? Now let us go for the second question in second question. So when is the force smallest? When is the force? Force or normal reaction? So I think it is normal reaction. It is not force, ma? So let me see the question. When is this force? Okay. So when is this force? So what is meant by this force? This force means normal reaction. So in which condition this normal reaction will be smallest in magnitude? Clear? So this normal reaction will be smallest in magnitude when x value is maximum. This is understandable, no? So kx into capital M into small m, we are subtracting from g. So if kx by m plus m, if it is maximum, the normal reaction will become minimum. And what is the maximum value of x there? Maximum value of x is a. So therefore, when x is equal to a, then n will become n minimum. This is how I can write. Clear, ma? So n becomes n minimum when x value becomes equal to a. So therefore, substitute here and find out the minimum normal reaction. So n minimum is equals to m into g minus ka divided by capital M plus small m. So this is the relation of minimum normal reaction which I got. Are you able to understand? So this is our equation for second question. Now let us see, one more question is also there, no? So the next question is, what is the maximum amplitude with which the two blocks may oscillate together? This is the question. Clear? So first of all, make a note up to here, then we will study the next question. The third question is, what is the maximum amplitude with which the two blocks may oscillate together? What is meant by together? So what is the maximum amplitude that can move so that they can return together? It means that, so at the maximum amplitude, what will happen? The body will experience maximum acceleration, no? Because already we have studied that. So acceleration is directly proportional to minus x. Clear, no? So if x value is becoming maximum, then a also will become maximum. So when a becomes equal to, when a is less than or equal to g, so only in this condition, the bodies will not lose contact. How? Let us explain. Simple. So for example, if a value, that is acceleration produced in this system because of maximum amplitude, if this a value is greater than g, then what will happen? This block it is connected to the spring, no? So it will come down definitely with this acceleration because this small m is connected to the string, and definitely it can come down, okay? But this small m, it is not connected to capital M, no? It is just placed on capital M. So therefore, what is the maximum acceleration with which small m can come down? It can freely fall only with an acceleration of g only. Clear? But this block, it is coming down with an acceleration greater than g. So definitely these blocks will lose contact. Are you able to understand, ma? So then what is the maximum acceleration with which these bodies can come down? Maximum acceleration with which these bodies can come down is a is equal to g. Only with this acceleration, both the bodies should come down. Clear? When both of them, when they are coming down with an acceleration of a is equal to g, then what about the normal reaction between these two bodies? Normal reaction will become 0. Why normal reaction becomes 0? Because small m is now a freely falling body. It is falling with an acceleration of g. So if a body is falling with an acceleration of g, then that body does not have any weight. Clear? So capital M loses its weight. It doesn't lose its mass, it loses its weight. So there is no component of weight which is acting on capital M. So capital M also cannot give any amount of normal reaction. Clear, ma? So therefore, normal reaction should become 0 when these blocks, when they are coming down with maximum acceleration of a is equal to g. Clear? Now for normal reaction, already we have calculated a relation, no? So m into g minus of Ka divided by m plus m. So in which condition normal reaction can become 0? Normal reaction can become 0 when magnitude wise g and Ka divided by m plus m, when they are equal. Clear? Because when they are equal, total sum will become 0, then normal reaction between them will become 0. That's all, no? So therefore, what can I write? I can write, so g should be equal to Ka divided by m plus m. Clear, ma? So therefore, a is equals to m plus m into g divided by k. So this is the equation for maximum amplitude with which these blocks can oscillate. Clear? That's all. Dear students, now let us see this question. So this is a spring which is attached to this vertical system, and spring is attached to capital M. Capital M is present on a frictionless surface, and on capital M, a mass of a small m is present, and there is a friction between capital M and small m, and coefficient of friction is mu. Clear? Then what we are supposed to find out, if a system is slightly displaced and released, find the time period. Clear, ma? So if system is slightly displaced and released, then capital M starts accelerating towards the mean position. So along with that, small m also should accelerate. And who will provide acceleration for small m? Friction will provide the acceleration. Are you able to understand, ma? So let us try to understand this one. So if this is capital M, clear? So if it is moves in this direction with an acceleration of a, then small m also should move in the same direction with an acceleration of a. Clear? So who provides this acceleration for capital M? Friction between small m and capital M will provide the acceleration. Clear? So initially, slightly displaced, so acceleration produced is also very less. So if acceleration produced is very less, then the friction necessary also is very less. Because on this small m, the only one force which is acting is friction, which is producing the acceleration. Clear? So therefore, if it is small m, clear? So only friction is providing the acceleration, which is mass into acceleration. Are you able to understand, ma? So therefore, what is the time period I can write? So both of them, they are moving as a single body, no? And they are moving as a single body because of friction. So for the first condition, time period can be written as 2 pi root m by k. Here m is the total m plus m divided by k. So this is the answer for the first question. Clear? So why I am writing m plus m here? Because both the bodies, they move as a single body. Okay? Why they are moving as a single body? Because of friction. Clear? Okay. Now let us see the second question. So find the magnitude of frictional force between the blocks when the displacement from the mean position is x. So this we are supposed to find out. Clear, ma? So when displacement of these blocks from the mean position is x, then what will be the acceleration experienced by this capital M? This experiences an acceleration of a is equals to omega square into x. Minus I am not writing here because minus represents just direction. So therefore, capital M experiences an acceleration of a is equals to omega square into x. Clear, ma? Then small m also should move with the same acceleration, no? Small m also should move with same acceleration. And again, who provides that acceleration? That acceleration is again provided by friction only. Clear, ma? So therefore, the same acceleration should be experienced by small m also. So therefore, if I write this small m, so this should move with an acceleration of a is equals to omega square into x. And who provides this acceleration? Friction provides this acceleration. Clear? So therefore, friction, how I can write? Friction is the net force which is acting on this small m, and this is equals to mass into acceleration. Clear, ma? So therefore, here I can write, so therefore, friction is equals to mass into acceleration can be written as omega square into x. So omega square into x. Clear? Now, omega value is not given, no? So instead of omega, I can write 2 pi by capital T. So therefore, f is equals to m into, so 2 pi by capital T whole square multiplied by x. So therefore, f is equals to m into, so 2 pi divided by t. And what is the time period? Now also they are moving like a single body, no? So again time period remains to be same. 2 pi into square root of m plus m divided by k. So therefore, how I can write? So 2 pi into square root of m plus m divided by k whole square multiplied by x. So this is how I can write. So 2 pi gets cancelled. So f is equals to m into, this k goes to the numerator. So mkx divided by m plus m. So this is the amount of friction which is acting when the displacement is x in these bodies. Clear, ma? Now next question, third question. So this was our second question, third question. So now the question is, what is the maximum amplitude if the spring, if the upper block does not slip relative to the lower block? Clear, ma? So in which condition slipping will take place? Slipping will take place when friction is not able to support the required acceleration. Clear, ma? When displacement of the body is from the mean position, if it increases continuously, then acceleration also increases, no? Because already we have studied that acceleration is directly proportional to minus x. Clear? As the displacement from the mean position increases, acceleration also increases. Clear? So this body can move happily because this is connected to spring, no? So this mass can have any acceleration. But what about small m? Small m cannot have any acceleration because movement of a small m depends on friction, and friction cannot be limited. No, sorry, friction cannot be unlimited. So there is a maximum value of friction which is called as limiting friction. Are you able to understand? So therefore, let us try to understand this one. Clear, ma? So this small m, the maximum limiting friction which can be acting on this body is Fl. And what is Fl? Fl can be written as mu s into capital M into G. So this is the maximum friction that can be produced in small m. Clear, ma? And this friction should provide acceleration for this body. So maximum acceleration that can be produced with this limiting friction is this much. So mu s mg is equals to mass into A maximum. So this is the maximum acceleration. Clear, ma? Because limiting friction can have only maximum acceleration of mu s n value is mg. So therefore, maximum acceleration which it can produce is m into A max. Clear? Fl is equals to mu s mg is equals to m into A max. Clear? So therefore, acceleration when it will be maximum, when amplitude is maximum, because already we have studied, no, acceleration is directly proportional to x. So when x is maximum, A is also maximum. So let that maximum amplitude be A. Clear? So therefore, how can I write? I can write, so mu s mg is equals to m into omega square into A. Are you able to understand, where A is the amplitude? So m and m gets cancelled. So mu s into g is equals to omega can be written as 2 pi by capital T into whole square multiplied by A. Clear? So therefore, mu s into g can be written as 2 pi by T value can be written as 2 pi into square root of m by k. So I can write k divided by m plus m whole square multiplied by A. Clear? So I have written up to here. Now let us see what is the A value we will get. Okay, ma? So therefore 2 pi and 2 pi gets cancelled. So therefore mu s into g is equals to k divided by m plus m into A. So therefore, A is equals to mu s g into m plus m divided by k. Clear ma? So this is the maximum amplitude with which bodies can oscillate, so that both the bodies, they can move as a single body. Are you able to understand ma? And we can solve this problem in a second method also, third one. Second method. So what is the second method of solving this one? So this is the maximum acceleration, this is the maximum friction that can be produced in capital M, no? And that maximum friction I can equate to this one. So if it's instead of x, if I write A value, clear? Because F is directly proportional to x here. Friction is directly proportional to x. So if x becomes A, then F becomes FL, clear? So therefore what I can do, so maximum limiting friction, which is equals to mu s mg, it can also be equated to, so mka divided by m plus m. I can equate like this also, clear ma? So therefore again, this m and m gets cancelled. So again I will get the same result. So mu s into g into m plus m divided by k, clear? So in these two methods we can do the problem, clear? Come on, make a note of this one. Dear students, now let us see this question. So this is the given system. So on this inclined plane, a spring is present whose spring constant is k, and this angle of inclination is theta. So this mass m1 is attached to this spring, and mass m2, it is just placed on this inclined surface. It means there is no attachment between m1 and m2. Only mass m1 is attached to the spring, clear? Then these are the questions which we are supposed to answer. First question is, what is the compression in the equilibrium position? What is meant by equilibrium position? If there is no movement, or if all the net forces are becoming zero, then in that position, what is the compression produced in this position? Okay, so how can I calculate compression? Very simple. For example, if you consider these both masses as a single mass, whose mass is m1 plus m2, then this weight of this body I can split into two components, mg sin theta and mg cos theta. So already we know this one, and we know that this is the force which is pulling these two body downwards. And what is the magnitude of this force? So m1 plus m2 into g sin theta will be the force, clear? So already we have studied splitting of vectors, Nama. For example, if on an inclined plane a mass is present, its weight mg is acting downwards. This mg I can split into two components. So if angle of inclination is theta, this is also theta. So this becomes mg sin theta and this becomes mg cos theta. So already we have studied them many times. So here total mass is m1 plus m2. So m1 plus m2 into g sin theta, it is the force which is pulling these two bodies downwards, clear? But these bodies are in equilibrium, no? It means there is another force which is pushing these bodies upwards, and that force is balancing this m1 plus m2 into g sin theta. So what can be that force? That force is nothing but the restoring force that is produced in the spring, which is in opposite direction. So that restoring force is given by kx. So therefore these two forces must be balanced. So therefore how can I write a relation between them? I can write kx should be equal to m1 plus m2 into g sin theta, clear? So therefore what is x value? X is the compression produced in the spring, so it can be written as m1 plus m2 into g sin theta divided by k, clear? So this is the initial compression produced in the spring, okay? Now we are supposed to answer second question also. So in addition to this compression, initially there is some compression of x whose value is this much. So in addition to this compression, if I further push this spring and release, then where these two blocks will get separated? That is the question, clear ma? So that is after reaching which position, so these two blocks will get separated in which condition? If I am further pushing these blocks by further distance in the same direction of initial compression, then at which position these two blocks will get separated? That is the question. So let us try to understand how we can try to understand this one. See ma. For example, if mass m1 and m2 are absent, so consider only spring is present, then how can I draw a diagram of this one? I can write, so this is the initial position of the spring, clear? So this is the spring, and spring should be present in its natural length. So therefore I can say this is the position of natural length of the string. This is the natural length of this spring. Clear? Now after placing the masses, what will be happened? So they will be compressed by a distance of x, no? And this x value already we have calculated. So m1 plus m2 into g sin theta divided by k. So that much amount of compression will be produced in this spring. Clear, ma? So let that compression, let it be x. Here we calculated x only, no? So therefore spring should have been like this. It is compressed by this much of distance. Understand? Now from here again what we are doing from here, again we are compressing this spring by another distance of, so from where to where we are compressing, let us consider I am further compressing this one by an additional distance of x1. Clear? So this is the additional distance which is compressed, which is x1. Now what is the position of the spring? Spring is highly compressed. So spring has become like this. Are you able to understand, ma? So this is additional compression produced in the spring. Now if I release the spring from here, now what will happen? That is my question. Clear, ma? So these two blocks, they start moving upwards. Why? Because when I further compress the spring, there is an additional potential energy which is stored in the spring. So this additional potential energy, it starts converting into kinetic energy of the blocks. So velocity of the blocks continuously increases. Clear, ma? So from here, first of all, they will reach to an initial compression, so which is at a distance of x here. Clear? So here also spring is not present in its natural length. So from here again it will go to this position. Clear, ma? So let us consider this is position number 1, this is position number 2, and this is position number 3. Clear? So first of all it will move from position number 3 to position number 2. So in the process of going from 3 to 2, so what is happening? So spring is still compressed. Clear? So in traveling from 3 to 2 also, still there is a compression of x here. Clear? So again restoring force will be in the same direction. Restoring force will be in this direction. Compression is in this direction, no? So restoring force will be in opposite direction even up to position number 2. Clear? Now from position number 2 to position number 1 also, restoring force will be in the same direction, because again there is some compression produced in the spring. Clear, ma? Now when this spring reaches position number 1, when it reaches this position number 1, now what happens? This is the natural length of the spring, no? This is the natural length of the spring. So here restoring forces will become 0. Clear? Here restoring forces will become 0. So up to position number 1, what will happen? Up to this position number 1, both the blocks, they will move like a single body. Both the blocks definitely they will move like a single body. Now from position number 1, what will happen? Now when this spring crosses this main position, then there is an elongation produced in the spring. And this elongation will produce a restoring force in backward direction on mass m1. Okay? Then what about mass m2? Mass m2 is not attached to mass m1, no? Mass m2 is not attached to mass m1. So restoring force will be produced only on mass m1. Clear, ma? So therefore here what can I write? After crossing the position 1. Clear, ma? So which is position 1 here? This position, which is the natural length of the spring. Clear? After crossing position number 1, so restoring force pulls mass m1 in down in the mass m1. What can I write? Mass m1, no need of in here, so directly I can write down the inclined plane. Clear? So therefore after crossing the natural length of the spring, now how many forces are acting on mass m1? So where shall we write? We will write here. So on mass m1, totally how many forces are acting? One force is this one. So m1g sin theta, this is one force, and additional force is k into x. Why k into x is in this direction? Because elongation of the spring is in this direction after crossing position number 1. Clear, ma? But on mass m2, what is happening? On mass m2, there is only one force, and which is that force? That is, this is m2, no? So m2g sin theta. Clear? On mass M2 there is only one force, but on mass M1 there are two forces which are called M1g sin theta and also Kx. Clear? So therefore the retardation produced in mass M1 will be greater when compared to the retardation produced on mass M2. Clear? So definitely at this position both the blocks will get separated. Clear ma? So therefore at position number 1, so which position? When the spring is in its natural length, at this position both the blocks will get separated, because only at this position only the retardation produced in mass M1 is greater than the retardation produced in mass M2. Clear ma? So velocities of both the bodies will definitely decrease, but the decrease of velocity in mass M1 is greater when compared to decrease of velocity in mass M2. Clear? I hope you have understood a question. Make a note of this one. Dear students, now let us see this question. So this is the given arrangement. So this mass, it is being attached to two springs, and each spring is having a spring constant of K. Clear? So these two springs they are separated by an angle of 90, and with respect to horizontal, this spring is at an angle of 45 degrees. So this is the given arrangement. So if this mass is slightly pushed against a spring C, what is meant by spring C? If this mass is displaced in this position, clear ma? In the direction of C, and released, and it is also slightly pushed, clear ma? Then calculate the time period of oscillation. So let us see how we can do this problem. So for example, if you take the system of A and C, so therefore, for example, this is the mass, and mass is shifted in this direction by this much amount of distance. Clear? So if mass is displaced in this direction, this spring should be displaced downwards. Clear? Actually, it will be displaced by a small angle of theta, but angle theta we are neglecting because already it is given that mass is slightly pushed. So therefore, what can I say? So therefore, this spring will be displaced in this direction by a small angle, by a small distance. Clear? So if this is the elongation or compression produced in spring C, clear? Then this angle is 45 degrees. If this is 45 degrees, then this angle also will be 45 degrees. So this will be x sine 45, and this will be x cos 45. So therefore, the elongation produced in spring A is x cos 45 downwards. Are you able to understand? So if elongation is in downwards direction, then what will be the direction of restoring force? Restoring force will be exactly in opposite direction. So this will be the direction of restoring force which is acting on block A. Clear ma? And what is x value? X value is x cos 45. And x cos 45 is how much? K into x cos 45 value is root 2. Clear? So kx divided by root 2 will be the restoring force produced in spring A. Clear? Okay. Now let us see the system of B and C now. Clear ma? So from here, if C is displaced in this direction, then we can say that B will be displaced in forward direction towards the left side. So therefore I can say this will be the displacement produced in B, spring B. Clear ma? So therefore, which angle is 45? This angle is already given as 45, no? So this angle will be 45 degrees. Clear? So therefore, if this is the compression produced in spring C, then this will be the elongation produced in spring B, which is called as again x cos 45. Clear ma? So if this is the elongation produced, then what will be the direction of restoring force? Restoring force will be exactly in opposite direction, which can be written as kx cos 45. Clear ma? So kx divided by cos 45 is how much? 1 by root 2. So kx divided by root. Clear ma? So therefore, and because this spring is elongating in this direction, in spring, so spring is elongating, spring C is compressing in this direction, no, by a distance of kx. So therefore, in a spring C also, restoring force would have been developed exactly in opposite direction by same value of kx. Clear ma? Sorry, this is the compression produced in x, and this is the restoring force produced in x. So which is again making an angle of 45 degrees. Clear ma? So if this angle is 45, so spring is also, restoring force is also produced at an angle of 45 degrees. Clear? So now on this mass totally how many restoring forces are produced? Clear? So let us draw here. So total amount of restoring force produced on this mass. Clear? So one restoring force is kx by root 2 because of the elongation produced in spring A, and that will be in this direction. Clear? So this is equals to kx divided by root 2. Clear ma? And because of the elongation produced in spring B, the restoring force produced in spring B will be kx cos 45 only, and this will be in this direction. So this is also kx divided by root 2. Clear now? Now what about the restoring force produced in the mass in the spring because of the compression which is produced in spring C? So that is in this direction. So that will be exactly at an angle of 45 degrees. So I will write here. So this is kx divided by root 2 in spring A, and this is spring B, and this is the restoring force produced which is equal to kx because of spring C. Okay, so these are the three restoring forces. Now if I take the resultant of A and B, they are exactly at an angle of 45 degrees. So A and B, they are exactly at an angle of 45 degrees. So by using triangle law of addition, how can I join A and B restoring forces because of A and B? I can join like this. Clear? So this is also kx divided by root 2, and this is also kx divided by root 2. Clear? So this is the total restoring force produced because of only A and B. So which is equals to square root of kx divided by root 2 whole square plus kx divided by root 2 whole square. Clear ma? So kx divided by root 2 whole square plus kx divided by root 2 whole square, it will be how much? Kx by 2 plus kx whole square divided by 2 plus kx whole square divided by 2 will be root of kx whole square. So therefore it will be equal to kx. Clear? So therefore what is the total restoring force? So resultant of these two will be kx, and already there is one kx because of the restoring force produced in spring C. So therefore total restoring force will be in this direction, which will be kx plus kx. Clear? So this is the restoring force because of A and B, and this is the restoring force because of spring C. So total restoring force will be how much? It will be equal to 2kx. Clear ma? And restoring force, we can indicate this one by negative symbol, no? Because if elongation is in one direction, then restoring force will be in opposite direction. Okay? First make a note of this one, then we will try to derive here. Okay? Sigma. So therefore the restoring force produced is how much? The restoring force produced will be minus 2k into x. Clear? Because restoring force is in opposite direction to the direction of displacement, no? So we are representing by minus symbol. And this restoring force, this is the only force which is acting on mass m. So that restoring force will become the net force. And what is net force? Net force is nothing but mass into acceleration. So therefore A can be written as minus 2k by m into x. Clear? Acceleration can be written as d square x by dt square. Clear? Plus 2k by m into x. So totally it should be equal to 0. So comparing this equation with the standard equation of SHM, basic equation of SHM. So what is the basic equation of SHM? So d square x by dt square plus omega square into x is equal to 0. So this is the basic equation of SHM, no? So when you compare with this relation, then what I will write? I will get omega is equals to square root of 2k divided by m. Clear? So where shall we write? I will write here. So therefore what can I write? By comparing these two equations, I will get omega is equals to square root of 2k divided by m. Clear ma? And what is omega? Omega is nothing but 2 pi divided by capital T rho. So therefore t value will be 2 pi into square root of m by 2k. So this is the equation for time period of this mass if it is slightly displaced by small distance and released. Clear? I hope you have understood. Make a note of this one. Question, see what is happening here. So this is a spring whose natural length is up to here. So this is the main position of the spring. Clear number? So what we are doing is we are compressing this spring. We are compressing up to which position? Up to a position of minus A. If this is plus A, so the compression on the other side will become minus A number. So up to that we are compressing this spring and we are releasing. So then what is happening? He said that there is an elastic wall at a distance of plus A by 2. So actually if there is no wall, it should perform oscillations between minus A and plus A. Minus A ki plus A ki madhyalo oscillate avutundi kada. Clear nama? But wall is present where? Wall is present at a distance of plus A by 2. It means the spring can oscillate only up to minus A and plus A by 2 only. Are you able to understand ma? Then find the time period of oscillation of this block. Okay. So time period of oscillation we are supposed to calculate. So consider this mass is a point mass, very small mass. Clear now? So therefore wall is present here. What is this wall? So this is a vertical wall, vertical elastic wall. Okay ma? So it means a spring can oscillate with the help of this mass. So a small mass m is attached here. So this mass can oscillate only in between, if this is a by 2 plus a. So somewhere here minus a will be present. So spring can oscillate only in between this distance only, no? So up to here it is minus a, and from here it is a by 2. So spring can oscillate only in between these two gaps. Elastic wall means what? It goes and strikes with the wall and returns back with the same speed. That is called as elastic wall. Okay. So first write down what is meant by elastic wall now. So elastic wall means the mass bounces back. The mass bounces back with same speed. Okay, ma? So actually mass should travel up to plus a, no? Mass should travel up to plus a. But at a by 2 only wall is present. So therefore it will strike the wall and it will return back from a by 2. Are you able to understand? So what is the total time period of oscillation that I want to calculate? Can you say how can I do? So it travels up to a by 2. At a by 2 it will have some velocity. With that velocity it strikes the wall. Are you able to understand? And it returns back also with the same speed because wall is elastic in nature. So how can I calculate time period? Any idea? Sima. First of all, let us calculate what is the time taken to travel from 0 to a by 2. How much distance was 0 to a by 2? Okay. So time taken to travel from where to where? To travel from 0 to a by 2. Are you able to understand? So how can I calculate? I can use the position equation. No? X is equals to a sine omega t. So this is the position equation from the main position. No? Here. So distance is a by 2 is equal to a is equals to sine omega into t. So a and a get cancelled. So sine omega t is equals to 1 by 2. Clear, no? So sine omega t, if it is 1 by 2, then sine 30 is also 1 by 2. No? 30 degrees, how can I write? Sine pi by 6 is equals to 1 by 2. Clear, no? Therefore, can I say omega t is equals to pi by 6? Omega t and pi by 6 both are equal. Clear, no? Omega can be written as 2 pi by capital T multiplied by small t is equal to pi by 6. So pi and pi get cancelled. So therefore, what is the time taken? Time taken is equals to t capital T divided by 12 seconds. Clear, no? So how much time the body will take to travel from 0 to plus a by 2? So 0 to plus a by 2, it will take a time of t by 12 seconds. Understood, Nama? Now it travels from 0 to a by 2 and strikes this wall. After striking the wall, again it should return back from a by 2 to again main position. First 0 to a by 2. Then after striking again it should return back from a by 2 to 0. So therefore, what is that time? T2 is equals to, this is also equals to t by 12 seconds. Nama? So what is T1 and what is T2? T1 is the time taken from 0 to a by 2. Clear, Nama? T2 is the time taken from a by 2 to 0. Clear, no? Are you able to understand? 0 to a by 2, t by 12. And a by 2 to 0, another t by 12. So what is the total time? Total time from traveling from 0 to a by 2 and a by 2 to 0 is how much, ma? It is t1 plus t2. So how much? T by 12 plus t by 12. Clear? T by 12 plus t by 12, it is t by 6. One value I have calculated. Ma? Are you able to understand? Ma? Then what is the time taken from 0 to minus a to 0 and 0 to minus a? That will be how much time? Now we have calculated what? We have calculated time taken from 0 to a by 2 and a by 2 to 0. Total time is t by 6. Are you able to understand? Okay. Clear, ma? Late I allow karta nahi ji aapa mein. Clear, ma? So what is the time taken from minus a to 0 and 0 to minus a? Ma? Come on. So minus a to 0 means it is only 1 by 4th of oscillation. No? Minus a to 0. How much oscillation? 1 by 4th of oscillation. So time taken also 1 by 4. T by 4. That's all. So therefore, another again time taken from minus a to 0. How much, ma? It is t by 4. Okay. So there will be one more time also. No? Time taken from where to where? 0 to minus a. Again it will be t by 4. Now this completes one oscillation, no, ma? Now one oscillation is completed, no? Okay. So minus a to 0, 0 to a by 2. A by 2 to again 0 to minus E. That completes one oscillation. Are you able to understand? So therefore, what is the total time taken? Therefore, total time taken is how much ma? So here already I have calculated, no, T by 6 plus T by 4 plus T by 4. Add all of them. Are you able to understand? So therefore, T by 6 plus T by 2. Okay. So I will do the calculation here, ma. Make a note up to here first of all. So let us calculate the total time taken, ma. Let it be T dash. T dash is equals to how much? T by 6 plus T by 2. So let us take LCM as 6, ma. So T plus 3T. So how much it is? 4T divided by 6, 2T divided by 3. That's all, ma. So this is the amount of time taken. Okay. So and we know in general conditions, what is the formula for time period of a horizontally loaded spring, ma? 2 pi root m by k. This is the formula, no? But what is the new time period I got? T dash is equals to 2t by 3. So 2 by 3 times of t value. So 2 pi root m by k. So 4 pi by 3 root m by k. That is my answer. Understood now? Clear now? So at a by 2 there is a elastic wall. So oscillations are limited from minus a to plus a by 2 only. So for that condition we have done the total calculation. Clear? That's very simple. Okay. So let us see this question, ma. What he is saying here. So this is a spring to which a mass of m is connected, ma. Spring constant is k, mass is m. These are the values which are given, and it is performing simple harmonic motion from minus a to plus a. So therefore then what we are doing is, when it is present at a by 2, that is at the positive direction, when it is present at half of the amplitude towards right direction, we are giving an impulse. Impulse means we are applying some sudden force on this mass. So that what happens to its velocity is becoming double. At a by 2, the velocity of the mass has suddenly become double. Clear, no? Without changing direction. That means in the same direction only we are providing the impulse to the body. Impulse means we know, product of force into time. Clear, no? Then what is the new velocity at that position? And similarly, what will be the new amplitude? Initial amplitude is plus a and minus a, no? When I give a sudden impulse, it means if I suddenly apply some force on this mass, definitely its velocity also increases and its amplitude also increases, no? The distance up to which this mass travels, that also will increase. So these two values I am supposed to calculate. Can you say how can I do it? See, whether I give an impulse or whether I don't give an impulse, time period never changes, no? That's what we have studied in the starting classes, no? Time period is never going to change. Why? Why time period never changes? ఒక సడన్ ఫోర్స్ అప్లై చేస్తున్నాం కదా ఇక్కడ మనం a by 2 దగ్గర సుత్తితో ఎవడో కొట్టినట్లు అనుకోండి. Suddenly velocity of the mass has increased and its amplitude also will increase. Clear, no? What about time period? Time period, will it change or not? Time period will never change. Why? Because formula of time period is 2 pi root m by k, no? This is never going to change. Because k, spring constant, it depends on the stiffness of the spring mass, the mass which is attached. Until these values doesn't change, time period also does not change. Clear, no? If a time period doesn't change, what about omega angular frequency, will it change? How many oscillations it is performing in 1 second, will it change? No, it will also doesn't change because omega is 2 pi divided by capital T, no? If T doesn't change, omega also doesn't change. So these values, they are constants. Clear, no? And if omega is constant, omega is equals to 2 pi f is also a constant. This is also a constant. Frequency is also a constant. Angular frequency is a constant. Time period also is a constant. Clear, no? So therefore, at a by 2, when it is present at a distance of a by 2, what will be its equation of velocity? Velocity only he is asking, no, new velocity. What is the actual velocity, ma? Actual velocity is v is equals to omega into square root of s square minus x square. This is one equation. Why we are using this equation? We have one more equation, no? V is equals to a omega cos omega, it is also there, no? Why we are using this equation? Equation enduku vaadtam, no? Because everything is depending on position, no? Position. And this is the equation depending on position. There is another equation which depends on time, but this is the equation depending on position. So now substitute. My x value is how much? X value is a by 2, no? So find out. V is equals to omega into square root of s square minus a by 2 whole square. Clear, no? So V is equals to omega into square root of s square minus a square divided by 4. So V is equal to omega into square root of 3a square divided by 4. Clear, no? So this is the original velocity. When body was oscillating naturally without any force. Okay, so this was the original velocity. At which position? At a position of a by 2. Clear, no? Now when I gave impulse, velocity suddenly became double. No? It means to this velocity, velocity will become double. That's all. No? So therefore, what is the new velocity? New velocity, let us call it as v dash. So v dash will be how much? Ma? 2 omega into square root of 3a square divided by 4. This is the new velocity. So this is my answer. Understood? No? Okay. Ma? And omega value we don't know, but k and m we know. No, ma? So I can write, we know that k is equals to m omega square. No? Already we discussed this one. No? K is equals to m omega square. So therefore omega is equals to how much? Omega is equals to root k divided by m. So you can substitute there. So therefore velocity in terms of given values is how much? New velocity is equals to 2 into root k by m multiplied by square root of 3a square divided by 4. So that will be the new velocity. Understood? No? So one answer I have calculated. New velocity. New amplitude, how can I calculate? So if I give an impulse, definitely amplitude also will change. No? Maximum displacement from the mean position, that also will change. That one how can I calculate? కొత్త amplitude. A/2కి వచ్చిన తర్వాత సుత్తితో కొట్టినాడు ఎవడో, కొడితే amplitude కూడా పెరుగుతుంది కదా వెలాసిటీతో పట్టి. దట్ న్యూ amplitude how can I calculate? చెప్పండి. మళ్ళీ అదే ఈక్వేషన్ తీసుకున్నదే కదా. ఆల్రెడీ వీ నో న్యూ వెలాసిటీ. Once you know new velocity, why don't you find new amplitude? What is the equation for velocity? New velocity v dash is equals to 2 omega into square root of 3a square divided by 4. This is the new velocity. No? And velocity again you write in terms of amplitude. So v is equals to omega into square root of a dash square minus a by 2 whole square. Can I write like this? Formula of velocity, omega into square root of a square minus x square only. No? A dash is new amplitude. New amplitude. Position is same position, a by 2 position only. No? So can't I equate these two? New velocity, velocity equation in terms of new amplitude. Now just do the calculations. Omega, omega get cancelled. So therefore, what I am left with now? So let us square on both sides. Squaring on both sides, I will get to 4 into 3a square divided by 4. This is equals to how much? A dash square minus a square divided by 4. Okay. Now anything which get cancelled, 4 and 4 get cancelled. So a dash square is equals to 3a square minus a square divided by 4. Okay, 12 minus 1 is, this will become plus 12, 13. 13a square divided by 4. Clear? No? So therefore, I will write here. Therefore, I want a dash, new amplitude. So a dash is equals to how much? Root 13 a divided by 2. This is the new amplitude. That's all very simple. Now let us see this question. So a horizontal spring block of mass m performs a simple harmonic motion. So when the block is passing through the equilibrium position, so another mass small m is put on it and both move together. If original amplitude is a, then find the new amplitude and frequency of oscillation if original frequency is f. So this is what we are supposed to find out. So let us see what is happening here. So actually, so consider this is a spring which is connected to a mass of capital M, and this is performing simple harmonic motion. So at the mean position, so consider this is the mean position. So we are placing another block whose mass is small m. Clear? Then we are supposed to find out the new frequency of oscillation. Clear, ma? So here, how we are placing this second mass? We are placing the second mass such that horizontal forces applied on the capital M are 0. So if horizontal forces are absent, then what is the meaning of this one? So it means that momentum cannot be changed. In the direction of motion, if horizontal forces acting are 0, then momentum of a body will never change. This is what we have been studying. So therefore here we write, if horizontal forces are absent, then we can write if external forces are 0, then in which direction? In the direction of motion of the body, external forces are absent. Bodies are moving horizontally. No? So in horizontal direction, the forces applied are 0. Then momentum is conserved. Momentum will be always conserved. So what is conservation of momentum? Total initial momentum is equal to total final momentum. So therefore I can write m1 v1 is equals to m2 into v2. This is what I can write. So total mass, initial mass is so much, capital M, and total initial velocity I don't know, so let it be E1, and final mass is an addition of capital M and small m, and final velocity also I don't know, so let it be V2. Clear? Now these are velocities V1 and V2 which are present at the mean position. So at the mean position, velocity of simple harmonic motion, it is maximum. So therefore, what is the equation for maximum velocity? I can write. So V is equals to maximum velocity formula, V max is equals to A into omega. So this is the equation for maximum velocity. Already we have studied many times. Clear, ma? So therefore, initial velocity. What is initial velocity? Before placing the small m. So V is equals to initial amplitude is A, and initial omega 1, initial angular velocity can be written as omega 1. So therefore I can write V1 is equals to A into omega can be written as square root of K divided by M. So this is our initial final, maximum velocity at the main position. Clear? Similarly, how can I calculate final velocity, final maximum velocity at the main position? So again, V2 is equals to final amplitude, I don't know, so let it be A dash. So A dash into square root of, and final angular velocity is omega 2, and omega 2 can be written as K divided by capital M plus small m, because there is an additional mass number. So therefore angular velocity will become omega is equals to square root of K by M plus M. Clear? Now take this V1 and V2 and substitute in this original equation, then what I will get? So M into V1. So instead of V1, what I can write? I can write A into square root of K divided by capital M. So this is equals to M plus M. So M plus M into, now final velocity. Final velocity is how much? A dash into square root of K divided by M plus M. Clear? So therefore, here root K and root K gets cancelled. Therefore, what is the final equation I am getting? I am getting, so root M into A is equals to, so A dash into square root of M plus M. This is the result which we will get. Clear? So from this, what I am supposed to find out? I am supposed to find out A dash. So therefore, we will calculate A dash here. So therefore, A dash is equals to square root of M divided by M plus M into A. So this is our equation. So therefore, A dash is equals to A into square root of M divided by M plus M. So this is the final amplitude of the body when a body of mass small m is placed on this capital M. So based on which concept we have done this problem? We have done this problem based on the law of conservation of momentum. So if external forces which are acting in the direction of motion of the body, if they are absent, then total momentum always remains a constant. Clear, ma? So come on, make a note of this one. Then we will try to calculate frequency also. Final frequency also we are supposed to find out, no? Come on, make a note of this one. Okay. So now let us see how we can calculate the final frequency. So here we will try to calculate the final frequency. So we know that omega is equals to 2 pi into f. Clear? So therefore omega 1 is equals to 2 pi f1 and omega 2 is equals to 2 pi into f2. What I want f2? So 2 pi f2 divided by 2 pi f1 is equals to omega 2 divided by omega 1. So 2 pi gets cancelled. So f2 is equals to f1 into omega 2 divided by omega 1. So f2 is equals to initial frequency is already given, it is f. Clear, ma? And similarly omega 2 divided by omega 1. So what is omega 2? Omega 2 already here we have calculated, no? K divided by root of M plus M. So square root of K divided by M plus small m divided by omega 1. What is omega 1? This is omega 1, square root of K divided by M. So substitute that one. So square root of K divided by capital M. So root K and root K gets cancelled. So again I will get F2 is equals to F into, so I will get square root of capital M divided by M plus M. So this is our equation for final frequency. Okay, come on, make a note of this. Okay, ma? So now let us see this question. So here in the following arrangements, clear? So if a block is slightly displaced from the mean position and released, then find the time period of oscillation. Clear, Nama? So this block, if it is slightly displaced and released, then this block will perform with what a time period for oscillation. Clear? So let us see. So here what we will do is, let us do how we can do for the first one. So let us assume this block comes down by a distance of x. Then because this is a single string, so definitely I can say that this spring also will be elongated by x only. And here if tension is T, here also tension will be T only. Clear, Nama? Because it is the same string which is connected. So therefore what I can write? I can write restoring force is equals to minus k into x. So on this mass, what is the restoring force? T. So T is equals to minus k into x. So therefore definitely I can say here k value remains to be k only. If k value remains to be k only, then what is the equation for time period? So 2 pi root m by k. K value is k only. So definitely I can say that the equation of time period remains to be 2 pi root m by k. Clear? This is the answer for first one. Now let us see how we can do the calculation for second question. This is the second question. Clear, Nama? So here let us assume that this mass has come down by a distance of x. So if this mass goes down by a distance of x, then what is the elongation produced in the spring? So here elongation produced in the spring will not be equal to x value. What is the reason? Because this string and this spring, they are different. Clear? And similarly here I have a movable pulley. So definitely I have to use the concept of constraint relations. So how can I use the concept of constraint relations? Let us see. So I can write xa plus xb is equals to 2xp. This is the relation already which we have derived in constraint relation concepts. So if you are not aware of these equations, you go to the playlist of constraint relations in this channel, then very beautiful concepts you can find in that constraint relation topics. So xa plus xb is equals to 2xb. So for this pulley, this is block A and this is block B. And block A displacement is 0 because it is fixed here. So therefore I will write 0 plus xb. Now what is the displacement of this mass? It is displaced by an x, no? This is our assumption. So I will write x is equals to 2 times of displacement of pulley. So pulley is displaced by x by 2. This is the relation. Clear, Nama? So pulley comes down by a displacement of x by 2. So if pulley comes down by displacement of x by 2, then spring also will have an elongation of x by 2 only, because spring and pulley, they are attached to each other. Clear, Nama? So therefore I have calculated what is the elongation which is produced in this spring. Clear? Okay. Now what about tensions? Let us distribute the tensions. Here if tension is T, here also tension will be T because this is the same string. So here tension are T and T, then here tension will be 2T. Why? Because this is a massless pulley, no? So therefore the tensions which are acting above this pulley and below this pulley, they should be equal. Clear, Nama? So therefore, now you write equation for spring. How can I write equation for spring? So I will write the equation restoring force is equals to minus k into x. So here what is the restoring force? Restoring force is 2t. So spring constant is k. And what is the elongation? Elongation is only x divided by 2. Clear, Nama? So therefore from this equation I can write t is equals to minus k by 4 into x. I can write like this. Clear? Now what is t? T is the restoring force acting on this mass. Similarly, x is the elongation produced in this mass. So again you compare this equation with the restoring force equation. Then I can understand here k value has become k by 4. K value has become k by 4. So for k by 4, if it is the k value, then I know equation for time period, no? T is equals to 2 pi root m by k. And what is k value here? K value is nothing but k by 4. So therefore T is equals to 2 pi root m by k. Instead of k I will write k by 4. Clear, ma? So this 2 and this 2, if they get multiplied, then I will get T is equals to 4 pi root m by k. So this is the relation which I will get. Are you able to understand, ma? So this is the equation for time period of this mass. Clear? Now let us see how we can proceed for the third question. For the third question also, we will proceed in the same manner how we have proceeded in first and second processes. Clear, ma? Let us see. So now we are doing calculation for case number 3. So here let us assume this block has gone down by a distance of x. Then definitely I can say that pulley also goes down by same distance of x only. Why? Because these two are attached to each other. Clear, ma? Then what is the elongation which is produced in this spring? Clear? So that spring elongation I can calculate by again using the constraint relations. So xa plus xb is equals to 2xp. Are you able to understand, ma? Now to this pulley, this is block A and this is block B. So this displacement is 0. And what is the displacement of block B? This is block B. Spring is nothing but block B. So I don't know. So let it be xb. So is equals to 2 times of elongation of the pulley. Pulley has gone down by x value. So therefore xb value is how much? 2x. It means that this spring will be elongated by 2x if this block goes down by a distance of x. That is the meaning of this one. Clear now? Now we have to distribute the tensions also, no? So here let us suppose the tension is T. Then here tension will be T by 2 and here also tension will be T by 2. Again same concept. Tensions above the pulley and below the pulley, they should be equal because this is a massless pulley. Are you able to understand, ma? Now write equation for spring. For spring, how can I write the equation? Let us see. Clear, ma? Restoring force is equals to minus k into x. Now, what is the restoring force produced in the spring? Restoring force is T by 2. So, therefore, T by 2 is equals to minus k into. Now, what is the restoring for displacement? Displacement is 2x. So, therefore, T is equals to minus 4k into x. Clear, ma? So, this can be written as minus 4k multiplied by x. Clear? Now, what is T? T is the tension which is acting on this mass, and what is x? X is the elongation produced in this mass. So that is mass has come down by a distance of x. So therefore, if I compare this equation for mass m, again if I compare this equation with restoring force, then I will see that k value has become 4k. So therefore, what is the equation for time period? It is 2 pi root m by k. And what is k value? K value is 4k. So this 2 and this 2, they will get cancelled. So therefore, the equation which I will get is T is equals to pi root m by k. So this is the relation. Are you able to understand, ma? So I hope you have understood the procedure in which we have done this calculation. Clear? So here a time period is 2 pi root m by k. Here a time period is 4 pi root m by k. Here it is a pi root m by k. Clear? Come on, make a note up to here. Now let us see this question. So this pulley, it has a moment of inertia of I, radius is r, initially block is in equilibrium. So if a block is slightly pulled and released, and if I consider that there is no slipping between this thread and this pulley, then find the time period of oscillation. So this type of problem we have done previously, but here we are supposed to calculate, we are supposed to consider the rotation of this pulley also, which is having a moment of inertia of I. Clear, ma? So let us see how we can do this problem. Clear? And previously, this what you call this mass is in equilibrium. So what is meant by equilibrium? So this block, it will be having its own weight, no? Weight will be how much? mg. But why it is in equilibrium? Because tension should have been balancing this mass. So T is also equal to mg. So same tension will be acting here also, and this tension is responsible for a bit of elongation, which is called as initial elongation in this spring. So therefore, I can say at equilibrium, initial elongation, let it be x. Clear, ma? Or x, not we will consider. So definitely one thing which I can say that mg is equals to restoring force which is developed in this spring, and this restoring force will be equal to kx naught. So let it be our equation number 1. Clear, ma? Up to here it is clear. Now when I pull this one and release, then what will happen? This mass, definitely it will perform simple harmonic motion. Clear? So if only masses are present, then what I can do? I can calculate a k value, and I can substitute T is equals to 2 pi root m by k, just how we have done in the previous problem, and calculate the time period. Clear, ma? But here, in addition to this mass, a pulley is also present. So therefore, what I will try to do, I will try to total calculate this equation, and I will try to get an equation in the form of A is equals to minus omega square into x. Clear, ma? Then that obtained equation, I will try to compare with this relation. Then I can calculate omega value. So once I calculate omega value, very easily I can calculate the time period, because we know T is equals to 2 pi divided by omega. Clear, ma? So let us see how we can do this calculation. So let us consider after a time of t, if I pull this system downwards. So let us assume this mass has come down by a distance of x, and here let its velocity be v. Clear, no, ma? So it has come down by a small distance of x, and let its velocity be v. Clear? Therefore, total energy at this position, how I can write? Let us see. Total energy, how I can write, and potential energy of this mass also we have to consider, no? And potential energy always depends on reference. Already we have studied this one. Clear, no? So without defining reference, you can never define potential energy. Clear? So from which reference shall I take? So shall I take potential energy from this reference? If I calculate potential energy from this reference, I can never do the problem, because this height, how much it is, I don't know. What is this height, I don't know. So what I do is, the initial position of this mass, this itself I will take as the reference. Clear, ma? So when mass was in equilibrium, that position I will take it as my reference. Clear, no, ma? Okay. Now, what about different energies? So therefore, what about the energy stored in the spring? When this mass comes down by a distance of x, so the total elongation in this spring will be x plus x naught, because previously there was an elongation of x naught, and now there is an additional elongation of x. So total potential energy stored in the spring will be this much. So half k into x plus x naught whole square. Clear ma? And this mass, it has come down by a small distance of x, no? It means it has lost some potential energy. Clear ma? So therefore, now lost potential energy is how much? Minus mg into x. Clear? Now, by this time, this body has gained some velocity. It means it gained some kinetic energy. And what is the equation of kinetic energy? Half mv square. Clear? So by this time, this pulley also has rotated by some angle and it has obtained some angular velocity. And that angular velocity has given some kinetic energy to this pulley. And what is that amount of kinetic energy? We can call it as rotational kinetic energy, half I into omega square. Clear ma? So this is the total final energy at this position. At which position? When mass has covered a distance of x and when its velocity is v. Clear ma? Okay. Now, so here I have half I omega square, and we know that v can be written as omega into r. So omega is equals to v divided by r. Clear ma? So by constraint relations, already we have studied these type of equations in rotational motion. So what is meant by v here? V is the tangential velocity of this pulley. Clear? And what about this v? This v is the velocity of the block. So if velocity of the block is v, velocity of the rope is also v. Similarly, tangential velocity of the block is also v only. Clear ma? So here v and vt both are equal. So if I substitute in this relation, then what is the equation for energy which I will get is this one. So the energy equation which I will get is, so half k into, so x plus x naught whole square, so minus mgx plus half mv square plus half into I into, instead of omega square what I can write v square divided by r square. This is the relation which I will write. Clear ma? And here I have half mv square. So this is half iv square divided by r square. So I will do one thing, I will take half mv square common from both of them so that we will get simplified calculations. So equation can be written like this also. So half k into, so x plus x naught whole square minus mgx. Now from both of them, if I take half mv square common, then I will get 1 plus, half is already gone, so I divided by mr square. I can write like this because m already it is taken, no, so I will get one more m in the denominator. Clear? So this is the equation up to which I got. Clear? So total energy of this system is always a constant. Why total energy is always a constant? Because here we are not applying any external forces. Are you able to understand? So therefore I can write total energy always remains a constant. So it also means that dE divided by dt is equal to 0. So what is meant by dE divided by dt is equal to 0? It means that change in energy with respect to time is 0. That is understandable, no? D means differential change in energy. Energy is a constant. So there is no change in energy with respect to time. So dE by dt will become 0. So if I had differentiated energy, then differentiate the other term also. So therefore we can write 0 is equals to half k into 2 into x plus x naught, and x is a variable, no? So I will write dx divided by dt. Clear ma? And here in mgx, mg is a constant, x is a variable. So minus mg into dx divided by dt. Clear ma? Similarly here half m 1 plus I by mr square, they are constant, but velocity is a variable. So therefore I will write half into m into 2v dv divided by dt. So total multiplied by 1 plus I by mr square. So this is the result up to which we got. Clear? Now let us simplify this one and let us see what we will get. 0 is equals to, what is this one ma? Half k into 2 na? Okay. So 2 and 2 gets cancelled. So kx plus kx naught multiplied by dx by dt is called velocity. Clear? So minus mg into again dx by dt is called as velocity. Clear? And here what I will have, here I have, so half into half and half gets cancelled. So I will write mv dv by dt is called acceleration multiplied by 1 plus I by mr square. So this is the relation which I got. Clear ma? So therefore if I observe in this relation, every term has the term v. So v gets cancelled because here I have 0. Clear? So therefore what is the relation I have now? And also mg and kx naught will get cancelled because in the initial conditions only we have written number. So mg and kx naught, they are equal in the balanced condition. Clear number? So therefore 0 is equals to kx. Now what are the terms we have? So plus m into a into 1 plus I by mr square. This is the relation which I have. Clear? Now let us try to convert that relation in terms of this relation. Okay. So if I try to convert, let us see what I will get. So therefore A into, so m plus I by r square is equals to minus kx. So therefore A is equals to minus k divided by m plus I by r square multiplied by x. Clear ma? So this is the relation which I got. Clear? Now you compare this equation with this equation. So very easily I can say that. So omega is equals to square root of k by m plus I by r square. Clear na ma? So where shall we write this one? We will write here. Okay. So let it be our equation number 2 and let it be our equation number 0, whatever it may be. Clear? So by comparing these two, I can write omega value is how much? Omega is equals to square root of k divided by m plus I by r square. And what is omega? Omega is nothing but 2 pi by capital T. 2 pi by capital T. So therefore what is T value? T value is 2 pi divided by omega. So 2 pi into square root of, so m plus I by r square divided by k. So that is our equation for time period of this mass. Okay. So I hope you have understood how we have done this calculation. Clear ma? So whatever we are doing, what we are trying to do, we are trying to convert this equation in terms of this equation, A is equal to minus omega square x. So that omega value I can compare with the equation which we got. Once we get omega value, very easily I can do the equation, easily I can calculate the equation for time period. Clear ma? So wherever energy is a constant, always we can use this relation. Okay, come on. Students, now let us see one more question of the previous model. So the pulley shown in figure has a moment of inertia of I about its central axis and has a mass of m. So find the time period of oscillation. So radius of the pulley is given as r and a string does not slip over this pulley. This is the given question. So in equilibrium, what I can say, in equilibrium, I can write like this. So in equilibrium condition, so this pulley, it has some mass number mg. So it will be supported by two tensions. So here one tension, so here another tension. So definitely I can write that mg is equal to 2t. Clear? Now what is T? T is the tension developed in this spring. So T is equals to kx naught. What is meant by kx naught? So the restoring force which is developed in this string is nothing but a T. So T is equals to k into x naught. Clear? Now if I substitute this relation here, then what I will get? I will get mg is equals to 2 into T. Instead of T, what I can write? I can write kx naught. So let it be our equation number 1. Are you able to understand ma? So initially when the system is in equilibrium, then weight of the body is equals to 2 times of k into x naught. Clear? So this is already understandable that mg and 2t should be balanced with each other. Okay? Okay. Now what I do is, so again to calculate in the same method how we have done previously, first of all we should select a reference of potential energy. So therefore the initial position itself, this I will take it as my reference for potential energy. Are you able to understand ma? So if I take this one as my potential energy, and if I pull this block, if I pull this pulley by a distance of x, clear, and release this one, then definitely I can say that this system will perform simple harmonic motion. Clear? But when the pulley is pulled down by a distance of x, what is the elongation which is produced in the spring? Spring will be elongated by 2x. What is the reason? So by constraint relations already we can study norma. So therefore I can write xa plus xb is equals to 2xp. This relation I can write. So for this pulley, this is block A and this is block B. So here xa value will become 0 because it doesn't move here. So 0 plus xb is equals to 2 times of elongation of the pulley. Pulley is elongated by x value norma. So therefore the elongation produced in the spring, that is xb, is how much? It is 2x. Clear? So therefore I will get xb, nothing but elongation of the elongation of this spring. This is equal to 2x. So let it be one more equation. Let it be our equation number 2. Clear? Now after elongation, so this block, this pulley should have some distance. This pulley should have some velocity. Similarly, it should have some angular velocity also. Why it will have some angular velocity? Because the reason here is that this string is not slipping over this pulley, but when this pulley is pulled downwards, pulley is actually rotating. Clear na? So definitely this pulley has 2 types of energy when it is at a position of x. It has a translational kinetic energy. Similarly, it has rotational kinetic energy also. Clear ma? So therefore, at an elongation is at a displacement of x, it should have obtained some velocity. So because of that, it will gain some translational kinetic energy. Clear ma? Similarly, here this pulley is not slipping. Actually, this is rotating. Clear, Nama? When I pull this one downwards, this string is not movable, no, only this string is movable. So therefore, this pulley will roll on this string. So because of that, it will give some rotational kinetic energy, and that is given by half I into omega square. Clear, Nama? Similarly, when it comes down by an x from this reference, it means it has lost some potential energy, and lost potential energy is minus mg into x. Clear, Ma? Similarly, when this pulley has come down by a distance of x, then the total elongation produced in this spring is x plus x naught plus 2x. Because already initially there is some elongation of x naught at equilibrium, and now when pulley has come down by a distance of x, this spring elongates by 2x. So total elongation is x naught plus 2x. So because of that, the total potential energy will be how much? So total potential energy stored in the spring is half k into x naught plus 2x whole square. Clear, ma? So this is the total amount of energy after a time of a particular displacement of x. Clear? Okay. Now here omega, I don't want omega, so omega can be written as v by r. So if I substitute this relation, E is equals to half mv square plus half into, instead of omega, what I can write? I can write v by r whole square minus mgx plus half k into x naught plus 2x whole square. This is the relation which I can write. Clear, Nama? So therefore, now what I will do, I will take half mv square common, it is better, so that I can simplify this calculation. So half mv square if I take common, then 1 plus half has already gone, v square also it is gone. So I by m r square is the equation which is really pending now. So minus mgx plus half k into x naught plus 2x whole square. This is the relation up to which we got. Clear, Nama? So already we have discussed that here there are no forces which are acting. All the forces are conservative forces only. So therefore, total energy is always a constant. If total energy is always a constant, then also I can write that dE by dt should be equal to 0. What is meant by dE by dt is equal to 0? Total change in energy per total change in time. Energy is not changing, it's just like how we have done in the previous calculation. So therefore, then you have to differentiate on the other side also. So therefore, I can write 0 is equals to, now half m is a constant, so half into m into 2v into dv divided by dt, because velocity is a constant, you know, and 1 plus I by mr square is a constant. So 1 plus I by mr square. Clear, Nama? So similarly, if I differentiate this one, mg is a constant, so minus mg into dx divided by dt. Clear, Ma? And here half k into 2 into x naught plus 2x. Then 2x is not a constant, so if I differentiate this one, I will get 2 dx divided by dt. So these are the equations which we will get on differentiation. Now let us try to simplify this one. So 0 is equals to, so 2 and 2 gets cancelled, so I can write, so mva into 1 plus I by mr square. Clear, Ma? So minus mg into v plus 2 and 2 gets cancelled, so k into x naught plus 2x multiplied by 2 dx by dt is called velocity. Clear, Nama? So here also I have velocity, here also velocity, here also I have velocity. So velocity and velocity terms will become 0. So therefore 0 is equals to ma into 1 plus I by mr square. Clear? So minus mg. Now if I can write this one, I can write 2k x naught plus 4k x. This is the relation which I get. Clear, Nama? So previously already we have written that mg is equals to 2k x naught. So cancel these two terms get cancelled. So therefore what is the relation I have? I have, so m into a into 1 plus I by mr square is equals to minus 4k into x. Clear? So I got relation up to here. Okay. Now further we will try to solve from here. Clear, Nama? So now let us see what we can write. So therefore I can write a is equals to minus 4k into x divided by, now what are the terms? I can write m plus I by r square. So this is the relation which I will get. Clear? Now try to compare this relation with a is equals to minus omega square into x. So definitely I can say that omega is equals to square root of, this is 4 Nama, this is 4k. Clear? So therefore omega will be equal to 4k divided by m plus I by r square. This is the relation which I will get. And omega is nothing but 2 pi by capital T. So therefore t will be equal to 2 pi into square root of m plus I by r square divided by 4k. Clear? So this is the equation for time period of this type of arrangement. Clear? Come on, make a note up to here. Dear students, now let us see this very important concept of oscillation of a two-particle system. Clear? So here, these are the two masses m1 and m2, which are connected by a spring. And the spring constant of this spring is k. And initially, this system is in compressed position. Clear, ma? So let the initial compression produced be, so let initial compression which is developed, let it be x. Clear, ma? So when compression is present, these bodies will experience restoring force in opposite direction. Clear? Because already we have studied, no? If compression is in one direction, restoring force will be in opposite direction. So these masses will experience restoring force in opposite direction. So definitely I can say both these masses will experience restoring force, because to apply restoring force on one body, we should have a support. And that support will be given by second body. It means both of them will experience same restoring force also. So how can I explain this one? Let us see. For example, this is a spring which is present at its main position, and this is mass m. Clear, ma? So if this mass, if I move by a distance of x, then what will happen? Spring also will be elongated by a distance of x only. Clear? So in this mass, it experiences a restoring force of kx in opposite in this direction. Similarly, this support to which this spring is connected, it also experiences same restoring force but in opposite direction. So same concept here also. So first mass as well as second mass, both of them, they will experience restoring forces in opposite direction, and the magnitude of restoring force will be equal. Clear, ma? So therefore, if initial compression is x naught, then what is the restoring force experienced by them? Restoring force experienced by each body will be equal to k into x. That's all, no? K into x. Both of them will experience same restoring force. Clear, ma? But if I write for mass m1, this is mass m1, no? So on this mass m1, this is the only force which is acting. Friction we are not considering here. So restoring force Fr is equals to k into x. That is the only force which is acting on mass m1. Clear, ma? So therefore I can write, so net force is equals to mass into acceleration is equals to restoring force is how much? Restoring force is k into x. Clear, ma? So therefore, what is the acceleration produced in the first body? A1 is equals to kx divided by m1. This is the acceleration produced in second body. Clear? First body. Similarly, if I write for mass m2, okay, ma? If I write for mass m2, then here also net force is how much? Net force is kx, which is equals to m2 into a2. Clear, no, ma? So therefore, acceleration will be how much? A2 is equals to, so kx divided by m2. Clear, ma? So this is the acceleration produced in second body. So accelerations are definitely not equal. Why accelerations are not equal? Because masses are different, no? Clear, ma? Because already we have studied that F is equals to mass into acceleration. Force is the same for both of them, but mass is different. So acceleration also will be different. So first body will have an acceleration of kx by m1. Second body will have an acceleration of kx divided by m2. So as accelerations are different, so the velocities obtained by these bodies after some time also will be different. Clear? For example, after a time of 1 second, velocity of this body will be different and velocity of this body will also be different. Clear, ma? Similarly, distance traveled by this body will be different and distance traveled by second body also will be different, because accelerations are different. Are you able to understand? So I hope you are able to understand up to here. Clear, ma? Then after some time, what will happen? This spring, it will go into relaxed position. Clear, ma? So when spring goes into relaxed position, then what will happen? The restoring forces experienced by both the bodies will become zero, because there is no elongation or there is no compression produced in the spring, no, ma? If there is no elongation and if there is no compression, definitely I can say the restoring force developed also will be zero. Clear? So therefore, after some time, so previously masses were present here, no, in the initial compressed position. So now what will happen? Now first mass, let us consider it is traveled by some distance up to here. So this is the position of first mass m1. And similarly, let us consider second body has traveled up to here, and let this mass, let it be m2. Clear ma? And this is how now the spring is connected. Clear? Now in this condition, the spring is in relaxed position. In relaxed position, the restoring forces experienced are 0. Clear? Now the question is, will they stop here, or again will they continue to move? That think about this one. So at the mean position, definitely compression produced is 0, but velocities are maximum, no? So again these bodies, they will continue to travel in the same direction, because already we have studied that at the mean position, so velocity of the body performing SHM will be maximum. Clear, Noma? So therefore, what will happen now? Let us draw the new diagram again. So previously this was the position at which bodies were present at the mean position. Clear, Nama? So from here, again this body will be displaced by a distance of x1, and second body will be displaced by a distance of x2. Clear? So I will draw this new diagram. So this is mass m1, and this is our mass m2. Clear? So bodies will move up to here. Now the spring is present in elongated position. Clear? Now what is the total elongation produced? Total elongation produced is x1 plus x2. Clear? So let us write that one. So now I will write here. Now the total elongation, produced in the spring is how much? It is equals to x1 plus x2. Clear, ma? So if total elongation is x1 plus x2, now can you say what is the restoring force experienced by mass m1? And again, what is the restoring force experienced by mass m1? Clear? So total elongation is x1 plus x2. So restoring force will be k into x1 plus x2. Clear? And this mass m1 also will experience same restoring force. Mass m2 also will experience the same restoring force. Clear, ma? So therefore what I can write? So therefore restoring force on mass m2, on mass m1 first of all we will write. So is equals to, restoring force is equals to k into x1 plus x2. Clear, no? So therefore restoring force k into x1 plus x2 is equals to net force. So this is equals to m1 into a1. Clear, no? So this a1 and this a2, they are not the same, they are different. So m1 into a1. So this is the acceleration produced by acceleration experienced by mass m1. Clear? So therefore what I can write? So therefore k into x1 plus x2 is equals to m1 into a1. So let it be our equation number 1. Clear? So after writing equation number 1, now let us go for the concept of center of mass. Clear, ma? So here external forces acting on this spring are 0. External forces are not acting. There are compression and elongation is happening only because of internal forces. So here definitely you can say external forces are absent. So let us write the statement. So here external forces are absent. Clear, ma? So when external forces are absent, then what can I say? I can say that the position of center of mass is never going to change. Clear, ma? Center of mass position will not change. Now already we have studied the equation of center of mass in center of mass concept. So let us write that one. I can write x center of mass is equals to m1 x1 dash plus m2 x2 dash divided by m1 plus m2. Clear, ma? m1 plus m2. So position of center of mass, it is not a change. Clear? So if I take my reference on the center of mass, definitely what I can write? Same relation I can write like this also. I can write delta x center of mass is equals to m1 delta x1 plus m2 delta x2 divided by m1 plus m2. What is delta x center of mass? That is the change in position of center of mass. External forces are absent, no? So change in center of mass will be 0. Center of mass remains to be at the same position. Clear? So therefore I can write, So this term will become 0. 0 is equals to m1 delta x1 dash plus m2 delta x2 dash. Clear, Noma? So from this what I can write? So m1 x1 is equals to, or I can write like this. So let us take this displacement as negative and let us take this displacement to be positive. Then what I can write? I can write 0 is equals to m1 into minus x1 plus m2 into x2. Totally it should be equal to 0. Clear? So I get equation up to here. Now let us see what we can do. So therefore what I can write? So m1 x1 is equals to m2 into x2. So therefore I want to substitute in this relation the relation of x2. So x2 is equals to m1 x1 divided by m2. Let it be my equation number 2. Clear? Now substituting equation number 2 in equation number 1. So what is equation number 1? So k into x1 plus x2 is equal to m1 into a1. Clear, ma? So if I substitute in this relation, now let us see what is the equation I will get. Clear? So therefore k into x1 plus, instead of x2 what I can write? I can write m1 x1 divided by m2 is equals to m1 into a1. This is the relation if I get. Clear? Now further I can take x1 common. If I take x1 common, then I will get m2 plus m1 divided by m2 is equals to m1 into a1. Clear? Now what I can do? So I want to write this total equation in the form of a is equals to minus omega square x. So I will write magnitude of a is equals to omega square into x. In this form I want to convert this relation. So therefore take this m1 also to the other side. Then I can write kx1 into m2 plus m1 divided by m1 m2. So this is the relation which I got. Clear, ma? So same equation how I can write? So a1 is equals to omega square into x. So k into m1 plus m2 divided by m1 plus m2 into x. So compare this relation with this relation. So therefore I can write omega square is equals to k into m1 plus m2 divided by, this is m1 m2. So m1 m2. Clear, no? So therefore omega is equals to square root of k into m1 plus m2 divided by m1 m2. Clear, no? Same relation I can write like this also, no? I can write k divided by m1 m2 divided by m1 plus m2. So relation can be written like this also. So we know omega is equals to square root of k divided by m. Clear, nama? So here instead of m what I got m1 m2 divided by m1 plus m2. And this m value I can call it as mu. Clear, nama? So what is mu here? Mu is called as reduced mass. Mu is called as reduced mass, which can be written as, so m1 m2 divided by m1 plus m2. So this concept is called as the concept of reduced mass. So therefore what is the reduced mass relation we got? m1 m2 divided by m1 plus m2. What is meant by reduced mass? It means that this total system will behave like a single mass whose mass is equals to m1 m2 divided by m1 plus m2. So are you able to understand, ma? So once I got this reduced mass, then very easily I can calculate the equation of time period. So what is the equation of time period I can write? So we know T is equals to 2 pi root m by k. Clear, ma? So T is equals to 2 pi root, and here instead of mass I can write reduced mass divided by k. So T is equals to 2 pi into square root of mu is how much? So m1 m2 divided by m1 plus m2 into k. Clear, ma? So this becomes our time period of oscillation. So this total system, it oscillates with a time period of this much. T is equals to 2 pi into square root of m1 m2 divided by m1 plus m2 into k. Clear? Come on, make a note up to here. Then we will study about acceleration also. Similarly, let us write the equation for maximum amplitude of first mass as well as what is the maximum amplitude of second mass. Clear ma? Now we are writing equation for amplitudes of the particle. Clear? So let total final expansion be x naught. Clear ma? So individual expansions or individual amplitudes, let it be a1 plus a2. So therefore amplitude of first particle plus amplitude of second particle, it should be equal to total elongation produced in the spring, which is called x naught. So let it be our equation number 1. Clear ma? So at the position of maximum elongation also, again the position of center of mass will not change, no? So just like how we have written previously what we derived m1 x1 is equals to m2 x2. Similarly here we will derive m1 a1 is equals to m2 into a2. So therefore what is a2? A2 is m1 a1 divided by m2. Take this equation and substitute here. So therefore I will get a1 plus, instead of a2 what I can write? So m1 a1 divided by m2 is equals to x naught. Clear ma? So if I take a1 common and if I take the LCM, then I will get m2 plus m1 divided by m2 is equals to x naught. So therefore this is a1. So a1 is equals to m2 x naught divided by m1 plus m2. Clear ma? And what is x naught here? X naught is the total final compression at the maximum compression of this spring. Clear ma? So this is our equation for a1. Similarly I can write equation for a2 also, no? So m1 x1 divided by m1 plus m2. So this will be the final what you called amplitudes if the final expansion produced is x naught in the total spring. Clear? So these equations are also important, so very easily we have calculated them. Okay, come on. Now let us see this question. So in this following system, if masses are slightly displaced and released, then find the time period of oscillation. Clear number? So if I see this first question, so this is nothing but a two particle system. So where two masses are connected by a spring whose spring constant, let it be k. Clear number? And we can neglect the friction between this small m and this capital M. So this is exactly similar to the theory part which we have studied just now. So therefore here I can definitely use the equation of time period. T is equals to T by root mu divided by K, where mu is called as reduced mass. Clear ma? And how much will be the reduced mass? Reduced mass will be equal to m1 m2 divided by m1 plus m2. So here what are the masses? Capital M into small m divided by capital M plus small m. So therefore if I substitute in this relation, T is equals to 2 pi into square root of capital M into small m divided by m plus m into k. Clear? So this will be the equation for time period of this system. Clear Dhamma? Now if I see the second body, here these two masses, they are connected by 4 springs here. So how can I calculate the equivalent k value of these springs? Let us see. Clear ma? So first of all, these two springs, they are connected in series. If springs are connected in series, similarly these two springs and these two springs also, they are connected in series. So in series connection, how I can calculate equivalent of series connection is equals to k1 k2 divided by k1 plus k2. This already we know. So therefore I can write, so k into k divided by k plus k is 2k. So it is k by 2. Clear ma? So for this combination it is k by 2. For second combination also it is k by 2. Now the equivalent diagram can be drawn like this, no? So this is mass m1 and this is mass m2. Clear? So both of them I can draw. So this is one spring, this is another spring. So k by 2, this is also k by 2. Clear? Now the two springs, they are in parallel. If two springs are in parallel, so what is the equivalent for parallel connection? It is equals to k1 plus k2 is equal to k by 2 plus k by 2, which is called as k. So it means that, so this total combination, it is equivalent to, so mass m1 and mass m2 connected by a single spring whose spring constant is k. Clear? So this is exactly the same situation which we have studied. So here also the concept of reduced mass will be So mu is equals to m1 m2 divided by m1 plus m2. So therefore again I can use the concept of reduced mass. So m1 m2 divided by m1 plus m2. So therefore T is equals to 2 pi root mu divided by K. So just substitute this mu value, that will be the equation for time period. Now let us see this question. So in the following system, the spring is compressed by 6 centimeters and it is released. Clear ma? So the spring constant of the spring is 800 Newton per meter, masses are 3 kg and 6 kg. Then first of all, we are supposed to find out time period. Second one is amplitude of 3 kg block. And similarly, what is the maximum momentum of 6 kg block. Clear ma? So let us see how we can do this calculation. So for first one, we are supposed to find out time period. So this is the concept of two particle system number. So definitely I can use the concept of reduced mass. So what is the concept of reduced mass? T is equals to T pi root mu divided by K. Clear? And what is mu value here? So mu value is equals to m1 m2 divided by m1 plus m2. So masses are 3 into 6 divided by 3 plus 6 is 9. So 3 1s are 3 3s are. So 2 is the reduced mass concept. So therefore T is equals to 2 pi into square root of 2 divided by K. K value is 800. So therefore T is equals to 2 pi into square root of 1 by 400. So therefore it is again equal to 2 pi divided by 20. So pi by 10 seconds. So this will be the time period of oscillation. Clear now? Now we are supposed to calculate the second one. So what is the amplitude of 3 kg block? Clear ma? So let us see how we can calculate the amplitude of 3 kg block. Clear? So previously we have calculated how we can calculate the amplitude of each block number. So for example, what he gave that compression produced is 6 centimeter. If compression produced is 6 centimeters, then what will be the elongation produced? Elongation produced also will be 6 centimeters only, no? So therefore I can write final elongation will be how much? Final elongation also will be 6 centimeters only, and let us call this as x0. Clear? Therefore, what is the amplitude of 3 kg block? Amplitude of 3 kg block will be equal to m2 x0 divided by m1 plus m2. So this equation already we have derived. Clear ma? So if this 3 kg body, if I take as m1, then what is m2? M2 is 6 kg. So 6 into x0 is 6 divided by 3 plus 6. 3 plus 6. So totally how much? So it is equals to 6 into 6 divided by 6 plus 3 is 9. Clear ma? So 6 6 are 36, no? So therefore 36 divided by 9 is equal to 4 centimeters. So this will be the amplitude of the 3 kg block. Clear ma? Similarly, we are supposed to find out maximum momentum of 6 kg body also. Clear? So first of all, make a note up to here. Then we will see how to calculate the momentum of 6 kg block. Okay ma? So already I have calculated this one. This was not recorded, so I am just explaining this one. So see. So maximum momentum. So at which position momentum will be maximum? Momentum will be maximum when velocity is maximum. Clear? And velocity will be maximum at the mean position. So already we have understood this one. So at relaxed position, velocities of blocks will be maximum. Clear? And here I will use the law of conservation of energy. So when spring is completely compressed, it has only potential energy. And what is the equation of potential energy? Half k x naught square. And at the relaxed position, that is when spring is in relaxed position, masses have velocities, and as the spring does not have any compression or elongation, potential energy is 0. Clear ma? So therefore, this is the energy at maximum compression, and these are the individual kinetic energies of the masses at the relaxed position. Clear no ma? So this I can also write by this equation of law of conservation of energy when only conservative forces are acting. When only conservative forces are acting, K1 plus U1 is equals to K2 plus U2. So at the compressed position, kinetic energy is 0 and potential energy is half k x naught square. At the relaxed position, Potential energy is 0. So kinetic energy is the kinetic energy of first mass as well as kinetic energy of second mass. So this is my equation number 1. So in this equation, how many unknown quantities I have? So K known quantity, X0 is a known quantity, M1, M2, they are known quantities. V1 and V2, they are the unknown quantities. Clear now? So if 2 unknown quantities are present, I require one more equation. And that one more equation I can calculate by the concept of center of mass. So what is the concept of center of mass here? So as external forces are acting, not acting on this system, so displacement of center of mass will be 0. So if displacement of center of mass is 0, velocity of center of mass is also 0. So velocity of center of mass, this is the relation. Clear ma? So velocity of center of mass as is it 0, so this total term will become 0. So therefore, velocity of one body is in one direction, velocity of another body is in opposite direction. So if I take velocity of 3 kg body to be negative, then velocity of 6 kg body will be positive. So I want velocity of this mass m2, that is 6 kg body. So I will write equation for v1. So v1 is equals to m2 v2 divided by m1. Take this equation, substitute in the first relation. Then I will get equation for v2. So v2 is equals to 0.4 meters per second. Are you able to understand ma? So once I calculate velocity, very easily I can calculate equation for maximum momentum. Because velocity is maximum, no? This is the velocity at the mean position. So as velocity is maximum, I can say momentum also will be maximum. So what is the maximum momentum? So momentum of 6 kg body is how much? It is equals to mass into V max, maximum velocity. Clear nama? So mass is 6 kg, velocity is 0.4. So 6 fours are 24. So 2.4 kg meters per second. So that is the maximum momentum of 6 kg body. 2.4 kg meters per second. Clear? Come on, make a note up to here. Dear students, now let us see the analysis of angular SHM. So previously we have done many concepts based on linear SHM. Now we are studying about angular SHM. So let us see what is meant by angular SHM. So Seema. So consider this is a pendulum which was in rest position. So are you able to understand? So initially pendulum was in rest position. Now this pendulum, I have taken this one to an angular amplitude of theta naught. Clear? So what is this theta naught? This theta naught I can call it as angular amplitude. So what is meant by angular amplitude? The maximum angular displacement of the particle from the mean position, that is called as angular amplitude. Clear? Now if I release this bob from here, then what will happen after some time? So definitely I can say that this bob, it will perform, it will start moving towards the mean position. So therefore after some time, this bob will reach somewhere up to here. So this is the new position of the bob, and it is traveling with a particular velocity. It is traveling with a particular angular velocity also. Clear? Now after reaching up to here, now the angle which it is making with respect to the vertical is theta. Clear? So theta naught is angular amplitude, and what is meant by theta? Theta is called as angular displacement of the particle. This is called as angular displacement. Clear ma? So therefore, when body has reached to a particular angular displacement of theta. Clear? Now, this is comparable with linear SHM also. No? So how I can compare this one with linear SHM? Let us see. So for example, consider a spring which is present in the mean position. So this is a spring which is initially present at the mean position. So let it be the mean position of the spring. Clear? Now from here, this spring I will elongate this one to a maximum amplitude of A. Clear? So what is this one? A. It means I am stretching this string up to this position, and from there I am leaving that spring. Clear Nova? Then what will happen? Then after some time, this spring will reach to a displacement of X. So it means that now the spring has reached to this position. Now it is at a displacement of again X from the mean position. Clear ma? So here A is called as amplitude, and this X is called as displacement of the spring from the mean position. So therefore this A can be compared with theta naught, and X can be compared with theta. So therefore what I can write? So this A, I can compare this one with theta naught. Similarly this X, I can compare this one with theta. So up to here we have tried to understand how we are comparing this angular SHM with linear SHM. Clear ma? Now what is the equation of simple harmonic motion of this spring? So equation of SHM is there, no? What is that equation of SHM? Equation of SHM is x is equals to a sin omega t plus pi. Clear, ma? Where pi is the initial phase constant. So x is equals to a sin omega t plus pi, where x is the position of the particle from the mean position, a is the maximum amplitude of the particle from the mean position, and here what is omega? Omega is the angular frequency with which this spring is oscillating. It means how many angular amplitudes or how many 360 degrees it is completing in 1 second, that is called as angular frequency. So here omega is called as angular frequency. Already we have studied them many times. Clear? And what is pi? Pi is called as epoch constant or initial phase constant, or just you can call it as initial phase also, or you can call it as EPOCH, epoch constant. Clear, ma? So same equation of linear motion I can use for angular SHM also. Now therefore, how can I write equation for angular SHM? I can write an equation like this. Instead of x, I will write a theta. So theta is equals to, instead of a, I will write a theta naught. So theta naught sine omega t plus pi. So similarly, I can write this relation. Are you able to understand, ma? It means that the equations of linear SHM and equations of angular SHM, they are analogous to each other. They are comparable to each other. Are you able to understand? Now here, what is meant by theta? Theta is the angle made by this particle at this displacement of x. So this arc traced by this path, I can call it as x. Clear, ma? So therefore, we know that, for example, if a body is moving in a circular path, so body has started from here and reached this position. So this length, we call it as length of the arc, which is called as L. Total length or radius of this circle is represented by r, and angular amplitude is represented by theta. Then what is the relation between theta, L and r? We know that theta is equals to L divided by r. Okay, ma? Similarly, if this distance is x, then the displacement of the maximum amplitude, this displacement I will call it as a. Then how can I write relation between theta, L and total length of the pendulum? Total length of the pendulum, let it be L. Okay. So therefore, how can I write relation? Theta is equals to L by r. So therefore, theta is equals to length of the arc here is x. So x divided by r. What is r? R is nothing but length of this simple pendulum L. So theta is equals to x divided by L. I can write like this. Similarly, for total angular amplitude theta naught, how I can write? I can write theta naught is equals to, and instead of x, the total length of the arc is a here. So a divided by L. So I can write relations like this. Clear, ma? So theta is equals to x by L, theta naught is equals to a divided by L, where capital L is the total length of this simple pendulum. Clear? So this theta I can substitute here, and this theta naught I can substitute here. Then also I can get one more equation for equation of the position of the body at a particular time of t. Are you able to understand? Okay. So therefore, the equation we have written the equation for angular displacement of the particle at any time of t. So theta is equals to theta naught sine omega t plus pi. This is the equation which we have written. Clear? Now this equation, if I differentiate this one with respect to time, so d theta divided by dt is equals to angular velocity. So I can write this one as angular velocity. Clear, ma? So angular velocity is also generally represented by omega also, omega only. But here already we have written omega. What is omega? Omega is called as angular frequency. So that is how many angular amplitudes this particle will complete in 1 second. But here this omega is different. This d theta by dt is what? This is the velocity of the particle. This is the angular velocity of the particle at a particular angle of theta. So this one I will represent by omega dash. Clear, ma? So omega dash is angular velocity of the particle at a particular time of t. And what is this omega? This is the angular frequency of this oscillation. It means how many 360 degrees or how many 2 pi radians it will complete in 1 second. That is called as omega. So don't be confused between this omega and angular velocity omega dash. So if I differentiate this one, what I will write? I will write the theta divided by dt is equals to omega dash is equals to theta naught. Differentiation of sin omega t plus pi is how much, ma? So it is equals to cos omega t plus pi multiplied by omega. Clear, ma? So therefore omega dash is equals to theta naught into omega cos omega t plus pi. Clear ma? In a linear SHM, what is the equation for velocity? In linear equation, V is equals to A omega cos omega t plus phi. This is the relation, no? Now you compare this angular velocity and this linear velocity. Both of them are exactly comparable. So here theta naught is comparable to angular amplitude. Clear ma? And angular frequency is angular frequency only. And remaining equation remains the same. Clear? So it means that the equation of linear SHM and angular SHM, they are always comparable with each other. Are you able to understand? So now I got equation for angular velocity. Now what I will do is again differentiating this one with respect to time. So again differentiating with respect to time. Already we have differentiated one time with respect to time. No, second time also we are differentiating. Then what is the relation I will get? I will get d square theta divided by dt square. And what is meant by d square theta divided by dt square, or also I can write it this one as d omega by dt. So d omega d by dt is what? It is alpha. What is this alpha called as? This is called as angular acceleration of the particle. Clear ma? Angular acceleration of the particle is called as alpha. Clear? So if I do this calculation, let us see what is the result I will get. Clear? So therefore, differentiating omega with respect to time, then I will get equation for alpha. So what is the equation I will get? So here I have theta naught into omega, which is a constant. So I will write theta naught into omega, and differentiation of cos omega t plus pi is how much? So it is minus sine omega t plus pi again multiplied by omega, because we have differentiated only cos theta. Theta we have not differentiated. So differentiation of omega t plus pi is equals to omega, where pi is a constant. Clear? So therefore alpha is equals to what I got? I will get minus theta naught into omega square sine omega t plus pi. Clear ma? So theta naught into sine omega pi. So theta naught into sine omega t plus pi, it is nothing but theta. So therefore alpha I can write minus omega square into theta. This is the relation which we have. Clear ma? Now comparing this relation with the equation of acceleration of linear SHM, then what is the equation I will get? So equation of linear SHM is A is equals to minus A omega square sine omega t plus pi. Clear? So exactly this equation, they are analogous to each other. So here theta naught is A and omega square is omega only. So alpha can be written as A. So it means that again the equations of linear SHM and angular SHM, they are always comparable with each other. Are you able to understand ma? Similarly, same equation of A can be written as minus omega square x also. So A is equals to minus omega square into x also. So again theta, just it is comparable to x in this condition. Okay ma? So these are the different equations of angular SHM, and these equations of angular SHM, they are always comparable with the equations of linear SHM. Are you able to understand? Okay. So similarly, we have one more equation for velocity also, no? Okay. So another equation for velocity. Another equation for velocity. Clear ma? So what is the one more equation for velocity we have? One equation which we have is this one. So omega dash is equals to theta naught into omega cos omega t plus pi. Clear ma? So which is comparable with linear SHM as V is equals to A omega cos omega t plus pi. Clear? So one more equation of velocity in linear SHM is V is equals to omega into square root of A square minus x square. Clear? Now definitely can I write an analogous equation of this equation of linear SHM in angular SHM also or not? So definitely I can write. So how I can write? I can write omega dash is equals to omega into square root of, instead of A I will write theta naught square, and instead of x I will write theta square. Clear ma? So this is one more equation for angular velocity of the particle at a particular angle of theta. Are you able to understand? So why we are writing two equations? This is the equation of angular velocity at a particular time of t. Clear? Similarly, this is an equation of angular velocity at a particular angle of theta. So that is why we have derived the equations in linear SHM also, no? So this is the velocity of the particle at a particular time of t, and this is the velocity of a particle at a particular displacement of x. Clear? Similarly, how can I write equation for maximum velocity? V max. Maximum velocity, how I can write? So a particle performing angular SHM, it will have maximum amplitude at the mean position. So this is understandable. Similarly, particle which is performing linear SHM also, it will have maximum velocity at the mean position only. So therefore, at the mean position, what is x value? 0. Similarly, at the mean position, what is the theta value? It is also 0. So therefore, maximum velocity omega dash is equals to omega into square root of theta naught square plus theta square, where theta value is 0. Clear ma? So therefore what is the relation I got? I got omega dash is equals to omega into theta naught. Clear ma? So this is just comparable with maximum velocity in the case of linear SHM is equals to A into omega. Clear? Where is A is called maximum angular amplitude, which is comparable with theta naught, and omega is the angular frequency. Are you able to understand? So at every position we are trying to compare the equations of linear SHM and angular SHM just to prove that all these equations are exactly analogous to each other. Are you able to understand ma? Come on. Make a note up to here. So then similarly we can write equations for maximum acceleration also, no? Clear? So equations of angular acceleration is how much? Alpha is equals to minus omega square into theta. So definitely I can write here alpha is directly proportional to theta, no? So therefore is theta is maximum, alpha also will be maximum. So maximum angular acceleration, how I can write? I can write minus omega square into theta naught. This is how I can write the relation. Clear ma? So this is just analogous to the equations in linear SHM. So A max is equals to minus omega square into A. So in angular SHM it is theta naught, in linear SHM it is A. Clear? So here also the equations are analogous to each other. Clear ma? Okay. Now we will study about time period, how to derive equation for time period of this angular SHM. Clear ma? In linear SHM, restoring force is how much? Restoring force is minus k into x. This already we have studied. So when spring is elongated by a distance of x, then what is the amount of restoring force that will be developed in the spring? Restoring force is equals to minus k into x. Clear? Similarly, same equation how I can write in angular SHM. In angular SHM, instead of restoring force, I will study about restoring torque, because this is angular motion, no? So force is analogous to torque in angular motion. So therefore what I will write? I will write, instead of restoring force, I will write restoring torque is equals to minus k into, instead of x I can write theta, because x is linear displacement, theta is angular displacement. So this is first equation. And this torque produced can also be written as I into alpha also, no? So let it be equation number 1 and let it be equation number 2. So definitely I can say equation number 1 is equals to equation number 2. So therefore I into alpha can be written as minus k into theta. This is one relation. Clear ma? So therefore alpha is how much? Alpha value is equals to minus k by I into theta. This relation is comparable with A is equals to minus omega square into x. Clear? So therefore if I compare both of these relations, this is the basic equation of SHM. A is equals to minus omega square x, or I can write d square x by dt square is equals to minus omega square x, or I can write d square x by dt square plus omega square x is equals to 0. This is the basic equation of SHM, no ma? So whatever equation, if it is present of this form, definitely it should be a simple harmonic motion. So therefore A is equals to minus omega square x. Comparing with these two relations, definitely I can write omega is equals to square root of k divided by I, or I can write k is equals to I into omega square. Now what is the equation for time period? Time period is equals to 2 pi divided by omega. So therefore time period is equals to 2 pi root I divided by k. Clear ma? So these are the equations for time period of angular SHM, where I is moment of inertia of the particle. Clear ma? So for an angular SHM, time period is dependent on this relation. T is equals to 2 pi root I by k. Okay. So definitely I can say that time period, it is depending upon the moment of inertia of the particle. So actually in linear SHM, T is equals to 2 pi root m by k. So there time period depends upon mass of the particle. But mass is comparable to moment of inertia in angular SHM. So definitely I got the same relation. So T is equals to 2 pi root I divided by k. Clear ma? Come on, make a note up to here. Then we will study equations for energy also. Okay. So let us see how we can write equations for energy. Okay. So energy of particle in angular SHM. Okay ma? So let us see. So energy of particle in angular SHM. Clear? Okay. So how can I write equation for potential energy initially? In linear SHM I can write half k x square, no ma? For example, if a spring is displaced by a distance of x, then potential energy, the work which we have done, that will be stored as potential energy inside the spring. And how much potential energy will be stored? Half kx square, where x is the displacement, linear displacement of the particle. And how can I write an analogous equation of this linear SHM in terms of angular SHM? I can write like this. So potential energy is equals to half k into theta square. I can write like this. Clear, ma? Now what is k? K just now we have calculated, no? I into omega square. So therefore, instead of k, I can write half I omega square into theta square. Let it be our equation number 1. Similarly, how I can write equation for kinetic energy? Half mv square. This is the equation of kinetic energy in linear SHM. In angular SHM, how can I write an analogous relation? I can write like this. I can write half I into omega dash square. And what is omega dash? Omega dash is angular velocity of the particle at a particular theta or at a particular time of t. Clear, ma? So therefore, omega dash, already we have written a relation previously. What is omega dash? It is equals to omega into square root of theta naught square minus theta square. This was the equation which we have written, no, ma? So just substitute in this relation. So therefore, kinetic energy is equals to half into I into, so omega square into theta naught square minus theta square. This is the relation which we get. Now, if I let it be our equation number 2. Now I want equation for total energy. What is total energy? Sum of potential energy plus kinetic energy. Sum of mechanical energy is called as total energy of the particle. So potential energy is how much? Half I omega square into theta square, and kinetic energy is how much? Half I omega square into theta naught square minus theta square. Clear, ma? So if I add both of them, I will get half I omega square into theta naught square. So this is the total energy of the particle performing angular SH. Clear? Now let us try to compare this total energy equation with the equation of total energy in linear SHM. In linear SHM, what is the equation for total energy? I can write half m omega square into a square. This is the relation, no, ma? Now compare both of them and see if they are analogous or not. See here. So I is analogous to omega. Clear? Omega remains omega only, and theta. I is analogous to mass. Omega remains to be omega, and angular amplitude is analogous to the linear amplitude. So here also total energy of the particle is also an analogous term. Are you able to understand, ma? Similarly, in the case of angular SHM, how can I write the same relation? This relation, basic equation of SHM, how I can write? I can write d square theta divided by dt square plus omega square into theta should be equal to 0. Clear? So these are the different equations which we have in the angular SHM of a particle. And all these equations of angular SHM, they are always comparable with the equations of linear SHM. Clear, ma? Come on. Make a note up to here. Okay. So next one which we are studying is oscillation of a simple pendulum. Ma? See, ma, here, if I disturb this bob which is present here, then what this bob will do? This bob starts performing oscillations. Okay, ma? But if angle of oscillation, if theta, for example, if pendulum is present here, this angle I can call it as theta, no? So if this angle of oscillation is less than or equal to 5 degrees, then these oscillations will be simple harmonic. Are you able to understand, ma? So in pendulum, this is one condition which you should remember. For not every angle, pendulum doesn't behave like a performing simple harmonic motion. It means this angle should be very small, less than 5 degrees. Then I can call it as simple harmonic motion. Otherwise, it is an oscillatory motion, but it doesn't have the properties of simple harmonic motion. Clear, no? Now let us see. So for example, if this is a pendulum which is present at an angle of theta and it is returning back from here, okay, then weight of this pendulum mg will be acting downwards, no, ma? Weight will be acting downwards, and pendulum length is L, and it is rotating about this axis of rotation. It is performing circular motion, vertical cycle, about which axis? It is performing simple what you call circular motion or vertical circle about this axis only, no? Din chutte kada rotate avutundi. So this becomes my axis of rotation. Okay, ma? Axis of rotation. Okay. So therefore, if this angle is theta, this mg also I can split into two components, no, ma? Clear? This angle is also theta. So this is mg sin theta, and this will become mg cos theta. Are you able to understand? So what is mg cos theta doing? What is the function of mg cos theta? Mg cos theta is increasing the tension in the string. It is pulling the bob in this direction, no? It means it is pulling the string. If I pull the string, what happens to the tension in the string? Tension increases. So tension is responsible, or mg cos theta is responsible for increasing in the tension of the string. But what is mg sin theta doing? Mg sin theta is the force which is pulling this bob in this direction. Thus is mg sin theta is responsible for pulling the bob towards the mean position. Mean position will be somewhere here, no? Clear, no? So mg sin theta is pulling the bob towards the mean position. So it means mg sin theta is the restoring force. Clear, no? So if this is mg sin theta, this is also mg sin theta. Clear? So therefore I say mg sin theta provides restoring force. Clear? Are you able to understand? Because this is the force which is responsible for pulling the bob towards the mean position. Mean position వైపుకు లాగడానికి ఇదే కదా హెల్ప్ అవుతున్నది. క్లియర్? So therefore I say restoring force is nothing but mg sin theta. Okay? And I can write it is equals to mg into theta also. Why I can write mg is equal to theta, sin theta is equal to theta also? Because theta values we are taking very small values, no? Very small. For very small values, sin theta and theta magnitude wise they will be equal. Okay? If values are very, very, very less, sin theta and theta numerically they will be almost the same. So instead of sin theta I can take theta also. So almost equal. That is the symbol. Are you able to understand? So therefore, now how much torque is provided by this mg sin theta? Torque formula. R into F, torque formula is what? Torque formula is R into F into sin theta. And the angle between this is the radius vector, no? Radius vector is nothing but L here. Pendulum is rotating about this axis, no? Clear, no? And this mg sin theta is responsible for making this body to rotate around this axis only. Okay? So what is the perpendicular distance of the mass to this force? Perpendicular distance is nothing but L only, no? And force is mg sin theta. So here theta value is how much? Here theta value is 90 degrees. Clear, no? This angle is theta. Angle between radius vector and force is called theta. Radius vector is L, no? What is the perpendicular distance from the axis of rotation? L. Clear, no? And what is the force which is responsible for pulling the body backwards? Mg sin theta. So this is radius vector, this is the force. This you can call it as R, this you can call it as F. So angle between R and F, theta, 90 degrees. So therefore I will write R into F into sin 90 value is 1. Okay, ma? So therefore what is the torque which is acting on this body, ma? R into F. R is L. F is nothing but restoring force, no? Restoring force is how much? Mg into theta. Okay. So this is the amount of torque which is responsible for rotating this body. Torque, effect of rotation only, no? That force which is responsible for making the body to move in a circular path is called as torque. Clear? Okay. So there is one more equation for torque, mama. What is that? Previously we studied in rotational motion. There is one more equation for torque. See, F is equal to ma. We know this relation, no? Newton's second. And what is the Newton's second law in rotational motion? Newton's second law in rotational motion is instead of force I have to write a torque. Instead of mass I have to write moment of inertia. Instead of acceleration I have to write alpha. This is the analogous equation of ఎప్పుడో చదివినాము సార్ మనం గుర్తుందా? షార్ట్ టర్మ్లో చదివినాం. క్లియర్ నమ్మా? F is equal to ma. So this is Newton's second law. Analogous equation of Newton's second law in rotational motion is torque is equal to I into alpha. So here also we got one torque, no? Here also we got one torque, no? So equate both of them. Clear? So 1 is equal to 2. So this is my first equation and this is my second equation. Equate both of them. So therefore I into alpha is equals to mg theta into L. Clear, no? So therefore what is alpha value? Alpha value is mg theta multiplied by L divided by I. So that is the angular acceleration which I got. Understood, Nama? Okay. Now, what is meant by I? I means what? Moment of inertia. And for this pendulum, can you say what is the moment of inertia? M? Moment of inertia formula. M? ml square. mr square. This bob is a point mass only, no? And for about this axis of rotation, length is L or R. Okay? Moment of inertia for a point mass, mr square. Here radius is L, no? So mr square or ml square. So therefore I will write alpha is equals to mg theta into L divided by moment of inertia is ml square. Clear, no? So what are the terms which get cancelled? Mass and mass, square and L will get cancelled. So therefore alpha value, how much I got, ma? So it is g by L multiplied by theta. So this is the alpha value which I got. Okay? It means that this much amount of angular acceleration will be produced by this mg sin theta. Fine, no? Okay. Now why we have derived this one? Why we have derived this one? Because I want to compare this one with the defining equation of SHM. What are the defining equations of SHM? Fr is equal to minus k into x. This is one defining equation. Clear, no? A is equals to minus omega x, omega square x. This is one defining equation. D square x by dt square plus omega square x is equal to 0. This is another defining equation for SH. Clear, no? So now I want to compare this one with this equation. Okay? Sima, listen very carefully. So A is equals to minus omega square x, or just you can write magnitude of A is equal to omega square x. So this is the equation of SHM, or acceleration produced in the case of SHM for linear motion. This is for which motion? This is for linear motion. For angular motion, I will write alpha is equals to omega square into theta. A, alpha, omega, omega only, x, theta. Clear, no? So this is in which motion? This is in angular motion. It means same defining property I can convert into angular motion, and I can write the equation like this. Ante kada. A badalu alpha, omega, omega ane untundi. X ante displacement, theta ante angular displacement. Clear, no? Now you compare this equation which I got in SHM of simple pendulum with this equation. Okay? Then I will get alpha is equals to g by L into theta. Okay, ma? Now what is omega value? If you compare these two, what is omega value? Omega value is equals to root g by L. Okay? Once I get omega, we know it is 2 pi by capital T, no ma? Clear, no? So therefore what is, I will write here, ma? Clear, no? So therefore omega is equals to 2 pi by T. So therefore T value is how much? 2 pi divided by omega. So 2 pi divided by omega value is how much? Root g by L. So therefore 2 pi root L by g. So this is the equation for time period of a simple pendulum. 2 pi root L divided by g. Understood, no? Okay. So for IPE students, I think derivation is also important. But for other students, you should understand the process in which we have done. Okay? Which forces are providing which acceleration, and how we are able to compare this one with the defining equation of SHM. Then finally I got the answer. Okay? Sima, whatever may be the type of motion in SHM, always you try to derive this kind of equations. You try to derive the acceleration produced in them. Because once you know the acceleration, you can compare with a general equation. In linear motion, you can compare with A is equal to omega square into x. In angular motion, you can compare with alpha is equals to omega square into theta. Once you know omega, very easily you can calculate time period. So this is the method of finding time period for any kind of motion. Always you find either A value or alpha value. అర్థమవుతుంది కదా? Equation of oscillation, time period of oscillation ma 2 pi root L by g, where L is called the length of the pendulum, g is called as acceleration due to gravity. And here also time period is independent of amplitude of oscillation. ఎంత దూరం నుంచి రిలీజ్ చేశాము అనేది డిపెండ్ అవ్వదు. ఇట్ ఓన్లీ డిపెండ్స్ ఆన్ లెంత్ ఆఫ్ ద పెండులం అండ్ g of that particular planet. Okay, for example, if I take the same pendulum to moon, ఇదే పెండులంని చంద్రమండలం పైకి తీసుకొని పోయినాను అనుకోండి, టైం పీరియడ్ విల్ ఇట్ ఇంక్రీజ్ ఆర్ డిక్రీజ్? Same pendulum, if I take to the surface of the moon, time period, will it increase or decrease? Change avadu asalu. Will it change or not? Change. G value increases or decreases? G value of Earth is how much? 9.8 only. G value of moon is how much? 1.67 only. 1.67 meters per second square. Very small. 1/6 that of Earth. Earth G value lo 1/6 ఉంటుంది. So denominator will be very, very, very small number. If denominator is very small, total value very large. It means time period is very large. So do you know how pendulum oscillates? Pendulum oscillates like this, slowly coming to the main position, then slowly going to the extreme position. Understood, no? Because time period increases many times, so automatically pendulum oscillates very slowly. Understood, no? That's it. So therefore time period of pendulum depends on only L value and G value, effective G value. Clear? Right up. Calculated number, it is T is equals to 2 pi root L by G effective. Effective acceleration. Are you able to understand? What is meant by effective acceleration? Let us see. First condition, pendulum if it is accelerating upwards. What is the meaning of this one? So consider this is a lift. In this lift there is a pendulum and lift is accelerating upwards. Are you able to understand? Are you able to understand? Lift is accelerating in upward direction. Then here G effective value will become G plus A. Acceleration due to gravity plus acceleration of the lift. Are you able to understand? Why it is like this? For example, if you take a body of mass m, so tension is acting in upward direction, weight mg is acting in downwards direction. So if body is accelerating in upward direction, definitely I can write T will be greater than mg, no? Ante kada? If body is accelerating in upward direction, upward force should be greater than downward force. So T should be greater than mg. Then how can I write the net force? T minus mg becomes net force, no? And net force formula? Mass into acceleration. So therefore what is the tension? It is m into G plus A. Actually when body is in rest position, T will be equal to mg, no ma? When this mass is in rest position, tension and mg they must be equal. But when body is accelerating in upward direction, effective G value has become G plus A, no? Clear, no ma? So that is why in the case of pendulum also, when pendulum is accelerating in upward direction, G effective will become how much? G plus A. So therefore what will be the equation for a time period of oscillation? T is equals to 2 pi root L by G plus E. So this is the effective acceleration due to gravity. Understood, no? Similarly, what is the next case? Accelerating downwards. So pendulum is present inside a lift and the lift is accelerating downwards. So in this condition what can be the equation? Come on. T is equals to 2 pi root L by G minus E. This will become the effective acceleration. Understood, Nama? Again same condition. With the help of Newton's laws you can derive this one. Derivations we are not doing. Just remember this one. When it is accelerating in upward direction, effective G value G plus A. Accelerating downwards, effective G value is G minus A. Now next case, when pendulum is accelerating horizontally. What is meant by pendulum is accelerating horizontally? Clear, ma? So this is a car, ma. In this car this is the pendulum which is present. Okay, and the car is accelerating with an acceleration of A. Then for an observer who stand and observe from here, we have to draw one pseudo force also, no? Pseudo force also we have to draw, no? Observer is present inside the accelerating frame. If observer is present inside the accelerating frame, Newton's laws we cannot apply. We cannot apply Newton's laws, no? But to apply Newton's laws, what we have to do? We have to apply pseudo force. Okay. So therefore, this pendulum, it takes an angle of theta if car accelerates. Already we have done some problems also in Newton's laws. Clear, no? G value is always downwards towards the center of Earth, but the pseudo acceleration is in this direction. So therefore, what is the resultant acceleration? Resultant A resultant is how much ma? So resultant acceleration will be equal to square root of A square plus G square. Okay, and this is the G effective acceleration. Understood no? This is how I take the resultant no ma? Parallelogram rule of addition. Clear no? Two vectors are joined tail to tail. So just duplicate the vectors, then this is how I can calculate AR. If this is A, this is also A only no ma? So this is a right angle triangle. So AR is equals to square root of A square plus G square, and this is the effective G value. Okay, so again in the formula, this formula we have to use. And here what is the effective G value? Square root of A square plus G square. Fine no? అర్థమవుతున్నాయి కదా ఎలా చూస్తున్నాం? Clear? Similarly, pendulum accelerating down an inclined plane. Now pendulum, it is not horizontal, it is not vertical, it is not coming downwards, it is present on an inclined plane. Inclined plane means what? So like this. Clear now? So here there is a car, and in this car there is a pendulum. Understood no? Now what about the effective G value of this one? So this derivation is there, we are not going towards the derivation. So just write down the formula. So T is equals to 2 pi root L by G cos theta. This is the formula. Understood no? So these are some of the formulas which can be asked in the case of simple pendulum, depending on effective G value. Fine? Okay. See ma. So these are the remaining cases ma. Case number 5. So pendulum oscillating in a liquid of density rho L. Okay ma. So density of this liquid is rho L, water, kerosene, whatever it may be. Now it should perform simple harmonic motions in this water. Clear no? See my weight of this bob, mg will be acting in downwards direction no? And water will give certain force of buoyancy also. In fluid mechanics we will study this. Liquid will give a force of buoyancy. And what is the formula for force of buoyancy? It is equals to rho L VLG. Okay ma? Rho L is the density of liquid, VL is the volume of this bob or volume of the liquid displaced also. G is the acceleration due to gravity. So therefore effective G value will definitely change, you know, because G value is acting downwards, but force of buoyancy is acting in upwards direction. So effective G value will definitely change. And here also we are not going towards the derivation. I am writing the equation. T is equals to 2 pi root, so L by G into 1 minus rho by rho L. So this is the formula. Clear ma? So what is meant by rho here? Rho is the density of the bob. So right now, rho is nothing but density of bob, BOB. And rho L already we have written down density of liquid in which this pendulum is performing as such. Clear no? So this is another important formula which sometimes can be asked in the examination. Clear no? So then case number 6. Case number 6 is body released through the center of earth. So we are making a hole from the center of earth and we are releasing a body. So it means this one will become diameter of earth. No? So we are releasing one stone to the diameter. Therefore here the time is equals to 2 pi root R by G. Clear no? Where R is called as radius of earth or radius of any planet. Okay. And now in the case number 7, we are not releasing the body through the diameter, no? But we are releasing through some chord. What is meant by chord? The length which is less than diameter is called as chord of a circle. So here also the time period will be again 2 pi root R by G only. Okay. Here also formula remains the same. So even when you release the body through the diameter, 2 pi root R by G. Even when you release through the chord also it remains same. T is equals to 2 pi root R by G. So these are some of the cases in the case of oscillations in the case of simple harmonic motion. Understood no? That's it. మళ్ళీ ఇంకోసారి వినండి. క్లియర్? So what is meant by physical pendulum? Any body which can perform SHM is called as a physical pendulum. Clear no? So when weight is acting here, when body is arranged like this, then there is no restoring force. In this condition I can say restoring force is 0. Clear no? But if I take this angle by a small angle of theta, then this weight mg I can split into two components, mg cos theta and mg sin theta. So this mg sin theta is responsible for providing the restoring force. Understood, Nama? So therefore I can say restoring force is provided by whom here? Restoring force is provided by mg sin theta. Are you able to understand that? And mg sin theta will act at the center of mass of the body. No, this is the position of center of mass. Okay. So therefore mg sin theta is providing how much amount of torque? Can you see? Restoring torque produced by this mg sin theta is how much? This is the position of center of mass. Huh? How much will be the restoring force? Huh? So restoring torque formula F into R only, no? Theta is already 90 degrees, F into R. So what is the restoring force? Restoring force is mg sin theta. Okay? And R means perpendicular distance from the axis of rotation, no? Which is the axis of rotation? This one. So force is applied at what angle, at what position? This position. What is this distance? This distance we have already assumed to be small l. Clear, no? So substitute here, multiplied by small l. L is the distance between point of application of restoring force and the axis of rotation. Clear, no? And here also, let us take sin theta is very small. Sin theta is very small, such that sin theta is almost equal to theta. Understood, no? Therefore, what I can write mg into theta multiplied by L is equals to torque produced, and torque is also equal to I into alpha also, no? Torque I into alpha also. So therefore, what is alpha value which I got? So therefore, alpha value which I got is mgl theta divided by I. Clear, no? So this is the angular acceleration which is produced. And I don't know moment of inertia of this body, no? Because this body can be any body. If it is a rod, its moment of inertia will be different. If it is a disc, its moment of inertia will be different. Clear, no? So I cannot substitute I value here. But what I can do, I can compare with this one with alpha is equals to omega square into theta. The defining equation of SHM in angular motion is equal to omega square into theta. Therefore, what is omega square? Omega square is mgl divided by I. So therefore, what is omega? Root mgl divided by I. Clear, no? So omega is nothing but 2 pi by capital T. So therefore, what is T, ma? T is equals to how much? 2 pi by omega. So 2 pi root I by mgl. Clear, no? So this is the equation for time period of any physical pendulum. Okay? Any pendulum. Any body. This is the equation. 2 pi root I by mgl. Understood, no? So if I ask you one question based on this one, try to answer it. Clear? Completed, no, this one? So this is a uniform rod, ma. Length of the rod is L, mass of the rod is capital M. And where is the axis of rotation? Axis of rotation is not present at the end of the rod. It is present at a distance of L by 4 from the end of the rod. Clear now? Then if I disturb this one, then this also starts performing simple harmonic motion, no? It starts performing about the axis of rotation. Okay. Here what is the formula for SHM? Time period of SHM already we have calculated, no? So 2 pi root I divided by mgl. This is what we have studied, no? I by mgl. Now the question is mass I know, G value I know, L and I values I have to calculate. Where will be the position of center of mass, no? Center of mass will be exactly at the geometrical center, no? Clear, no? It will be somewhere here. This is the position of center of mass. So therefore, if this distance is L by 4, this distance also will be L by 4 only, because center of mass will be exactly at the middle. And here total weight of the body appears to be concentrated. Total mass and total weight appears to be concentrated at that position. Okay. Therefore, what is small l? Small l is the distance between center of mass and this axis of rotation, no? So what is this distance? Capital L divided by 4. One value we have calculated. Now let us calculate moment of inertia. Okay, ma? Moment of inertia of this rod I am supposed to calculate. Okay, ma? See, ma, when axis is present at the center, then what is the formula for moment of inertia of a uniform rod? ml square divided by 12. This is the equation. Clear, no? But axis, is it present at the center? No, it is present somewhere at a distance of L by 4. Clear, no? So therefore, if this is the rod, so center of mass is here, but axis of rotation is here. Okay. So about this axis, I know the moment of inertia, ml square by 2. But about this axis, I want moment of inertia. No? So these two axes, how they are they parallel to each other? This axis and this axis, they are parallel to each other. No? Therefore, use parallel axis theorem. What is parallel axis theorem? Parallel axis theorem. Okay, ma? Parallel axis theorem says that I is equals to I center of mass plus md square. This is parallel axis theorem. No? I center of mass plus md square. I center of mass. At the center of mass, what is the moment of inertia? ml square by 12. So ml square divided by 12 plus m. D means what? Distance between both the axes. What is the distance between both axes? L by 4. So L by 4 whole square. Okay. So if you do this calculation, you will get I value. Once you get I value, you substitute in this relation, you will get the total time of oscillation. That's it. Understood now? So therefore, ml square divided by 12 plus ml square divided by 16. What is the LCM of 12 and 16 ma? 16 2s are 32, 16 3s are 48. 16 3s are how much ma? 32? 48 element. So 12 4s are 48. So I can take 48. So 12 4s are 4 ml square plus 16 3s are 3 ml square. Clear no? So total how much? 7 ml square divided by 48. So this is the moment of inertia of this rod. Okay? So take this moment of inertia and substitute here. So therefore T is equals to 2 pi root. Moment of inertia is 7 ml square divided by 48 divided by mass of the body is m, G value is G, and what is L value? L value is L by 4. Now do this total calculation. That is my required answer. Mass must get cancelled, and one L and another L also get cancelled. Remaining calculation you do it. Clear number? That's it. Last concept in simple harmonic motion is torsional pendulum. See ma here. So this is some metallic wire or any wire which has some torsion. Torsion means what? See ma, if I pull the string, tension will develop. No? If I pull any string, tension develops. Similarly, if I rotate a string, torsion develops. Understood? No? Okay, wire ni baga chuttu unnaru anukondi. Again, if you release this one, it will try to regain its original shape and size. No? That is called as the tension which is developed in rotational motion. You can call it as torsion. Clear? No? So torsional constant of this string, let it be K. What is K here? K is called as torsional constant. Clear? No? So what I am doing, I am rotating this disc or any mass continuously. I am rotating this one. Then some amount of torsion will develop in this wire. Now if I release this one, again it will try to rotate now. It will come to the mean position. So by the time it reaches the mean position, its angular velocity will be maximum. Just like in previous SH. By the time body comes to the mean position, its velocity will be maximum. No? Here this is a concept of rotation. No? So rotational velocity will be maximum. That is angular velocity will be maximum by the time it reaches to the mean position. So it cannot stop at the mean position. It will again continue to rotate. Are you able to understand? So it means now torsion develops in opposite direction. Clear? No? So like this continuously this also starts performing rotational SH. Understood? No? So therefore if I rotate this one, in this if I rotate this one and if I release, then this body will experience this much amount of torque. So torque is equals to K into theta. Okay? And one more equation for a torque is I into alpha. No? I into alpha. So therefore what is alpha value? Alpha value is equals to K into theta divided by I. Okay? Or you can write K by I multiplied by theta. Okay? So this you compare with angular SHM. What is angular SHM? A is equals to omega square into theta. No? So if you compare both of them, what is omega here? Omega is how much? Omega is root K by I. This is the omega value. No? So once you know omega value, you can calculate time period, 2 pi by capital T. So therefore capital T is how much? 2 pi divided by root K by I. So it is 2 pi root I by K. Okay. So this is the equation for a time period of this oscillation. If I twist this one by small angle and if I release this. See my here also in this formula, this time period is independent of theta. Clear? No? So what is the angle by which how much you are rotating? Time period doesn't depend on that. Time period depends on only what? Depends only on moment of inertia of this body and torsional constant of this thread. Understood? No? That's it. So this is our concept which is